Hi guys, welcome back with another video. So guys, in this video, I'll be talking about some data collection strategy you can follow whenever you are working with large language model. Let's say you want to fine tune your large language model, or let's say you want to train any kinds of large language model from the scratch, right? So for this, definitely you need the data, because we know that LLM is all about data. So here you need massive amount of data. Now where we can get these are the data, I'll try to talk about it. Okay, so there is a possibility, let's say whenever I'm talking about data acquisition. So let me just write here, data acquisitions. Okay, acquisitions, you can also call it as data collection. Okay, it's up to you. So there is a possibility you have available data. Okay, available data. So available data means, let's say you have some files. Let's say you can you might have CSV file, you might have TXT file, you might have docs file. Okay, you might have PDF file, then you might have Excel SX file. Okay, and so on. So if you have, these are the files available with you, so we can call it as a available data. So if you have the available data, so no need to worry, just try to take the data and try to do some pre-processing and use the data for your training purpose. Okay, and then there is another possibility, you might have other data. Okay, what is other data? Other data means, let's say this data is available in the database, or let's say it is available over the internet. Okay, internet, or let's say it is available inside an API, and you have to use the API and you have to get the data. And you can also scrap the data. Okay, scrap. So scrap means, let's say this data is available over a website, and what you can do, you can perform some web scraping operation and you can scrap the data. Okay, it is also possible. So I'll also show you some demo, okay, how we can scrap the data, whether it's a text data, whether it's a image data. I will also discuss about it, how we can scrap these kinds of data. Okay, now there is another possibility, you have no data. Okay, no data means you don't have any kinds of data. Then that time what to do? Okay, that time what to do, that time you can create your own data. Create your own data. So maybe you can survey. Okay, you can manually collect the data. Otherwise, nowadays I have seen like people are using large language model for generating the data. LLMs is generating the data. Okay, generating data. So you can also utilize large language model for generating synthetic data. Okay, I'll also show you some practical demo, okay, how it can be done. So yes, guys, so these are some actually possibility you will be getting whenever you are doing the data acquisitions. So the first thing, you might have available data. Okay, then second thing, you might have other data, like data is available over the internet APIs, or you have to scrap the data. Then you have the no data, so that time you have to create your own data. Either you can use the large language model to generate your own data. Okay, great. So now let's say whenever we are collecting our own data, so there is a possibility you will be collecting very less amount of data. Let's say here we are following the this particular approach. Okay, we are collecting our own data. So whenever we collected our own data, let's say I need actually, let's say 1000 data just for the demo. Let's say I need 1000 example, and I'm able to collect, let's say 800. Okay, 800 example I'm able to collect. Now what about like remain 200? Okay, remain 200, how I can get this remain 200 data? Okay, for this what I can do, guys, I can use something called data augmentation technique. So there is a concept called data augmentation. Okay, augmentation technique. So in data augmentation technique, what we do, we just try to increase the data. Okay, by referring our original data. So let's say here I'm talking about the textual data, text data. Okay, text data. So text data, actually how I can increase? So there are some actually technique you can follow. Let's say the first technique you can follow, called replace with uh synonyms. Okay, let's say here you have one sentence, I am a data scientist. Okay, so this thing you can convert like that, I am a AI engineer. Okay, so here you can see I have changed this particular term. Okay, but at then meanings are same. Got it? So this is called replace with synonyms. Then you have something called bigram flip. Okay, bigram flip. So what we do inside bigram flip, so let's say here I have a sentence. I am Bappi. Okay, so here what I can do, I can do the flip like that. Bappi is my name. Okay, so then meanings are same. Okay, meanings are same, but you can see I have flipped some bigram. Okay, I have flipped some words. So this is called bigram flip. Okay, then you have something called back translation. Back translation. In back translation, what we do, let's say I have a English data. Okay, English language data. First of all, I will try to convert to the any other language, let's say French. Okay, then what I will do, I will take the French data. Okay, then again I will try to convert to the English. So here we are doing the back translate. Okay, so if you do the back translate, you will see that some of the words will be changing. Okay, so here you can use this particular approach as well. Then you can also add some additional noise. Add additional noise to your data. Okay, so let's say here I have one sentence called I am a data scientist. Okay, I love to work here. Okay, so here you can see this particular part I have added as a noise to my data. Okay, uh, I've added to the noise to the data. So that's how you can actually do the augmentation and you can increase your data. Okay, I hope it is clear, guys. So yes, these are the actually strategies you can follow whenever you are doing the data acquisitions. And let's see some demo like how we can perform web scraping, how we can generate our synthetic data with the help of LLM. I think, and then this part would be more clear. So yes, guys, this is all about. I hope you got it. Thanks for watching. Hi, guys. Welcome back with another video. So guys, in this video I'm going to show you the web scraping part. Okay, so how we can scrap different kinds of data from any kinds of website. So here I'm going to show you two kinds of scraping. One is like our text data scraping, and another one is our image data scraping. Okay, you can see I have kept two website. So here you can see I have data inside this particular table. So let's say I want to extract all of the data. So how we can perform it. Then there is another one called image. Okay, so you can see this is another website. So here I have different images. Okay, you can see different images are there. So if I need, these are the images, so how I can scrap it. Okay, so both example I'm going to show you. I think after that you will be able to scrap any kinds of data. Okay, and see, whenever you are doing the fine tuning and whenever you are creating your own data, that time this scrapping is super important because data are available all over the internet. Okay, and if you open any kinds of website, you will see the data. So definitely if you need any kinds of data, so you have to know how we can scrap out the data because they won't be giving you the API. Okay, so for this what are the strategy you have to follow, I'm going to show each and everything. So first of all, let's try to see how we can scrap this table from this particular website itself. So from this I'm going to open up my Google Colab, uh, and let's get a new notebook here. Okay, so here I can name it as text scrapping, and now let's connect the notebook. And to scrap the data, guys, I'm going to use one amazing library from Python called Beautiful Soup. So if you see Beautiful Soup, it is designed for scrapping purpose. So it has actually different functionality. With the help of that, you can easily scrap the data. So first of all, let me import Beautiful Soup. Okay, so here, this is my Beautiful Soup. Okay, if you're using Google Colab, you don't need to install it because it is already available. But if you're using local computer, that time you can install it. Okay, it is available in PyPy. Beautiful soup py. Let me show you. See, this is the like beautiful soup package. You have to install like that. Pip install beautiful soup, and you have to import like that from BS4. Import beautiful soup. Okay, and to send the request to this website, I need another package called request. So let me also import that. Now let me import all of them. Now let me define the URL, guys. So this is the URL. You can see I just copied the URL, and here is the URL. Okay, so first of all, we'll try to send the request to the URL, and make sure URL request, okay, the sending, the response should be 200. Okay, otherwise you won't be able to scrap the data. So let me show you the page. Okay, now see, response is 200. That means we are able to successfully send the request. If it is 404 or any other number, that time actually request is not successful. Okay, they are blocking your let's say request. Okay, so make sure it should be $200. Now whatever response I'm getting, guys, I'm going to pass to the beautiful soup. You can see I'm passing it to the beautiful soup, because if I show you the page.txt, okay, the page.txt, it's a HTML content. So I can come here, let's say if I do like that, let's say view page source, you'll be able to see that it's a HTML content. Okay, and inside that I have all the data, let's say whatever table I showed you now here. So all the data are available inside this particular HTML content. From there I have to scrap the data. So guys, how we can do it with the help of this beautiful soup, we can easily perform that. And let's say if I want to only extract this particular table, so how I can let's say navigate to the table. So for this you can go to the inspect and click here. Okay, you can see element, and now you just click here. Okay, let's say I need this particular table. Okay, you can see this table is available here. Inside the table you have all the content. You can see, you can hover. Okay, and this is the table. Okay, you can see this is the table tag. So that's how, guys, I can navigate, and I can extract any kinds of content I want. Let's say I need the second table, so just below there is another table, this one. So maybe you can click here. Okay, you can see I can click here. So this is another table. Okay, that's how this is another table. So this website is having 3 table here, but I need the first one. Okay, so that's why I'm hovering on top of the first one. Okay, now let's scrap the data. So again I will go back here. Now let's say whatever page content I'm getting, I'm passing to the beautiful soup, and this is a HTML let's say content. Okay, that's why I'm mentioning it. Now once it is done, now if I show you the soup, you'll see that you got the entire HTML content after refining. Okay, all the HTML content. Great. Now guys, what I will do, I'm going to find the table, because here I showed you all the data are available where into the table section. So let me show you. So I think here in the table section it is available. So yeah, table section. So I have to filter out the table. So what I can do, I can write like that. Uh, find all table. Okay, soup dot find all table. So it will return me all the table you have inside this particular uh, website. Okay, so here how many table we have? So let me show you. We have 3 table. We have 3 table, you can see, but I need the first one. Okay, I need the first one. So here I'll try to extract the first one, guys. So let me extract the first one. So this is the first table, guys. Okay, I'm taking the first one. Now if I just show you, so you can see this table is having rank, industry. Okay, let me show you rank, industry, name. Okay, so these are the thing. So that means I'm able to get the first table. Now what I need, guys, I need the um I need the content of the table. So if I show you this class is sorry, this table is present inside this particular class. So let me show you. mm, so you can see table, table tag. Where is the table tag? Yeah, so you can see, guys, this class table tag class is wiki table, sortable. Okay, this particular class it is available. So what I will do, I'll only try to extract this particular class. So here I can write like that. So soup.find table, wiki table, sortable. Okay, now you can ask me why not this particular line. So here some more content was available. In the table. jQuery table sorter. Okay, so this thing you don't need to give, only you just need to give the first one. Okay, this one. Now if I execute, now see guys, I'm getting the table. Now what I need guys, I will first of all store the table inside a variable, the first table, then I will do all the operations. Okay, so this is my first table. So here first of all let's try to find all the titles. Okay, all the title name. Now if I show you, the title is available here. Hmm. So title is available in the th tag. Okay, you can see th tag, all the titles are available: name, industry, revenue, okay, employee, and so on. So let me extract all of the title. So here I will give th, that means the title, so it will give me the title. Okay, I'm getting all the title, but here some tags are coming. I don't need the tags, so I will do some cleaning operation. So this particular code will try to clean. I'm doing the strip operation. Now if I show you, after that you will only get the table name, sorry, the column name. Okay, this one. Now with the help of that I'll try to create a pandas empty data frame, because later on I'll insert the data. Okay, after extracting, after scraping all the data. Now let me create a empty table. Okay, with the help of this column name. Now this is our empty table. Okay, now here what I need guys, because if I show you here, so let's say I need, these are the row. Okay, and where it is available in the, you can say td tags. Okay, in the td tags it is available. Td means it's a table data. Okay, you can see it's a table data. Okay, all the table data it is available. So what I can do, I can extract the td tags, that means the table data, and I can run a for loop, because here I have multiple rows, right? So it will go through all the rows and it will extract all of the data and it will insert one by one to the empty table. Okay, for this I have written a for loop here. So guys, this is the for loop I have written, you can see. So here what I will do, okay, the first thing I have to take the column data, okay, row wise. So here if I show you, it is available in the tr tags. Okay, if I see, let's say if I click here, so this data is available in the row. Okay, this is the first row. Okay, this is the first row, then this is the second row. That's how you can see the tr tags, right? Tr means table row. First of all I have to take all the row. So how to do it? So here I can call like that, table.find tr, so it will give me all the table row. Let me show you, all the table row you'll be getting. Okay, now we'll try to loop through the row and we'll try to extract the table data. Okay, and the data I'll be getting, we'll try to do the stripe operation, because some tags would be there. Then we'll try to insert to the empty table. Okay, now let me execute. Done. Okay, now if I show you my df, now see guys, my data has been stored to my empty data frame. Now easily I can save this data as a csv file. Okay, so let's say compile.csv. Now if I save, now see, you have successfully saved the csv file here. Okay, now if I open it up, see, this is your data. So guys, that's how we can do the web scraping operation if we want to scrap any kinds of text data. Okay, now we can use this particular data for your fine-tuning purpose. Now let's try to see how we can scrap these kinds of image data. Okay, let's say whenever you have the image data, how we can scrap it. So for this, what I can do, I can create another collab file. Or maybe instead of creating multiple collab file, I can do in the same collab file. Okay, that would be fine. So this was the text scrapping. Let me comment here. Now we'll try to scrap the image data. Image data scraping. Okay. Hmm. So for image data scraping, I'm going to use this website. Okay, so here you have different images, so let's try to scrap the data, and same process. Okay, the process I showed you, same process you have to use. So again, let's import some necessary library. So I need, guys, these are the library operating system request. Okay, a beautiful soup again I'm going to use, and URL join from URL lib. So ways I need to create the folder, because in the folder I'm going to scrap all the images. Request for sending the request to the URL. Beautiful soup for all the, let's say, refining and let's say to get the response from the website. And this URL parse, because I want to join the image URL, so that's why I need that particular function. So now here let's write a function. So I'm going to name it as scrap images. Okay, so it will take the URL and it will take the folder name. So in which folder you want to save those images. Okay, folder name is equal to, let's say I'm going to define as downloaded underscore images. This is my folder name. Okay, now inside that first of all we'll try to create the folder. So with the help of operating system, I can easily create make directories folder. It will be created. If it is exist, it won't be creating. Okay, so once it is done, I'm going to send the request to the URL. Okay, the URL user will assign. I'll try to send the request. Okay, now let me define the URL here. So here what I can do, let's say this is our URL. So what I did, I copied the entire URL. Okay, and here I pasted it. Now this should be scrap images. Okay, now see if I execute and if I print the soup, see it will give you the HTML content. Okay, now if I show you, so if I go to the view page sources, see this is the HTML content, and here you have all the image URL. Okay, so these are the image URL I have to at the end download. Got it? Now if I want to navigate to the image, so what I can do, I can do the inspect, and now I can activate it. Now let's say I want to see this image. So see this image is available here, okay, in this particular image tag, and this is the URL of the image. Okay, so again I'll be following the same approach to scrap the image. So let's come here. So what I will do, so after getting the response, I'm going to find all the image tags. Okay, soup.find image. Okay, so it will return me all the images, and how many images I got here. So let me execute. So total 26 image I got. Okay, in this particular page. Then after that we'll try to make a for loop. Okay, let me show you what this for loop will do. Very simple code. See, so here I make a counter, then I'm running a for loop. So it will go through all the image tags. Okay, then it will scrap the image. That means if I show you, this URL is available in the source src. You can see src. So I'm scrapping all the src. Then I'm checking if it is not a image URL, then continue. And if it is a image URL, so first of all it will make the URL. Okay, URL plus your image URL. Then after that it will download the URL. Okay, you can see request.get full URL. It will get the content. After that I'm saving that particular image, okay, inside the folder. I'm taking the name, then I'm saving inside the folder. Then you can see I'm saving the image. First of all I'm making the path of the image, then I'm saving to the folder, okay, with the pub with open. Then I'm increasing the counter. That means it will run 26 times. That means how many images you have in the website, it will run that many of time. Then I'm printing a message downloaded images. Then if any exception is going on, I'm also raising the exception, because I'm running everything in the try except block. Okay, now after downloading all the images, I'm showing you total number of image count. Now if I execute, see it will download all the images from the website. See, it is downloading one by one. Done. Now if I come here, if I go to the folder, now see all the images it has downloaded from the website. Okay, amazing, right? All with the high resolution image it has downloaded. Now we can use these are the data for training our LLM. Okay, So yes, now you can use any kinds of website, guys, and you can scrap the data. Okay. So yes, guys, this was the scrapping part. I hope you got it, and that's how you can scrap. And make sure, guys, you are getting 200 response whenever you are doing the scrap operation. So all the resources I'm going to share, you can also try. With that, thank you so much, and I will see you in the next video.
So guys, as you can see, this is the notebook I already prepared. So here you can see I'm using one dataset from Kaggle. So let me open the link. This is the link. So the dataset name is IMDb dataset, and it is having actually 50k movie reviews. Okay, 50k actually movie reviews. If you are already from, let's say, machine learning, deep learning background, I think you know about this dataset, right? It's like very common dataset. And why I took this particular dataset, because in this dataset you will see there are so many actually unnecessary text. Okay, because it's a movie review. So what they did, actually they extracted, they scrapped this data from the IMDb website. If you don't know, this is the IMDb website, IMDb. So in this website you will see all the movies reviews and rating. And what they did, actually they published this dataset in the Kaggle website, so that if anyone is working in the field of, let's say, generative AI or natural language processing, they can use the dataset. Now here what you just need to do, you just need to download this data. Okay, it's around I think 27 MB. Just click on download button, it will download. Okay, so I already downloaded this dataset, so it is available inside my download folder. So I'm going to upload in my Collab notebook. So here, first of all, what you have to do, you have to connect this particular notebook. So there is a connect button, just try to connect. And no need to worry, I will also share this notebook link in the resources section. From there you can open it up. So my notebook is connected. So first of all, let's import some of the library. First of all, I need something called pandas, because if you see the data, it's a CSV data. Okay, it's a CSV data. So let me upload and let me show you. So if you want to upload anything in the Google Drive, just try to right click and there is an upload button. Click on upload and try to upload this data here. Now see, it's a CSV file. Okay, and if I want to load any kinds of CSV file, JSON file, or let's say Excel file, whatever file, you can use the pandas package for that. So you can see my dataset is uploaded. Now if I want to load the dataset, what I have to do, I have to assign the path. And see, you don't need to execute these are the code, because this code I have added. Let's say if your dataset is available in your Google Drive, that time what you have to do, you have to mount your Google Drive. First of all, mount means you will be connecting with your Google Drive, then we'll be relocating the folder. Okay, like inside which folder you kept your data. Okay, with the help of cd command. CD means change directory. Okay, then after that what you will do, you will assign the data path. But here I haven't kept my data inside my Google Drive, I kept inside my Collab. Actually you can see drive. This is the Collab disk I am using. Here you will get around 74 GB of space. So here you also can keep your data. So I don't need to execute this code. What I will do, I'll just go below, and if I check my current working directory, that means pwd, you will see I'm inside content. Content means this is the directory right now. Now here I'll just simply define my data path. So I'll copy the path, copy, and let me paste it here. Okay, that's it. Now let me execute. Now see, if I now load the data, pd.read csv I'm doing. So now see, it will load the data. See, it has loaded the data. If you want to see the shape of the data, this is the shape. Okay, you have around 50k actually movies reviews in this particular CSV file, and two columns. Two columns means one is the reviews column, another is like the sentiment column. Okay, sentiment means whether it's a positive sentiment, whether it's a negative sentiment. This kinds of sentiment you will get here. I hope it is clear. Now see, here I'm having 50k movie reviews, but here I'm not going to use all the reviews. Here I'm going to show you the demo, like how we can perform the text pre-processing. And if I'm taking all the 50k reviews, so it will take like lots of time to process those are the text. So what I will do, I'll only take the 100 example. Okay, the first 100 example I'll be taking, and on top of that I will perform all the text processing task, right? So this is the code you can execute. So it will load 100 example. Now if I show you the shape, see, now we are having 100 example and only two columns. Fine. Now if I want to show you the data, see, this is the data. So first thing we'll be learning how we can perform the lowercase operation, and why lowercase is important I already explained here. I think you remember. Let's say if one of the name is containing uppercase character, it will consider these are actually separate name. Okay, these are actually separate entity. That is the idea. So that's how we have to bring everything in a lowercase character. So that's how you have to apply this lower operation. And how to perform lower operation, I think you already know. In Python we are having a function called lower. With the help of lower also we can do it, right? Now see here, let me show you one example. Let's say I'm taking the reviews 3. So here I'm taking the three number rows. This is the 3 number rows. Now you can see some of the Character is uppercase character here. So this is uppercase, this is uppercase. Okay, so that's how actually you will see different uppercase character would be there. Now if I want to make them lowercase, what I have to do, first of all I have to select my column, like in which column you have to apply the lower function. I have to apply on top of my review column. Now first of all I'm converting everything to the string. Okay, string data type, then I'm applying the lower, because lower is a string method. Okay, lower is a string method, I think you already know that. Then whatever changes actually I'm doing, I'm saving inside my column. That means I'm just doing the permanent change, okay, inside my column. So that's why I've given a review again. That is the idea. Now if I execute, now see, if I show you the data, now see guys, all the character has become lowercase right now. Now if I want to show you the, now if I again execute that review 3, you will see that all the character has converted to the lowercase character. Okay, that is the idea. Now the next thing we'll be learning how we can handle the HTML tags. That means how we can remove the HTML tags. For this, here I have written a function. Here I'm using something called regular expression, regex. Okay, so inside regex you can give a pattern. That's, let's say here you are giving a pattern. If you are getting this kinds of symbol, okay, if you are getting this kinds of symbol, it's a like HTML tag. You have to remove those HTML tags and you have to replace with empty. Okay, empty string. That is the idea. Now this is the function we can use. Now if I execute, now let's say this is a one text I have prepared. You can see in this text actually we are having lots of HTML tags. Now if I pass this particular text to my function, see, it will automatically remove all the tags. Now see, I'm only getting the text, okay, relevant text. That is the idea. So this notebook I prepared in such a way so that you can use it as a template. Let's say whenever you need anything, any kinds of functionality, you can come here, you can copy those functions. So please try to keep this particular notebook with you, because this is going to help you a lot. Okay, whenever you'll be developing the projects, this is going to help you a lot. Now if you want to apply on top of the entire data set, again just call this column name, let's say review column. Okay, and there is a function called apply, and inside that just try to pass this function. Okay, apply function takes actually one function object. Now here I'm giving the function object. So what it will do, it will try to apply this particular function on top of the entire rows you are having in your data set. Okay, now see, if I execute, and the changes actually I'm doing, I'm saving everything permanent. Okay, now let me execute. Now if I show you any kinds of random, let's say rows, now you'll see all the now let's see if I also show you 7, okay, 7 number rows. Now just try to see, there is no HTML tags in this particular text. You can pick up any kinds of, let's say index. So let's say if I show you the 10, nowhere you will see the HTML tags here. Now we'll be learning how we can remove actually URL. Let's say if you are having some URL in the text, how we can remove it. For this again I'm using regular expression, and there is a pattern I have given. If you are getting this kinds of, let's say a word http then slash then www, that means it is a URL and you have to remove the URL with the empty string. Okay, this is the function. Now let me execute. Now here I have just mentioned some of the URL. So this is my YouTube channel URL, this is my LinkedIn URL, and google.com and kaggle.com. Okay, now these are the text I have prepared one by one. Now let's say if I'm passing any kinds of text inside my remove URL function, it will remove that URL. Let me show you. See, I'm giving the text to, that means my LinkedIn URL. Now you can see, check out my LinkedIn. I hope it is clear. See, again I'm telling you, it's not a mandatory things. Let's say you need URL in your data, at that time you can keep it. Let's say you need actually HTML tags, you can keep it. But if you don't need it, you can remove it, because I already told you nowadays actually we are having advanced generative AI application. It also supports all kinds of text like emojis, HTML, okay, everything it supports. So if you are creating this kinds of advanced, let's say application, that time you need these are the data, you don't need to remove it. Okay, but sometimes actually you also need to remove this data set. So that's why I'm showing you how we can remove it, and if you want to keep it, you can also keep it. It's up to you. Okay, you have to decide based on your project architecture at that time. This is the idea. Now we'll be learning how we can handle the punctuation. So if you want to see the punctuation, so there is a string package you can use. Now if you just write string.punctuation, you will see all kinds of punctuations are available. Now what I have done, I just stored these are the punctuation in a variable called exclude. Now here I have written a function. Okay, here I have written a function called remove punctuation, and here I have written a for loop. So I'm just looping through this punctuation one by one, and user is giving the text, and I'm just checking whether if there is any punctuation. Okay, I'm just replacing with the empty string. Now let me show you how it will work. Now let's say this is one text string with a punctuation. You can see there are so many punctuation I have assigned. Now if I pass this particular text to my punctuation functions, it will remove the punctuation. Now see, there is no punctuation right now. Even I'm also calculating the time, like how much time it is taking to remove the punctuation, because there is another way you can follow to remove the punctuation. I'll tell you how you can do it. See, this is the function, guys. So here you can use something called text.translate. Inside that, just try to use this particular function. Okay, make translate, and inside that, just try to mention the punctuation. So what it will do, it will take your text and it will remove all the punctuation. So this is another approach. Now see, if I calculate the time of this function, you will see that this is the time. That means this function is taking less time than your this function, because here you are using one for loop, and for loop has the linear time complexity. I think you know that. If you are familiar with DSA concept, I think you know that it is having linear time complexity. Okay, so this particular approach is good. So let's say if you are applying this particular logic on top of 50k data set, just try to think how much time it will take this for loop. And in other hand, if you are using this particular method, it will take very less time to perform the operation. Now, if you want to see the time difference, you can also see the time difference. Now, if I show you my text, now see, inside this text, actually, I'm having lots of punctuation. Now, what I will do, I will use my remove function one, that means this particular function, and inside that, I'm going to pass my entire review. Now, see, it will remove the punctuation. Okay, see, all the punctuation has been removed. Now, you can also pass the entire data like that. You can also pass the entire data. It will remove all the punctuation inside your entire data. Now we'll be learning how we can handle the chat conversation. See, sometimes whenever we perform the chatting operation, we give like lots of shortcut. Let's say if I want to write as far as I know, what you will give? You will give AFAIK. Then let's say away from keyboard, AFK. Then as soon as possible, ASAP. That's how we use lots of chat keyword. Okay, we use lots of chat shortcut keyword. Okay, here I have listed down some of them. You can see for your information, FYI. So that's how I have listed all the chat conversation short word. Now let's say you are working with actually social media dataset. In the social media dataset, you will see these kinds of data a lot. People will be using short form. Okay, short form. So how we can handle this particular short form? For this, first of all, try to create a dictionary like that. The entire dictionary you have to create. Then after that, here I've written a function. So this is the function chat conversation handle. So inside that, I'm just taking the text. Okay, I'm just taking the text and I'm checking. And inside that, with the help of this for loop, I'm checking if we are having these kinds of word. Okay, if you're having these kinds of word, what we're doing, we're just mapping with the value. That means, let's say, if anyone having actually this particular, let's say, a shortcut word, let's say FYI. What I will do instead of FYI, I will just return for your information, because this is a dictionary. If I want to get the value, I want to call the key. Okay, that's how we are mapping. Now see, if I execute the program, now let's say here we are giving a short message. Do this work ASAP. Now see, it will return me do this work as soon as possible. Okay, because here it is coming here and it is mapping and it is giving me this value. Okay, this is the idea. Now let me see how we can handle the incorrect text. Let's say sometimes what happens whenever you are using real-time data, there would be lots of spelling mistake, right? Let's say this is one example, certain spelling is not correct, then condition spelling is not correct. That's how you'll see different word is having the spelling mistake. So how to handle this spelling mistake? For this, you have to use one package called text blob. So let me import this text blob. And now see, here I'm having my incorrect text. Now if I pass this incorrect text to my text blob, and if I call this particular function called correct, now see, it will handle everything. Now see, certain conditions during several, see, all the word has been corrected. So this is one amazing package you can use if you want to handle the spelling, okay, spelling of any word. Now the next thing we'll be learning how we can handle the stop words. So inside English language, not only English language, inside all kinds of language, we're having some stop words. Okay, now here we're working with the English language. So let me show you some English related stop words. For this, I will be importing stop words from the NLTK. NLTK is nothing but it's a natural language toolkit library. So with the help of NLP also, you can perform lots of NLP related tasks. So here you can see I'm importing the stop word. So here I'm performing nltk.download. It will download all the stop words from the internet. Now see if I click this cell, it will download the stop words. Now if you want to list down all the stop words, you can just write stop words, and here you can specify the language. So here I'm working with the English language. So here I've given the English. Let's say you are working with Hindi, Bengali, you can give that language also. It will give you the stop word related that language. So you can see the documentation of NLTK. We'll see that how we can pass the parameter here. Now see, these are the words we are having inside English. So this is called stop word. So this word doesn't have any kinds of meaning, okay, in a sentence. Okay, we use it to represent one sentence, but there is no meaning. So let me show you why I'm telling there is no meaning. Let's see if you want to perform sentiment analysis. So let's say there is one review we are having. So let me just write, this movie is awesome. I loved it. Now just try to see here, you are having some stop word, right? Like is there, this is there, I is there, it is there, right? But if I want to get the sentiment of this particular let's say reviews, I can see movies is required, awesome is required, loved is required. Now if I'm getting these kinds of word, actually this kinds of positive word, that means it's a positive sentiment. Okay, it's a positive sentiment, yes or no, right? So here actually I don't need these are the stop word. Okay, I don't need this as the stop word to understand whether this particular reviews is a positive or negative. And if you're using these are the stop word in the sentence, what will happen whenever you will perform the text vectorization, it will make actually extra dimension. Okay, it will make the extra dimension in the data. And whenever it is making the extra dimension, that means if dimension is increasing, that time your model might get difficulties, right? Because we know that there is a concept of curse of dimensionality. So we always need to reduce the dimensionality somehow. I think you have learned in your machine learning. Okay, machine learning, let's say, topic. So that is why we don't need these are the stop words. So we have to remove this particular stop word sometimes. And sometimes actually we have to also keep it. So these are the stop word, guys, you saw. Now let me show you the length. So around we are having 179 stop words present inside English. Now here I've written a function. So this function will remove the stop words from a text. Now let me show you. Let's say this is a text I have given. So inside that you can see different stop words are there. Now if I pass to my function, so see, now see, there is no stop word in this particular text right now. Okay, that's how you can use this particular function. Now again, this is my data. And if I want to apply on top of my entire reviews, I can do it. I can use the apply function and I can pass my function object, remove stop words. And if you want to store permanently, what you can do, you can write this code. Okay, df reviews is equal to df reviews apply stop words. Okay, it will save everything permanent, but I don't want to save it permanent as of now because I'm showing you as a demo. If you want to do the permanent, you can do it. So now guys, I think it is clear how we can remove the stop words. Now the next thing we'll be learning how to handle the emoji. Okay, see, emoji is nothing but it's a Unicode actually character. Okay, if I show you, if you just write emoji Unicode, you will see different Unicodes of different emojis. So let me open it up. See, here we are having different emojis. Based on that, we are having the Unicode. Okay, Unicode character. Okay, Unicode character. So that's why I just collected some of the Unicode character, like for the emotions emojis, symbols, then pictographs. Then we're having transport, map, symbol, flag. Okay, so these are the emojis related Unicode I collected here, and I just written a function. Okay. And again, I'm using the regular expression. So here I'm telling if you are getting these kinds of Unicode in a sentence, that means it's an emoji. So what you have to do, you have to remove those emoji with the empty space. Okay, now let me show you. So let's say this is one text I'm giving. Love the movie, it was flying kiss. Okay, now see if I pass this particular text, now see it will remove the emojis automatically. Now this is the next one. Now see only Lamo is coming. Now sometimes actually I told you emojis are required. Because let's say I told you in the ChatGPT example. So if you pass any kinds of emoji to the ChatGPT, it will also able to understand, okay, what you are trying to say. Let's say if I pass any kinds of emoji here, let's say I'll give this emoji. Hey there, what's on your mind today? See, it is trying to understand my feelings, right? Now, if I want to handle these kinds of situations, what I have to do, I have to keep the emoji. That time, what I can do, I can extract the meaning of the emoji. So for this, I can use one library called Emoji. Okay, now let me show you. First of all, you have to install it. Now just import the emoji, and inside emoji you are having one method called demojize. Okay, now inside that just try to pass the text Python is fire. I'm giving the fire emoji. Now so it will automatically convert to the word Python is fire. Okay, that means it is trying to extract the meaning of that particular emoji right now. I hope you cleared. So that's how whenever you are passing any kinds of emoji as an input to the ChatGPT, it is trying to convert this emoji to the word and is trying to understand what you are trying to say. Now there is another example I have given. I love this movie, it was flying kiss. See, love this movie, it was face blowing a kiss. Now we'll be understanding the tokenization. I told you we are having two kinds of tokenization, sentence level tokenization and word level tokenization. So let's try to see. See, if you want to perform the tokenization, directly you can use the split function, because split also will give you the individual word in a list. See, if I have one sentence, now if I perform the split operation, see, I'm getting actually individual word. So with the help of split also you can perform the tokenization. So similar wise, you can also do the sentence level tokenization. This is the word level tokenization. Now for this, you have to mention this particular full stop sign. So whenever it is getting the full stop, that means this is one sentence. Okay. Now see if I execute. So here I'm having 3 sentences. So I am going to Delhi. I will stay there for 3 days. Let's hope the trip to be great. Okay, see 3 sentence I'm getting. So this is called sentence level tokenization. So again, some of the example with the split function. Now with the help of regular expression, you can also do the tokenizations. So this is one example I kept with the regular expression. So here is my sentence and it will give you the individual word. This is the sentence level tokenization. Okay. And this is the pattern for the word level. This is the pattern for the sentence level. Okay. This is the idea. Now you can also use something called NLTK. Okay. That means Natural Language Toolkit Library for the tokenization as well. Inside that, we are having two actually function word level tokenizer and sentence level tokenizer. Now let me, and if you want to perform the tokenization, you have to download this particular thing called PUNKT. Okay. This particular thing you have to download. Okay. Now see, here is my sentence and I want to perform word level tokenization. I will pass this. So it will give me the word level tokenization. So automatically this function will handle. Now if you want to perform sentence level tokenization, you can use send tokenizer. Okay. From here. And you are getting the sentence level tokenization. Okay. So again, some of the example you can try, I have given. And I created this notebook in a such a way you can use it as a template. I already told you. I have written like the function wise, right? If you need any kinds of, let's say, cleanup technique, you can copy from here and you can use it in your code. That's the idea. Now there is another package you can use called Spacey. With the help of Spacey, also you can perform the tokenization. Fine. So you can explore this part. Now let me go to the steamer. Okay. I already told you what is steamer. Steamer means you are trying to bring the different word in a root form. That means let's say you are having play, playing, played. So what you will do, you will apply steamer and you will just try to convert it is to the, and you'll just try to convert to the root word, that means play, right? Because it is meaning the same, okay, in a sentence. So now let me show you. So inside NLTK, we are having this steamer, porter steamer. Now we are importing porter steamer and here we have created the function steam word. So whenever you will give any kinds of, let's say, sentence, it will perform the steaming operation. Now see, here I'm giving works, walking, work. Now if I give this particular sentence, it will give me the root form. That means walk, and all. Okay. Now see, here I kept one sentence. So this is the entire sentence you can see. Now I want to perform steaming operation on top of the sentence. So I'm using my function inside that. I'm passing the sentence. Now see, it will give me the steaming word right now. Now see, probably it has been probable. Okay, probable. That's why I told you steaming is not readable. Sometimes you will get some kinds of word, it's not readable. But your model will try to understand. Okay. But as a human, it's not readable. See, favorite has been converted to favorite right now. Okay. So in case actually what you can use something called lemmatization. Okay. Lemmatization will handle this kinds of situation. It will give you a readable word actually. Now see, this is the lemmatization code. So it is available inside NLTK. I'm importing the lemmatization, initializing the lemmatization. And if you want to use lemmatization, you have to download these are the things, WordNet and OMW. And now if I execute this code, you will see that it will give you the lemmatization for all the words. See, so this is the word, this is the lemmatization, this is the word, this is the lemmatization. Now see, it's readable. Okay, it's readable. Then your steaming one. I hope it is clear. Fine. So that's why I just written steaming and lemmatization are same to retrieve root words, but lemmatization is worked good, lemmatization is slow, and steaming is fast because lemmatization will give you the readable output. That's why it's a little bit slow than your steaming. Okay, I hope it is clear. So yes, these are the technique you can follow for the text pre-processing. If you are having any kinds of text, you can perform text pre-processing with the help of these are the technique. You can clean up your text. Okay, and again I'm telling you it's not required to perform all the text cleaning technique. Sometimes if you need anything, just try to keep it as it is. That is the idea. Fine.
So guys, in this video, we'll try to understand what is chunking exactly and why it is required, and some chunking strategy I'm going to also show you. I'll also show you the practical implementation of chunking so that your understanding will be clear. So first of all, let's try to understand what is chunking exactly. See, I think you know that whatever large language model you are using, LLM, it has one input limit. Okay, input token limit. I can write input token limit. Okay, if you go to like any kinds of model, you will see the documentation, you will see that it has some input token limit. Okay, let's say one model is having input token limit is equal to 4096 token it can take, okay, at a time. And let's say whenever you are working with custom data, mostly in RAG, retrieval augmented generation, will be also working with that, okay, going forward. So in RAG, what happens, we'll try to use our custom data. And let's say I have one TXT file So after extracting all the data from the txt file, let's say my token size is 8096. So definitely it is bigger than, okay, it is bigger than your model token, model input token, right? So definitely we'll getting the input error, okay, from your model. So to prevent this kinds of issue, we use something called this one, chunking. Okay, we use something called chunking. Okay, chunking. So how chunking works for this? Let's copy our text. So I'll come here. So let's copy our text. I'll just write, let's say, Python. Let's copy something from here, and I'll come here. I'll try to paste it. Okay. So here, what I will do, so what happens, let's say chunking, there are two parameter. One is the chunk size. Okay, another one is chunk overlap. Okay, so let's say chunk size is equal to 1000 and chunk overlap is equal to 200. Okay, so whenever it will start the chunking, so first of all it will start from here. It will count 1000 tokens. Okay, let's say 1000 tokens ends here. So this is going to be your first chunks. Okay, then it will get the second chunks, but the chunks overlap is 200, so it will get back 200 word back, like that. Let's say 200 words ends here. Then it will again, it will count 1000 tokens. Let's say 1000 tokens ends here. So this is going to be your second chunks. Okay, so that's how again another chunk will start. Again it will go back 200 tokens. Then let's say it will ends here. Okay, 1000 tokens. So it is going to be your third chunks. Okay, that's how it will be creating multiple chunks. Okay, now to the model. Okay, to the model, instead of giving the entire document at a time, you'll be passing the chunks one by one. Okay, you'll be passing the chunks, first of all first chunk, second chunks, and third chunks. Okay, that's how you can reduce the chunks, I mean input limit error. Okay, so I think this part is clear. Okay, why chunking is important. So now let's try to see how we can perform the chunking with the help of LangChain. So for this I'm going to show you one practical. So guys, you can see this is the practical, and guys, this chunking strategy, it is the component of a RAG. Okay, whenever we'll try to develop the RAG, that time actually we'll be using that. So first of all, let's load the OpenAI API key. I'm using OpenAI model for that. And here in the data folder, I have one file called bgood.txt. Inside that, I have some data. Okay, so let me show you. So this is the entire data, guys. Okay, yeah, it's a bigger actually documents, you can see. So if you count all the tokens, it would be like more than your model limit. Okay, so that's why first of all, let's try to load with the help of text loader with the help of LangChain. Okay, we have loaded. Now you can see this is the entire documents. Now if you want to see the page content, this is the page content. Now we are having two kinds of chunking strategy. The first one is character text splitter, and the second one is recursive character text splitter. First of all, try to see the character text splitter. Okay, so it will try to do the chunking operation based on the new line. Okay, whenever it will get the new line, that time it will do the chunking operations. And here we have given the chunk size and chunks overlap. Okay, I think I showed you what is chunk size and chunks overlap. Okay, now let me initialize. Okay, now here let's say this is our documents. In that documents we have loaded. Now we have to pass inside this particular object. Now if I execute, now see it has created the chunks. So it has created two chunks actually. Okay, if my chunk size is 1000, so it has created two chunks. So if you see one of the chunks, so this is the chunks. Okay, now I can pass these documents to my model. Okay, now let's try to see the recursive character text splitter. So you can see it will do the chunking recursively. Okay, so you can see this is the objects I have created, and again chunk size and chunks overlap. Now if I do the split operation, now see multiple chunks I got because I have given very small chunk size. Now if I show you the length of the chunks, okay, here you got 815 chunks. Okay, you got. So guys, that's how we can perform the chunking, and these are the chunking strategy we have inside LangChain. And all the code I will share, you can also try from your side. So thank you so much. Hi guys. In this video, we'll try to see how we can generate the embeddings, because you know that whatever data we have, this is a raw data, and we can pass directly to the LLM. Okay, for this we have to convert it to the numbers. Okay, that means to the vector. And we also use something called vector database, and we also store these are the vector to the vector database. Okay, so for this we have to convert this text to the embedding. So I'll show you one demo how it can be done. So here again I'll be using LangChain. So here I'm using OpenAI embedding model. Okay, with the help of OpenAI embedding model, what I will do, I'll just try to generate the vector embedding. So let me import first of all this OpenAI embedding from the LangChain OpenAI. Now let's say these are my documents. Okay, English text. You can use your own documents. You can load your custom, let's say TXT file or PDF file. I think I already showed you. Okay, how to load it. Now let's define this particular text. Now I will pass this particular data to my embedding documents. Okay, that means to the embedding model. There is a function called embed documents. Now if I execute, I will see that your data would be converted to the numbers. Let me show you. It's executing. Now if I show you, see, this is your vector embeddings. Okay, now these embeddings I can store to the vector database. So you can see the length, even you can see the some of the vectors. Got it? So these embeddings actually now I can store to the vector database. In the next video I'll show you how we can store to the vector database, how we can create our private knowledge base, okay, with the help of that. So yes guys, this is the demo of the embeddings. I hope you liked it. Thank you so much. So guys, in this video we'll try to see how we can build our private knowledge base with the help of vector database. So here again I'm using LangChain guys. So first of all I am importing the data loader, then OpenAI embedding I need to generate the embeddings, then I need a splitter because I have to do the chunking operations, and I'm using ChromaDB vector database. So in the data folder I have one file, you can see called state of the union. Okay, this file. So we'll try to create the knowledge base on top of that. Okay, so let's try to do it. So here first of all I'm loading the documents, then I'm doing the chunking operation because I told you why chunking is required. Here chunk size is 1000 and chunks overlap I have given 0. Okay, so here I've done the split documents operation. Now if I see I have 42 chunks, okay, in total. Now we'll be creating the knowledge base. For this we'll be using ChromaDB vector database, and it's a local vector database. I think I already showed you the ChromaDB example. Okay, now we are doing the from documents, and inside that we are passing the chunks and we are passing the embedding model. Okay, and this example I already showed you. I already explained in my ChromaDB session why chunking is important. Okay, everything I already explained there. Now this has created my vector database. Okay, you can see it has created one object, okay, in my local instance. Now here you can do two kinds of search operation. One is similarity search and this is retriever. So first of all let's try to see the similarity search operation. So here let's say this is my question: what did the president say about the John Lewis Voting Rights Act? Because if you see the documents, we are having the content related that. Then we are doing the similarity search operation. We are passing the question. Okay, now it will return you the similar kinds of response, similar kinds of answer. Okay, see, it is not giving you any kinds of reference. But if I'm talking about retriever, okay, so retriever, what it returns, let me show you another demo. So first of all let's load the documents, then again we are loading the, you can say, content. We are doing the chunking, we are performing the splitter, we are loading the embedding model, and now we are using Fire's vector database for the embeddings. Okay, for the knowledge base. Now this is our vector database object. Okay, here I got one error, so I have to install Fire CPU. So let me do it. So here I already kept the requirement.txt file. Okay, you can install. So you can also add the Fire CPU there. Done. Now again re-execute. Okay, now this is my vector object. Now we are getting the retriever. Okay, and search keyword is equal to 3. That means it will return 3 relevant response. Okay, now this is the question I'm asking: what did he say about the Ketanji Brown's action? So see, it is returning 3 relevant answer with the source, okay, with the help of meta source as well. So this is the difference. So here in the similarity search, you are only getting the similarity, let's say, response, and you are also getting the meta source, okay, like which file it is suggesting, okay, and the page content as well. Okay, everything it is returning. Okay, you can see total 3 response you are getting. If it is 4, so it will return you 4 response that time. Okay, C4 response that time. Okay, so that's how guys we can create our private knowledge base. Thank you so much. So guys, so far we have seen how we can do the data acquisitions. I already showed you one practical demo of web scraping. Even I also showed you how we can pre-process the data. So now I will show you how we can generate the synthetic data with the help of large language model. Okay, so for this let's open up Google Colab. So here let's get a new notebook. So here I'm going to name okay, so LLMs to generate synthetic data. Okay, so this is the name. Now let's connect the notebook. Yeah, so first of all, here I'm going to install OpenAI. You can use any kinds of large language model. Okay, I'm going to use OpenAI for that. You can use Mistral, Falcon. Okay, you can use Gemini. Okay, it's up to you. So let's install the OpenAI here. So this is the command. Let me install. Then after that, we'll try to import the OpenAI. Then I will also import the operating system. Then I need pandas. Then I need string IO. So from IO, import string IO. Okay. So now what I will do guys, I'm going to set my OpenAI API key. So for this, just write OpenAI underscore API key is equal to. So let me pass my API key guys. Yeah, so this is my API key, you can see. So once my API key is set, so now we'll be writing a prompt. So here we'll be generating one sentiment analysis data. You can generate any kinds of data. Okay, you just only need to assign the prompt. So here I prepared a prompt. So this is the prompt guys, generate 10 rows of synthetic data for sentiment classification. Each row should have the two columns text, a sentence and the label positive or negative sentiment. Return the data as a CSV format with the headers, okay, text and labels. Now here just for demo purpose I'm generating 10 rows, but whenever you are generating for your actual task you can generate okay as much as you can. So this is our prompt guys, I have prepared. Now what I will do guys, I'll try to initialize my model. Okay, so let me just do it. So response is equal to OpenAI dot chat completion dot create. Okay, so inside that first of all we'll try to initialize the model. So here I'm going to use GPT-4 model, GPT-4. Then I'm going to initialize the message. So here just let me define the role, user. So user will pass the prompt, so it will be available in the content, which is nothing but my prompt. Okay, all right, so I think it is fine. Now let me give the temperature parameter. This is the creativity parameter, I think you already know that. Temperature temperatures is equal to, let's say I'll give 0.7. I want some creativity because we are generating the data. Okay, now let's initialize the model. Okay, so now what I will do guys, I'll try to take the data. So let's get a variable csv underscore text is equal to, from the response itself I'll try to extract the data. So from response choice I'll be taking the first index and messages content. Okay, yeah, so here you have the actual response from the LLM. Now once you got the CSV text, okay, so it is giving one error because it should be choices. Okay, not choice. I think it should work. Yeah, now let me show you the output. So this is the output, guys, I got. So what we have to do, we have to convert this thing to the pandas data frame. So let's do it. So df is equal to pd dot read underscore CSV. Inside that I'm going to pass this thing, but we'll first of all convert to the string IO because this is a string I'm getting. So let's do it. So string IO, inside that I'm going to pass my CSV text. Okay, now this will return your data frame. Now if you want to see the data frame, so df, let's try to print it. So guys, I got the data. You can see left hand side I have the text, okay, right hand side I have the label. Now you can use this data for your training purpose. Okay, if you're doing fine tuning or whatever you are using, you can use this particular data. Got it, guys? So yes, guys, this how that's how actually we can generate any kinds of synthetic data. Now let's say you need any other data. Let's say you need for the name entity recognition. For this you can give another prompt. So let me give another prompt here. So this is another prompt. Generate a 5 sentence with entities in font format. Text a sentence here, entities. Okay, you can see different entities. Entities should be person, organization, local, and so on. Okay, so that's how. If you need for the text summarization, just give text summarization. If you need for the language translation, give language translation. Only you just need to change the prompt. Otherwise, all the code will remain same. Okay, and that's how you can generate the data as much as you can. Okay, and definitely if you're using OpenAI, it has some cost involvement. You can also utilize any other model. Okay, it's up to you. So yes, guys, this is all about. I hope you liked it. Thank you so much. Hi guys, in this video I'll be talking about what is fine tuning exactly. See, whenever you are working in the field of generative AI, so I think you have heard of this name called fine tuning. So what is fine tuning? First of all, I will give you the idea and why fine tuning is required. I will also talk about that. See, fine tuning is nothing but, see, fine tuning. Okay, fine tuning. It's a process. Okay, process of taking a pre-trained model like GPT, okay, then Llama, Mistral, and so on, and adapting, okay, adapting it to a specific task, spe- specific task or dataset by continuing the training process on new data. Okay, so that means what you are doing here, you are tracking a pre-trained model, okay, and you are training that pre-trained model on a specific dataset for a specific task. Let's say I have taken a model called Llama. Okay, let's say Llama 2. I'm considering Llama 2. So now let's say I have very specific data. This is, let's say, my private data. Let's say I want to train for a what I can do. Let's say I want to train for a language translation. Okay, so what I will do, I'll take that data and I will take a pre-trained model like Llama 2. On top of that, I'll just try to do the fine tuning process. That means I will do some training. Okay, I'll do some training. I'll just I will adjust some weights. Okay, and this is called actually fine tuning. That means your model already knows about lots of things, right? And what you are doing, you are uh, giving some more information to the model, okay, by fine tuning that particular model. Okay, so this is called actually fine tuning. I hope you got it right. So see why this fine tune is required, because what happens, let's say whenever I have a specific like private data, and if I want to use my LLM, because if you go to the LLM and if you are asking anything anything specific to your private, let's say, information, it will not able to give you the answer, right? So definitely for this you have to fine tune. These are the model, and for fine tuning these are the model we use different approach, because at the end LLM is like very huge model. Okay, if you see, if I'm talking about llama, okay, llama is having different model. Let's say llama 2 is there, 3 is there. Okay, and if you see the parameter size, you will see like llama 70 billion parameter model is also available. Okay, that's how actually different kinds of models are available. And if you want to load this model to your machine, so you should have good configuration machine, at least some good GPU configuration you have, some RAM configuration you have, then you will be able to load this particular model in your system. But we don't have this kinds of system, so in this case actually we can use some cloud provider like Google Colab we can use. Okay, Colab we can use. Then we have some other platform like Paper Space is there. Okay, Paper Space is there. Then we have Data Crunch is there. Okay, Data Crunch is there. So that's how we are having different platform there. You can purchase a machine and you can load these are the model. But again, if you see fine tuning these are the model is not an easy task, because again you have lots of parameter. So for this we use some parameter efficient fine tuning process. We also call it as PFT. Okay, PEFT. So that means parameter efficient fine tuning. So for this we use some technique like LoDA. Okay, LoDA or QLoDA. So these are some actually, let's say, library we use for the parameter efficient fine tuning. That means at the end it performs something called quantization. Okay, quantizations operations. That means it will quantize your model. Instead of loading the very big model, it will perform the quantization, then it will load the model. Okay, I will more discuss about it, what is like PFT, what is QLoDA and QLoDA. Even I will also show you one practical demo of the fine tuning, okay, how it can be done. We'll try to pick a LLM and there I will show you the entire fine tuning process, guys. Okay, so yes, this is the fine tuning. I hope you got it. Okay, now in the next video we'll try to understand what is the difference between fine tuning and RAG, because there is another concept called RAG. With the help of RAG also we can also connect our custom data to the LLM. Okay, so yes, let's try to see the difference between fine tuning and RAG.
Hi everyone, welcome back. So guys, in this video we'll try to understand what is the difference between the RAG versus fine tuning, because many people has this question when we have to perform the RAG, when we have to perform the fine tuning operation, and what is the difference between them. So see, both technique actually we use to extend the abilities of the large language model. Okay, see, when you have to use the fine tune approach, when you have to use the RAG approach, let's say you are working in a very specific domain with some specific data, okay, and with some specific task. That time actually you can use something called fine tune approach, because whatever pre-trained large language model you will be using, it won't be having like these are the information. Let's say you are working in the field of medical, okay, medical domain, and there actually you are creating one bot. Okay, you are creating one medical, let's say, information bot. So this will give you, let's say, medical related information. And here you are using very specific data. Okay, so this data actually was not used during training of this large language model. So that time what you can do, at the very first time, you can do the fine tune operation. That means you can fine tune one pre-trained model and you can create this application. So let's say this is the application we created. Now user has given one question: what are the latest treatment for the type 2 diabetics? So whenever you train this model, so you provided actually these are the information. So the latest treatment for the type 2 diabetics include meditation like metformin, then lifestyle changes such as diet, exercise, and in some cases actually insulin therapy. So these are the information actually you have given during fine tune. These are the model. Now let's say there is a new treatment came. Now if you are asking the same question again to your, let's say, system, it will give you the same answer again and again, because it is already trained with your older data. Yes or no? So that new information actually it doesn't have, so it won't be able to give the new actually, let's say, technique for the, let's say, treatment of diabetics too. Now, in case what you can do, you can use this new information and you can create a RAG based application. So what you have to do, you have to use the same LLM model only, but you will be creating one additional knowledge base. I think I showed you how to create the RAG. So with the help of this data, you will be creating one additional knowledge base, and with that knowledge base, you will be connecting your medical bot. Then your medical bot will be able to give the response, okay, from the latest, let's say, technique, from the latest information, yes or no. Okay, now I think you got it, when we have to use the RAG technique, when we have to use the fine-tuning technique. Now see, here we are using RAG technique. Now if you're asking the same question, now here you will see that it will give you the recent treatment, okay, for the type 2 diabetics. Okay, the recent treatment, whatever actually it's came in the market. Okay, now I think this is clear, when we have to use the fine-tuning technique, when we have to use the RAG based technique. And again, fine-tuning is like more costly. So for this, you need huge amount of data. You need a good computational machine. That means you should have GPU, good configuration GPU, good configuration RAM. Okay, if you're not having this kinds of GPU, so you can't do the fine-tuning operation. That means in fine-tuning, you are retraining that model, you are updating the weights, right, which is not involved inside RAG. So inside RAG, actually, we are not training any kinds of model. Instead of that, we are creating an additional knowledge base. And with the knowledge base, actually, we are connecting our large language model. Okay, this is the difference only. Fine. Now, I think, guys, you got the clear-cut idea. What is the difference between RAG versus fine-tuning and when we have to use it. So even I will also show you how we can perform the fine-tuning operation. Okay, let's say if I want to create any specific task, how we can perform the fine-tuning operation out of our custom data.
So guys, in this video, we'll try to understand what is PFT, that means parameter efficient fine tuning. So see, PFT, just let me write PEFT. So the full form, parameter efficient fine tuning. Okay, fine tuning. So what is parameter efficient fine tuning? So see here, instead of updating all parameter, okay, parameter of LLM models like GPT, then we have Llama, okay, then we have Falcon, Mistral. We use PFT technique, PEFT techniques to modify only a small fraction, okay, fraction of the model, making it fine tuning faster, okay, faster and more memory efficient. All right, so guys, I think you got to know what is parameter efficient fine tuning. That means here, instead of updating all the parameters of the large language model, we use some PFT technique. Like we have some library like LoRa and QLoRa. I'll be also discussing about. Actually, it performs something called quantizations, and that's how you can reduce the model parameter, and you can fine tune this at the model, okay, with the memory efficiency and all. So now, why to use the parameter efficient fine tuning? Because in our traditional fine tuning, so let me write here, traditional fine tuning. So here we update all parameter, all model parameter, okay, then it requires lots of compute and memory, okay, then uh, not ideal for multiple domains. Okay, but whenever we're using our PFT technique, so here we update only a small, okay, small subset of the model, then works with limited compute, then easily support multi tasks. Okay, tasks. So yes, these are the like advantage you'll be getting whenever you are using PFT technique. Now in the next video we'll be talking about the PFT and LoRa and QLoRa. Okay, how it works exactly. Then I will also show you how we can perform the fine-tuning process with the help of this PFT technique. So thank you so much.
So guys, inside fine-tuning, you will be using one pre-trained model. Okay, pre-trained large language model. Okay, I think I already showed you there are so many large language models are available as open source. For this, you can go to the Hugging Face. So here you can see there are thousands of large language models are available. Now you can choose any kinds of model as per your requirement. Let's say you want to use something called Llama, Meta Llama. You can simply search Llama here. So we'll get see all the Llama model. Okay, Llama 2, Llama 3, all kinds of model actually will see that. See, okay, and this one Meta AI. Now what you can do, you can download this model. On top of that, you can fine tune your custom data. But before fine tuning, what you can do, see, first of all, let's say whatever, let's say project you want to implement. Let's say you want to implement one chatbot. Let's say you want to implement one medical chatbot. Okay, medical chatbot. First of all, use one pre-trained large language model and try to perform the inference operation. Okay, try to perform the inference operation. Inference on top of the model. If this model is able to give the correct answer, okay, if it is able to give the correct answer, try to select this model. Okay, otherwise what you can do, just try to build one RAG, retrieval augmented generation. Okay, that means create a external knowledge base, then try to connect your one pre-trained large language model and try to again perform the inference operation. Okay, and try to see the accuracy of the model. Try to see like whether your model is giving able to give the correct response or not. If it is giving, try to select this model. Okay, otherwise if this both approach is not working, that time what you can do, you can perform the fine-tuning operation. Okay, fine-tuning operation. So there what you can do, you can take one pre-trained large language model from Hugging Face, from any kinds of, let's say, platform, and on top of that you can train your custom data. The data set you are using, let's say you are using one very specific medical, okay, medical data. That time you can use this data and you can train one custom model on top of it. Okay, this is called actually fine-tuning, and that should be my suggestion, guys. I mean, directly don't do the fine-tuning. Before that, try to check whether pre-trained model is working or not. If pre-trained is not working, try to build the RAG based system. If it is not working, then try to do the fine-tuning. Okay, because fine-tuning is a more costly task at the end, because here you need like huge amount of data, even you need lots of computational power. You need actually higher configuration machine. Okay, you should have good GPU instance in your system, otherwise you can't do the fine-tuning operation. But if you want to do the fine-tuning operation, there is some way actually we can do it, because all kinds of large language model you can see, it is having actually huge parameter size. You can see Llama 2 7B, that means it is having 7 billion parameter. It is having 8 billion parameter. That's how it is having 70 billion parameter. Just try to consider. Okay, it's a huge size model, so we can't use any kinds of low configuration machine here to fine tune these are the model. So for this, what we can do, we can use something called PFT technique. We can use something called PEFT. Okay, what is the full form of PFT? Parameter efficient fine tuning. Okay, this is the full form of PFT. So inside this PFT, we are having some method we can use. So the first one, you can use something called LoRa, or you can use something called QLoRa. Okay, So this LoDA and QLoDA will help you to do to perform this parameter efficient fine tuning. That means it applies something called quantization technique. Quantization technique. Okay, that means it will load your model in a lower memory instance. That means it will load your model in a 4-bit precision, 8-bit precision. Okay, that's how actually it will perform the parameter efficient fine tuning process. Now you can ask me what is quantization then. Okay, let me show you what is quantization. See, quantization is nothing but quantization. It's just a way of converting from higher higher memory format to a lower memory format. So this is called actually quantization. Now I think you already know about neural network, right? Let's say this is one neural network I'm having. So inside neural network, what do we have? We have lots of weights, yes or no, right? We have W1, W2, okay, and W3 and so on. So this is what actually we are having. That means we are having lots of weight and biases. Let's say B1, B2 and so on, right? Now you can represent these are the weight as a matrix, because if you know about artificial neural networks, so there I think you know how we can represent these are the weights. Okay, how we can represent our input data and all. Okay, let's say this is the one 3x3 matrix I'm having, and inside that we're having lots of weights. Let's say W1, W2, W3 and so on. Okay, this is the weights, and this weight is nothing but it's a floating number. Okay, it's a floating number, it's a floating value. If you see any kinds of weight, it would be like that. Let's say 7.23000 like that. Okay, so this is called actually floating value. These are the floating value, and if you see, this floating value stores in a FP32 bit. Okay, FP32 bits. Now what is the full form of FP? FP means full precision. Okay, full precision. Okay, full precision. You can also call it as single precision. Okay, single precision. Got it? So whenever we are doing the quantization, that means what we are doing, we're just trying to convert this higher memory representation to lower memory representation. That means it is now saving these are the weights in the FP32 bits. Now what we will be doing after doing the quantization, we'll be converting these 32 bits to, let's say, 8 bits. Okay, 8 bits, or let's say 4 bits. 4 bits. That means what will happen? Let's say you are having one floating number like that. Let's say 1.70890. Now, if you want to convert it to 8 bits, what you will be doing? You will just remove, these are the numbers actually. These are the numbers actually you will remove. And you will take this number only. So that's how actually you can reduce the memory size. That means you can convert any kinds of higher memory actually format to lower memory format. So this is called actually quantization. Okay, I hope it is clear. And the technique actually we usually use, let's say LoDA and QLoDA. Okay, QLoDA. So these techniques help us to perform this quantization. That means it will load the original model as a quantized model. That means in a lower precision. Okay, let's say I want to load this model in a 4-bit precision. 4-bit precision. Okay, so let's say previously this model was in 32 bits precision, but I want to load in 4-bit precision. So how it will happen? With the help of QLoDA or LoDA, you can do it. Sorry, with the help of LoDA and QLoDA, you can perform it. We are having already some Python libraries. Okay, so we are having one library called PEFT. Okay, this is called parameter efficient fine tuning. So with the help of that, you can perform LoDA and QLoDA technique. So with the help of that, you can load any kinds of actual models. So these are the model. Okay, in a 4-bit precision, in a 8-bit precision. Okay, that means you can load as a quantized model so that you can perform the fine tuning operation. Because as I already told you, this actual model you can't load because it is having huge amount of size, huge amount of, let's say, weight size. Okay, and it is storing those are the weights in a 32-bit precision. And to load these are the model, we need a good configuration machine, good configuration GPU, memory, and so on. But we don't have that much of resources. We are having, let's say, Google Colab, free Google Colab, or let's say you are having a 3060 GPU. That time what you can do? That time you have to load these are the model. With the help of this, these are the technique actually. The technique actually I showed you. This one, quantization. That means you will be using LoDA and QLoDA. With the help of that, you will be loading the model and will perform the fine tuning operation. Now you can ask me, sir, if I'm doing that one, so definitely I will lose some information. Definitely will lose some information because you are loading the model in a 8-bit and 4-bit precision from the 32 bits. That means here you are getting rid of some of the numbers. So definitely you are losing some information. But again, LoRa and QLoRa takes care of this part actually. So they try to optimize your, let's say, model weights as much they can. Okay. So you don't need to worry about if you're using these at the library, everything would be happen in an optimized way. So we'll be learning as a practical also how we can fine tune one large language model. So in the next video, we'll be learning how we can fine tune one model called Llama 2, Meta Llama 2. Okay, we'll be fine tuning this model on top of our custom data. And here we'll be using this PFT technique, parameter efficient fine tuning technique. Got it? Because I'll be using free collab here. If you want to do in your local machine, if you're having, let's say, any basic GPU, you can also do it. But I'll try to train on Google Colab if you're not having any kinds of GPU, okay, and not having any kinds of good configuration machine, you can perform on Google Colab. Fine. So yes, guys, this is the introduction of fine tuning, and I think you got to know how we can perform the fine tuning operation and what is this PFT, okay, PFT technique exactly, and what is LoRa and QLoRa, because I know that many people will have this question: what is QLoRa, LoRa, and what is PFT and all. Okay, so I think now everything is clear. Okay, how things are working here. Fine. So in the next video, we'll see the practical demo of the fine tuning. So we'll be fine tuning one model, large language model called Meta Llama 2. Hello everyone, welcome back. So guys, in this video, we'll be learning how we can fine tune one large language model with the help of parameter efficient fine tuning process. Okay. So in our previous video, I think I already showed you what is fine tuning and why it is required and how we can perform the fine tuning. Fine. So here we'll be fine tuning one large language model called Meta Llama 2. I think you know Llama 2, right? Llama 2 is a large language model. So if you go to the Hugging Face and if you search for Meta, Meta is having different large language model. If I show you, let's say if I go to the Meta LLM, see, it is having different large language model like Meta Llama 3.1, Llama 2 is also there. If I expand all the things, see, this is the Llama 3 family, this is the Llama 2 family. So the way actually I'm doing the, let's say, fine tuning of Llama 2 family, you can also perform Llama 3 as well. Why I'm taking Llama 2? Because it would be a little bit, small size model. That's why I'm taking Llama 2. You can also take Llama 3 as well. Okay, the process will remain same. And how to get the permission from the Llama, I think I already showed you in my open source large language model session. So you have to apply for the permission first of all, and they will give the permission. Then after that, you can load it. And if you're not getting the permission as of now, what you can do, I can also show you one alternative approach. You can also follow this one. Fine. I think I already showed you one alternative approach, like you can use any other repository to load the model. It is also fine. Then what you can do after fine tuning this model, you can also push this model to the Hugging Face hub. Let's say if I show you my hub now, so if I go to my profile, see, I already published one model, this fine tune Llama model. After fine tuning it, I publish this model in my Hugging Face hub. Now people can use my model. So they will be just copying this name and they can use my model. You can see it is already downloaded 65 times. Okay, 65 times this model got downloaded by the audience, right? So that's how actually you can also publish your model. If you want, you can also publish your model to the Hugging Face hub. Got it? So that people can also use your model. Got it? So now let me show you how we can perform the fine tuning. For this, I have prepared one beautiful notebook. So in this notebook, actually, I have written each and every step you need to follow. So first of all, make sure you selected runtime as GPU because you are doing the fine tuning operation and definitely you need a GPU. So I'll be selecting T4 GPU because here I'm using free Google Colab. You can also take the premium subscription of the Google Colab. If you're taking the premium one, so you'll see that your training would be a little bit faster than this free one. Fine. Now let me connect this notebook. So guys, as you can see, my notebook is connected. Now the first thing what you have to do, you have to install some of the required package. So here I have listed down all the packages actually you need, like let's say Accelerate, then PFT. PFT is the parameter efficient fine tuning that package. Accelerate you need if you're using transformer library and if you want to, let's say, use the GPU, that time actually you need to install this Accelerate as well. Fine. Then you can see bits and bytes is also requirement of the transformer. And if you want to set up everything in your local machine, that means if you're having local GPU, but if you don't know how to set up the GPU, no need to worry. I have created one dedicated video. Let me show you. So if you search my YouTube channel DS with Bappi, so here you will see that I have created one video in the video section. Set up NVIDIA GPU for the deep learning. So here I showed you how we can install the CUDA and CUDA toolkit. So definitely, first of all, you have to set up your GPU in a proper way. Then you will be able to set up everything. That means you will be able to utilize your GPU. So make sure if you're doing local setup, you can try to watch this video. Okay. Otherwise, if you're doing on Google Colab, try to do the same thing the way actually I'm doing here. So let me install all the packages. So guys, as you can see, installation is completed. Now the second thing, you have to import all the necessary library. So you can see I have imported all the necessary library like auto model for casual LM, auto tokenizer. Okay, I think you already know these are the thing. The Hugging Face actually library. Okay, why we need it. Then you can see I'm importing something called PFT, that means parameter efficient fine tuning. So from PFT, I'm importing something called LODA. You can also use QLODA, but here I'm using LODA. Okay, so both technique we can use, it's up to you. So let me import as of now. So whenever I will be using it, I'll tell you, okay, what are the package actually you are using and for which task. So see guys, execution is completed. That means everything is working fine. Now, let me show you the data set first of all. See, this is the original data. So let me open the data. See, this is the original data. So the dataset name is Open Assistant. So the dataset name is Open Assistant Guanaso. I think this is the dataset name. And you can see this is the data. That means it is having some conversation between human and assistant. You can see. So conversation between human and assistant. You can see human and assistant. So this is the human, let's say conversation. And this is the assistant conversation. Okay. So that's actually they have collected this data. And it is having actually, you can see how many example. In the training, you are having 9.85k rows. Fine, almost 10k example you are having. Now see, it is also using different languages. See, different language actually they have collected the data. Not only English, it is also they are using Chinese language also. They're using different languages. That means it is a multi-language data and it is a conversation data. So we'll be training one chat model. That means llama to chat model. Okay. I think I already showed you what is the difference between llama to chat model and fine-tuned model. Let's say if you want to only perform the text generation, that time you can use pre-trained model. Okay. And if you want to perform, let's say chat operation, and let's say all kinds of tasks, the way actually you perform with the chat GPT, that time you can use chat model. Now, if you open the Hugging Face and if you go to the actually llama model, you will see that it is having different model. Let me show you. So if I search for llama, see if I go to the llama 2 series actually, llama 2 family, you can see it is having llama 2 7B model, HF model, and it is also having something called chat model. You can see, chat model. Chat model means you can perform the conversation, chat operation, the way you actually perform with the chat GPT, right? So we'll be fine tuning one chat model. So that is why I'm using this chat dataset, conversation dataset. Okay, instruction. So these are the instruction. I think this one, see, this is the instruction human is giving, assistant is replying. So these kinds of dataset actually will be using. Now you can use any kinds of data. You just try to prepare your data, okay, in that format. You can also create a CSV file. So inside CSV file, in first column, you can write the human, let's say conversation. In second column, you can write the assistant conversation. That's how also you can collect the data. Okay. It can be any kinds of format. So as of now, we are using the data from the Hugging Face. You can also use your custom data. And how to upload your custom data to the Hugging Face? For this, you can see Hugging Face documentation. They will also give you the, let's say, entire process, like how I can, let's say, publish my data to the Hugging Face app. And from there, I can load my data. It is also possible. But most of the data actually we'll see from the Hugging Face itself. We can use it from there. So see, this is the llama 2 supported data. That means whenever you will perform the fine tuning, so you have to convert this data in that format. See, this is the format. So first of all, you have to give the S token. You can see S token. Inside that, you have to give the instruction. And what is the instruction? Instruction is nothing but it's a human conversation. Whatever conversation human is doing, this is called instruction. See, if I open this example, see, this is the human. See, this is the human conversation. Okay, see, till this token actually, that means /inst, that means instruction. This is the human conversation. After that, whatever text you can see, this is the assistant conversation. Okay, this is the assistant conversation. Got it? So that's how actually you have to prepare your data. And at the last, your S token will end again. Okay, that means this is the complete system token right now. The complete prompt. That means you are creating the prompt here. Because my large language model supports prompting, right? So that means we are creating the prompt here. So that my model can understand whenever we are doing the inference, whenever we are, let's say, sending any kinds of prompt to the large language model, it can automatically understand. We are sending the prompt. Okay. So that's why I'm first of all teaching my model. This is instruction. And after instruction, whatever actually message you can see, this is the your output. That means your response, assistant response. Okay. This is the format. Now, if you open any kinds of data, you'll see that it is using the same format only. Okay. Same format only. So we have to convert our data, this format to this format. Okay. Now you can ask me how to convert this format to this format. For this, we can use one notebook. See, this is the notebook, guys. Even I already attached this notebook link inside this original notebook. Let me show you. See, this is the notebook. Okay. So in this notebook, actually, I already written one function transform conversion. So this one actually will take the human conversation as well as the assistant conversation and will add these at the token. Okay. Like that. the way actually I showed you here. Okay, I think it is clear. Now you can use this function as it is, and you can convert any kinds of, let's say, these kinds of conversation data to your like LLM format. That means your Llama 2 format. Now there are so many large language model. It takes actually different kinds of format. If you go to the documentation of the Hugging Face, you will see that what kinds of format they supports. Based on that, actually you can actually write the converter. Also, you can get this converter from the Hugging Face itself. Hugging Face also provide these kinds of converter. You can use this converter to convert your data to a specific format. Okay, so most of the large language model will follow this format only. Okay, we'll see that most of the large language model will follow the same format, the format actually I'm using here. Fine. So that's why you can use this converter as it is. Now see, here I'm loading the data. That means my entire data. That means this data, this Open Assistant data. You can see I'm giving the name of the Open Assistant. Then see, instead of taking all the data, all the, let's say 10K example, I'm only taking 1000. Okay, 1K actually example, because here I'm using free collab and fine tuning will take time. That's why I'm only taking 1000 example to perform the fine tuning operation. And I'm doing the, let's say, conversion operation. Then after that, I'm just pushing this, let's say, data here. So this is the data. Now see, the same data, but here actually this guy is taking actually 1K example, and he has already converted this data to the required format. Okay, so this is so this data is already available. You can see this guy has already converted this data to this format. So directly you can use this data. But if you want to do it, so this is the notebook you can use. Okay, the same notebook you can use. Got it? And if you want to use the entire data, guys, what you can do? So here I've already given the complete reform dataset link. You can open it up. So see, it is having actually 10K example only. See, around 9.85K rows. Now see, it is already formatted. Okay, it is already formatted. So you can also use this data. If you're using good configuration PC, you can use this data, okay, for the fine tuning operation. But I'm going to use this data actually, 1K example data. Okay, only 1K example I'll be taking here. So guys, I think now you got to know how we can reformat our data for the Llama 2 model. And see, here we are using free collab, and free collab actually offers 15 GB of graphics card. If you see here, it will give you 15 GB of graphics card. See, okay, and here you will get disk around 112 GB, and RAM actually will get 12 GB. Okay, so this is the configuration of our free collab. Now here you can see it is having actually limit resources, barely enough to store Llama 2 7B words. That means we can only use 7 billion Llama 2 model. Okay, 7 billion Llama 2 model. If you're using 70 bay, 30 bay, 13 billion, that time actually will get difficulties. Okay, because it is a free Google Colab. But if you're using a premium Google Colab, that time actually you can also use this model. Okay, it's completely fine. Now here you can see full fine tuning is not possible. Here we need to perform the parameter efficient fine tuning technique, like we'll be using LoDA and QLoDA. Because the full model we can't load here, we have to use a quantization technique. That means we'll be using LoDA and QLoDA to perform the parameter efficient fine tuning. Got it? And to drastically reduce the VRAM, we must fine tune the model in 4-bit precision, which is why we'll be using we'll be using LoDA here, not QLoDA. We'll be using LoDA here. Fine. That means we'll be loading our model in the 4-bit precision. I think I already explained here what is 4-bit precision, right? So initially your weight would be in the full precision. Okay, 32-bit precision. This is called full precision, and we'll be loading the model in the 4-bit precision with the help of LoDA technique. Fine. I think it is clear now. Now let's load the model, guys. Now you can load the official Llama 2 model. You can see you can also load the official Llama 2 model. So Llama 2 is having also official model. So this one. So see, this is the official Llama 2 model. You can load, you can copy, and you can just paste it here. But if you didn't get the permission, what you can do, you can also load the model from any other repository. So see, this repository has having this model also, this Llama 2 7B chat HF model. So this repository has already published, and here you don't need to take the permission. You can directly download the model. So if you haven't get the permission, you can use this model. Either you can use the official model. Okay, official model. Let me also copy here, and let me mention it here. Let's say I can comment here. Just for your reference, you can copy the name and you can paste it here. Okay, later on. Now this is the dataset, guys, I'll be using. I think you remember. So this 1K example we'll be using. So copy the name and try to mention it here. Okay. And after fine tuning, what is the name you want to assign? I want to assign this name, Llama 2 7B chat fine tune. And these are the LoDA parameter. You can see. And LoDA parameter wise, everything just keep it default, because you can see I'm loading everything in a 4-bit precision. Okay, 4-bit precision. So no need to change anything. Keep it everything as default. See, I won't be changing anything. Only the change you have to do, the epoch size, number of epoch you want to train. So I think epoch I have mentioned here somewhere. See, number of epoch, training epoch. So as of now, I'm showing you one let's say epoch training, because one epoch training will take time if you're using free collab. And if you're doing the actual training, that time just try to increase the epoch size. Now everything keep it default, no need to change anything. Now let me initialize all the parameter. So this is my LoRa parameter, guys, for the parameter efficient fine tuning. Fine. Now we'll be loading the dataset. I want to use the training dataset because I want to do the fine tuning. And here I'm loading everything in a 4-bit position, you can see. Okay, with the bits and bytes actually configuration, we are loading everything in a 4-bit position. So this is the way actually we can define our LoRa. And how I got this code, if you go to the Hugging Face documentation, you will see that, okay, they have already given these kinds of codes in it. So you just copy paste and try to use it as it is. No need to change anything. Fine. Now see here, I'm loading the model in a 4-bit position. So here you can see I'm loading the base model as well as the tokenizer. Okay, tokenizer I'm also loading. So guys, here you can see I'm setting all the LoRa configuration. After that, here is the training arguments. I think you know what is training arguments. In the Hugging Face, you have to set your directory, the number of epoch, your optimizer, everything you can set here. Then with the help of SFT trainer, I'm initializing the training process. You can see model.train. Now see, if I execute this code, it will start the training. But see, training will take time actually, around 30 minutes actually it will take. I was training previously. I know that it will take around 30 minutes. Okay, 30 minutes you have to wait because here we are using free Google Colab. So as you can see, it is downloading the model. After that, you will see that it will start the training. See, it's downloading the model. So see, I won't be waiting 30 minutes. What I will show you, the next process actually you can follow. Like after training, what you can do. Because see, I have written all the code. Only you just need to execute if you're doing it. Because here I'm recording currently. So I can't wait actually 30 minutes to train the model. Let me show you what you can perform here. See, after training the model, you have to save the model. You can see you have to save the model, trainer, model, save, pretend. Then you have to give the new model name. I think new model name, I think you remember, we have given a new model name here. Whenever we define all the configuration. This is the new model. Okay, so it will save with the help of this model. Fine. So it will save the model in the here in this disk actually. You'll see that it will create an output folder. Inside that it will save the model. Then after that you can also visualize the TensorBoard logs. See, this TensorBoard will show you the losses, then the accuracy, okay, of your model, everything it will show you. That means the complete metrics it will show you, the training losses, validation losses, everything it will show here. Then after that, what I was doing, I was loading the original model. You can see I'm loading the original model, not the trained model I've trained. I'm loading the original of the Llama model, and then I'm testing with a prompt. What is large language model? I just wanted to see what would be the output from my original large language model, because that means I want to compare this result with my trained model, the model I have trained right now. Okay, that's why I'm loading the base model. That means my original model, and I'm only want to see the output. Okay, so here I've given a prompt, what is the large language model, and this is the actually output I got, okay, from my model. Then after that, what I did actually, I deleted all the model pipeline and everything just to empty my VRAM, because in RAM actually it will occupy lots of space. So you have to execute this code after executing this line actually. So no need to execute this line of code, just try to skip as of now. First of all, execute this line of code. This line of code, what it will do, it will try to load your base model as well as your trained model. Okay, that means new model. Then it will merge. That means if you want to save the model right now, if you're using parameter efficient fine tuning, first of all, you have to load your base model as well as your new model. Okay, both you have to load. Then after that, you have to merge. After merging, what you can do, you can also load your tokenizer. Then you can push this model to the Hugging Face app. For this, just execute this line of code, and you have to perform the Hugging Face CLI login. Okay, Hugging Face CLI login, and it will ask for one authentication token. See, this is the token it will ask. Now what you have to do, go to the Hugging Face, go to the settings. I think you know how to generate the tokens. Go to the access tokens. Now create a new tokens. Let's say I'll give the token name is equal to test. And now you have to give the right access, because you want to write something. You want to push something to the Hugging Face app. That's why you have to give the right access. Now create the token. Let's create the token. Now copy the token and pass the token inside that. Inside that you have to pass the token, then give Y, then press enter. After that, it will automatically authenticate with your Hugging Face. Then it will be pushing your model to the Hugging Face itself. Now here you have to give your username. See, this is my username, ENT So make sure you are giving your username here. Okay, not my username. Otherwise, it won't be working. Okay, so if you execute this line of code, it will push your model as well as the tokenizer as well. Now, after executing this line of code, go to the Hugging Face, click on the profile, go to the, let's say, your profile. Now you'll see that in the model section, this model would be published. Okay, and this is the model, and this is your tokenizer. That means the same model you have to use for the tokenization as well. I think I already showed, right? Now, after that, let's test this model, okay, whether it is working or not. So for this, I created another notebook. Let me show you. So this is the notebook I created, guys, fine tune model test. Now again, just try to install transformer accelerate. that means all the required package. Then after that, just try to load your model right now. The model actually you have trained. See this model, just try to copy the name and just try to paste it here. Okay. Then again, I'm giving the same prompt. What is the large language model? I'm loading the tokenizer first of all. So inside this pipeline, I'm giving my model. Then after that, you can see I'm creating the complete pipeline. Then it is predicting and it is giving me the results. Now see, this is the results actually I'm getting. See, although I've trained only one epoch, but if you see the results, it's not actually bad. Somehow actually it has given me the good output. Then again, I have given another actually prompt. Now see, this is the results. I'm executing my model and this is the results actually I'm getting. So the prompt is actually explain to me in a simple to understand way what is the equation of finding the nth triangle number is and how it can be provided by using the high school level math. Please give each step of a proof of using latex. See, this is the latex actually output I'm getting. That means all the, let's say, mathematical equation and everything it has given me as a latex. Now I can convert this latex to the mathematical format and you can see that particular output. Okay, so that's how actually we can also test our model. And this is the entire process of fine tuning, guys. Entire process of fine tuning, and still training is going on. You can see still training is going on, and it has created the result folder. And inside result, inside branch, it will save the weights. Okay, it will save the weights. That means the artifacts. Fine. So yes, guys, that's how actually you can perform the fine tuning operation with the help of parameter efficient fine tuning. You can use either LoDA, either you can use QLoDA. Fine. So now what you have to do, guys, just try to perform this fine tuning. And if you are having any error, if you are having any issue, you can let me know in the comment. I'll try to help you with that, okay, to fix that particular error. Now apart from that, just go to the Hugging Face, try to pick any other model, guys. Go to the Hugging Face and pick any other model, not this Llama 2 model. You can also take Llama 3 model. You can also take, let's say, Mistral model, Falcon model, any kinds of model you can take. Just go to the model section, just find a model and try to perform the fine tuning process. Okay, you can use the same technique to perform the fine tuning process. Fine. So in future, I will create some more video there. Actually, I will show you how we can fine tune any other model as well. Let's see if we want to fine tune the Jimma model, how we can do it and all. Okay, we'll be creating some more video. But before that, first of all, try to explore by yourself. The way actually I showed you, the entire notebook I shared with you. Try to pick up any kinds of model and try to follow the same technique to perform the fine tuning operation. So with that, guys, thank you so much for watching this video. I hope you liked it. Thank you so much.
Hi guys. In this video, I'll be talking about retrieval augmented generation, which we also call it as RAG. So see guys, in generative AI, mostly we'll be working with the RAG based system because here fine tuning large language model is a little bit difficult. Even we have already saw that, okay, how we can do the fine tuning operations. I already showed you how one fine tuning example, right? So as you go ahead, you'll be taking different large language model and those model parameter would be very huge. And whenever you are fine tuning these are the model, definitely will face the difficulty. Okay. So instead of that, there is another concept we use called RAG concept. So with the help of RAG concept also, we just try to connect our large language model with our custom data. So first of all, let's try to understand what is RAG. So you can see guys, inside LLM, we have some limitations like LLM can't answer correctly to the private data. Let's say you have some private document and your LLM won't be able to give the response on top of that. And LLM can provide the most current information. That means if you are having some current documents, okay, so it doesn't have the information because it has one like a knowledge cutoff. Let's say you have used one LLM that is only trained till 2021. Yeah, okay, so that means after 2021 whatever things has happened, it doesn't know that. Okay, so this is the problem. So you can see guys, to prevent this issue, we use something called retrieval augmented generation. So here we use RAG for allowing LLMs to use the external sources for better response. That means here, let's say we have some documents. First of all, we'll be using one embedding model. With the embedding model, we'll try to create the vector embeddings. Okay, and these vector embeddings will try to store to the vector database. I think I already showed you the vector database concepts, and I also showed you how we can generate the embeddings and all. Everything I already discussed. Now we'll try to connect the large language model to the vector database, and this will become our knowledge base. That means whatever question user will ask, okay, first of all it will go to the knowledge base. Okay, knowledge base will return some relevant response. Then it will also pass to the LLM, and the question will also pass to the LLM. LLM will try to get the context, and it will have the questions, and it will refine the answer, and it will send it to you. So this is the entire actually idea of the RAG. That means here you are giving this knowledge base as a context, this particular vector database as a context to the LLM. Okay, this is the idea. Now you can see retrieval augmentation generation RAG allows to external sources for the better response, more accurate answers on private data, stay updated with the new information. Okay, now here you can see, guys, why we call it as a retrieval augmentations. Okay, so here you can see whenever user is asking one questions, let's say what are your business hour, first of all it will go to the retriever. Retrieval will try to retrieve let's say the information from the documents, and it will augment the query. That means this query as well as the retrieve output, it will try to augment it, then it will try to generate. That means it will pass to the LLM. LLM will try to understand the question, and it will refer that particular context. Okay, then it will try to generate something, let's say in this case Monday to Friday from 9:30 a.m. to 6:30 p.m. Okay, so this is the response we are getting. So yes, guys, this was the RAG concept. Now we'll try to see some RAG components. Okay, after that we'll also try to implement actually RAG in a practical way. We'll try to implement the entire RAG applications. Okay, then I think after that your understanding would be clear. So thank you so much.
So first of all, I'll be discussing about data loader. Okay, data loader. That means how to work with custom data. So it can be any kinds of format. It can be PDF format. It can be, let's say, HTML format. It can be, let's say, JSON format, Excel format. Any kinds of data you can consider in that case, right? Now the second thing I'll be discussing about what is RAG. That means introduction to RAG. And what is the full form of RAG? Retrieval. Okay, retrieval augmented generation. Okay, retrieval augmented generation. Then third, we'll be discussing about splitter. That means we'll be breaking down this RAG. Okay, so let me just write down. Yeah, so we'll be breaking down this RAG, and inside RAG actually we'll see different kinds of component. The first component we'll be discussing about, which is nothing but splitter. Splitter. Okay, then the second component we'll be discussing about embedding. Then we'll be discussing about vector store. Then we'll be discussing about retriever. Okay, retrievers. Then once we got the understanding of this, there is another topic we'll be understanding called top K. Okay, top K inside a retriever. Okay, what is top K inside retriever? I'll try to discuss. Next session will be learning one RAG demo. That means I'll show you one RAG application. Okay, RAG with LangChain. Okay, LangChain expression language. That means we'll be building one RAG system. We'll be using our custom data and we'll be building the RAG system, and we'll be using this LangChain expression language there. Okay, our new LangChain syntax we'll be using to implement the entire, let's say, RAG system. Okay, so this is the idea. Okay, fine. So now see, as of now, I think you remember, as of now, what we have done, we have only done the generation, okay, with the help of large language model. Let's say here we are having one LLM. So as of now, what we have done, we have given a prompt. Okay, we have sent a prompt, and my model was giving me some response. Okay, response. And to give the response, actually, that actually information it is using. Okay, so it is using pre-trained knowledge. Pre-trained knowledge. That means during training these kinds of large language model, let's say if I'm talking about GPT 3.5, okay, GPT 3.5 Turbo. So whenever I'm talking about this model is already trained with some data set, right, over the internet. I think in till 2023, I think till October, they train, they collected the data and they train these kinds of model. Okay, if I'm not wrong. So this model is having actually, these are the information. Okay, this model is having, these are the information. Let's say whatever data they used to train the model, it is already having, these are the knowledge. So if I'm asking anything related to that, it will be able to give me the response. But what about you are having some specific data? Let's say if I ask, let me show you one example. What I can show, guys. So I'll open up my code. So here I'll create a notebook. Just a minute. 03. I'll name it as, let's say, DataLoader RAG demo IP1B. So here, what I can do, I will initialize my LLM first of all. I think you know how to initialize the LLM, yes or no? If I want to initialize the LLM, first of all, I have to load my secret keys. Okay, I have to load my secret keys from where? From the environment. Okay, it is telling plain text because I have to select my kernel. So here I'll be using OpenAI model. That's why I'm loading the OpenAI API key. But if you want to use any other model, let's say you want to use Grok API, you want to, let's say, load Llama model or Mistral model, that is free model, you can use Grok API in that case. Okay, so I already have the OpenAI account. That's why I'll be loading OpenAI model. You can also load the Grok model as free. I already showed you how we can, let's say, load different kinds of model. Now, first of all, let's load the OpenAI API key. After loading it, so first of all, let me load one chat completion model, because I already told you mostly we'll be using chat completion model, okay, instead of completion model. So you can see I'm importing one chat completion model, which is nothing but GPT 3.5 Turbo 0125 model. Okay, so this is the model I have loaded. Now, how to let's say give the prompt to the large language model. I think remember, let's say if I am using chat model, so that's how I have to give the prompt. So this is the way we can send the prompt. So what I can do, I'll copy this prompt as it is, and here I think just let me copy from previous example. So here is one example I'll copy, and here I'll try to paste it. Now here I can give URN, let's say URN helpful. Okay, helpful assistant. Now here I can give one input. Let's say I'll tell me about DS with Bappy. Let's say I'll give my YouTube channel name. Let me see whether it is able to give me the answer or not. So I mean, whenever they train this model, I'm not sure actually they took my data or not. Okay, I mean, let's see. So what I can do, I can print the response here simply. Okay, so now let me execute. See, if I show you the content only, if I show you the content only, if I print it, see, it is telling, I'm sorry, but I could not find any information on DS with Bappy. It seems like it may be a typo or terms that is not widely recognized. Could you please provide more context or clarify your question so that I can better to assist you? Because whenever they trained this model, that time, that time they were not using my data. Okay, that means my YouTube, information was not there inside the, let's say, data set, whatever data set they used to use. What I'm trying to say, let's say whenever I'm performing the inference operation with the pre-trained model, that trained model we are using, let's say direct model we are using, and if I'm asking any kinds of prompt, it's always not, let's say, possible you will be getting the response. Let's say if you are asking anything which is not available in the knowledge base, okay, in your model knowledge base, that time it won't be giving you the response. Okay, and here is the example I already showed you. If I'm asking related DS with Bappy, it is not able to give me the answer because it hasn't trained with this particular data. So in that case, what I can do? In that case, what I can do? Can I use my custom data? Can I use my custom data and can I give the information to my model? Is it possible? Yes, it is possible. For this, we have to first of all learn how to load the data. how to load different kinds of data. Let's say here I'm having one data folder. You can see inside data folder I'm having different kinds of TXT file. Sorry, different kinds of file. Let's say I'm having PDF file, I'm having HTML file, I'm having TXT file, then I'm having CSV file, I'm also having database file. Okay, so these are the different kinds of file I'm having. Now if I want to load these at the data, and if I want to pass the information to my large language model, how it can be done with the help of LangChain, because I already told you LangChain is a universal framework. It can support everything. That means you can connect all kinds of data sources. You can connect all kinds of technology. Okay, you can connect all kinds of platform. Okay, and it can also load different kinds of large language model with the help of only one framework. Okay, that is what I already given you the intuition in my first session. Okay, so now we'll see how we can load these are the data. Okay, so this is called actually data loader inside LangChain. First of all, we have to learn how we can load different kinds of data, different kinds of format of the data. Then we'll be using that particular knowledge to create our RAG based application. And I'll tell you what is RAG. No need to worry as of now. If you're not familiar with RAG, I'll also give you the intuition about the RAG. Okay, so yeah, so first of all, let's try to see how we can load, let's say, PDF data, HTML data, TXT data. Okay, so these are the data, how we can load it. So this is our main objective. So for this, here I'm going to write a comment. So here I can write data loader. Okay, data loader. Okay, so the first data will be loading, which is nothing but TXT data. That means if you are having any TXT file, how we can load it. So here, so let me just write down here TXT data loading. So for this, you have to import one function from the LangChain community. So all kinds of data loader are available inside LangChain community, guys. Okay, so first of all, write like that, LangChain community. So I already installed LangChain community, I think, remember. So LangChain community is not there. Let me just find. Yeah, so LangChain community is not there, so I can install the LangChain community. So here is the LangChain community. Okay, LangChain -community, and this is the specific version I'm installing. Okay, and try to remember all kinds of data loader functionality are available inside LangChain community, because I already told you it is using core LangChain only, but LangChain has divided. Okay, these are the framework in a different let's say functionality. Let's say if you want to load the model, OpenAI model, you have to install LangChain OpenAI. Let's say if you want to use Grok API, you have to install LangChain Grok. If you want to, let's say, load the data, you have to install LangChain community. Okay, that's how actually it is having different kinds of sector, different kinds of sub framework. Okay, so this is what you have to remember. So for me, I already installed in my environment, but for you, what you have to do, guys, you have to execute this command. So this command pip install -r requirement.txt. So it will install this particular LangChain community in your let's say environment. So for me, I already have it. So what I'll do, I'll just try to close it. Then here I'll just try to import. So from LangChain community dot documents loader. Okay, documents loader import. So text loader. Okay, so because this is a TXT file na, so here you are having one function called text loader. That's it. Now you have to specify the location of the text. So inside this particular function, you have to give the location, like which TXT file you want to load. Let's say I want to load this TXT file. Let's say this one, be good TXT file. I'll just try to copy the path, and here I can mention it. Now see, it is copying the entire path, but I don't need the entire path. I only need the relevant path because I'm inside my project working directory. So what I can do, I can again copy it. So right click and try to copy the relevant path. Okay, relative path. So here I can paste it. I can see it is using backward slash. In Windows, by default, it will use backward slash, but what you have to do, you have to use the forward slash. Okay, forward slash. That's it. Now, after loading the data, it will give you the data loader object. So let me create an object here. So I'll store inside a variable. Then after that, you just need to call the load function. So let me just write loader dot load. Okay, now it will give you the data. So what I can do, I can just store inside a variable called loaded underscore data. Okay, now see, if I execute the program, you will see that this TXT, whatever TXT you are having inside this file, this data has been loaded. Okay, now let me show you. So if I print this data load, right, loaded data, you can see this data has been loaded, and it has loaded as a document. You can see it has loaded as a document. The type is document. Okay, always try to remember, guys, if you are using LangChain, Llama Index, whatever orchestration framework, whenever you are loading the data, it will load as a document, because inside generative AI, we call the data, we call all the custom data as a document. Always try to remember. Okay, we call it as a document. Okay, so this is the document, guys. So first of all, it will show you the meta sources. That means from which file it has loaded the data. You can see it has loaded the data inside data folder. This is the file bgood.txt, bgood.txt, and this is the page content. That means whatever content you are having inside that. So here is the content it has loaded. Okay, it has loaded. So this format you have to give to the large language model, otherwise it won't be working. So make sure your data is a format of document. Got it? If you're loading any kinds of custom data, always you need to remember. Yeah, so this is for actually TXT data loader. Now what about CSV? Let's say I'm having a CSV file. How to load the CSV file? So for this, let me show you the syntax. So here I can write CSV loader. Okay. Now let me show you the different kinds of data your LangChain supports. So data loader, you can see TXT loader. So this example I have already given you. List of the built-in data loaders. Yeah. Now you can see your LangChain supports all kinds of platform. You can see you can load the data from AC Realm, then byte loader. Then you can also use different kinds of loader. You can also use AstraDB, Archive. I think you know inside Archive actually we are having all kinds of research paper nowadays. Then Azure Data AI. Then see different kinds of Cassandra. Then you can also load Discord data. Okay, Dropbox data. All kinds of social media platform also you can connect. You can also use Figma. See, different kinds of data loader are available inside LangChain. It's not only about TXT data loader, PDF data loader, JSON data loader. It's not like that. It's all about all kinds of framework, all kinds of third-party, let's say, platform. You can also connect with the LangChain. It is also possible. See, guys, PySpark, Slack, Telegram. Okay. Then if you're having any custom URL, any website, you can also load the data. XML, YouTube transcript, Wikipedia. Okay. Twitter, all kinds of data, you can load it. All kinds of data, you can load it. Now, simply, let's say you want to learn how to load the CSV data. In that case, what you can do, just click on the CSV. In the documentation, you can see, okay, they have all the tutorial. Okay, it's not like that. Always this documentation would be hard for understand. Sometimes you will see some of the functionality would be easy to understand. Let's say if I'm talking about data loader, if you click on the CSV, you can see how to load the CSV data loader. First of all, you have to import this particular statement, CSV data loader from the LangChain community. After that, you have to give the CSV path and it will load the data as it is. Okay. So that's how, see, they have also given the code snippet. So try to open it up and try to copy the code and try to paste in your notebook. Okay. You will be automatically getting the understanding. So for me, what I will do, I'll show you some of the data loader, but for you, you can explore all the data loader. Let's say you need to load the Slack data, or let's say you need to load the data from the Telegram. So try to go to the documentation, try to open it up, and whatever code they are suggesting, try to copy paste and try to load the data, try to connect with the Telegram. Okay. But I will show you most actually frequent format. Okay, most frequent format, whatever let's say format people are using in their day-to-day life. Okay, so some of the example I'll show here. We have seen how to load the TXT data. Now let me show you the CSV data, how to load the CSV data. So this is the example of the CSV data. First of all, you have to load this particular function from the LangChain community document loader. And this is my CSV data, guys. You can see straight tree list CSV. So this is the comma separated data I'm having. Now if I want to load this particular CSV, I have to use CSV loader. And again, try to call loader.load. Okay, now if I show you the loaded data. Okay, so this is the entire CSV data you'll be getting. See. Okay, this is the entire CSV data you'll be getting. And all the row it is considering as a document. You can see all the row it is considering as a document. Row 0, row 1, row 2, and so on. Okay. Now let me comment it up. Now what about HTML? Let's see if you're having any HTML data. So here I'm having one HTML. Let me try to open it up. So start up HTML. See, this is the HTML page I'm having. And let's say I want to load these are the data. So how it can be performed. Okay, with the help of LangChain, we can easily perform it. Let me show you one example. So here is the example, guys. Okay, so you have to use this unstructured HTML loader, this particular function from the LangChain community. Inside that, you have to give the HTML path. So this is the HTML part. Inside data, I'm having this particular HTML. And make sure whenever you are doing it, okay, whenever you are doing it, you have to install one library called BS4. So inside requirement.txt, I can mention it. BS4 as well as the unstructured. So these two package you have to install, because you will be loading the unstructured data. Inside HTML, you will see unstructured data for this, and it is beautiful soup as well as the unstructured. Okay, these two packages. So those who have performed web scraping, I think you know what is beautiful soup and what is unstructured. Okay, so similar kinds of things LangChain will also apply. It will perform the web scraping and it will extract all the information from the website itself, from the HTML page itself. So this is the idea. So let me save, and after like adding inside requirement, make sure you are running this command, guys. So requirement.txt. So it will install all the package in your systems. For me, I already have installed all the package. That's why I'm not going to install again. That's it. Now let me load the HTML content. So you can simply execute. So it will load the HTML content. So inside this HTML page, we are having so many content. That's why it is taking time, because it is extracting all the information one by one. Okay. So it will take some time, guys. What I'll do, I'll stop the execution. But for you, we can execute and you can see whatever content it will extract. So as of now, let me clear the output. Okay. Now the next thing, I'll show you how we can work with the PDF data. So PDF data. So you can see I'm having the PDF documents. Okay. So how to load the PDF document? So this is the snippet to load the PDF document. You have to use PyPDF loader. See, all the import are same. Only you just need to change with respect to your data format. Let's say you need to load the CSV at the time CSV loader. You need to load the HTML at the time HTML loader. PDF loader. Okay, that's how you have to only change the function. Inside that you have to specify the PDF. So this is the PDF I want to load, and you have to load this particular PDF. Okay, so loader.load and split. Okay, you can call this particular function. Now if I show you the loaded content, but before that you have to install another library called PyPDF. So inside requirement, I'll try to add PyPDF. Okay, with the PyPDF, it will extract the information from the PDF document itself. Okay, this is what you have to remember always. Okay, so now let me save and let me execute here. Now you'll see that these are the content I had inside my PDF. So it is having actually 4 pages. If you open the PDF, so this PDF actually 5 pages PDF. So this is the PDF, guys. You can see it is having 1, 2, 3, 4. Okay, 4 pages. So that's why it is telling 4 pages PDF. So you can see it is having 4 pages. Okay, 4 pages, 4 sources, and all the content it has extracted one by one. Okay, now if you want to see the page content, so simply you can see this is a list. Okay, I want to take the first item. I'll give the first ID, and I only want to see the page content of it. Now see, it will show you the content, whatever content it has extracted. That's it. Okay, now let me show you how we can load the data from the Wikipedia. Wikipedia data loader. Okay, for this you have to install one package called Wikipedia. Okay, Wikipedia package you have to install. Then after that, this is the syntax. Okay, this is the syntax. See, now here inside query, actually what you can do, you can give any kinds of any kinds of let's say topic name. So what I can do, let's say here I can mention like that. Let's say query, I want to ask about, I want to let's say get the information about, let's say Tesla. So I'll give the Tesla here in the query. And what I'm telling, I need load maximum documents 1. That means it should only return me 1 documents. You can also increase the number. If you need some more information, you can increase the number. You can give 2, 3. Okay, as per your requirement. Now, if I see execute the program, it will give me the content related Tesla. Okay, see. So it is giving me the content related Tesla. Okay. Now there is another thing you can perform. So you can directly, whatever information you are getting, you can directly pass to the large language model and you can perform the question answer on top of it. Okay. That means you can give as a, let's say context. Okay. Context to your large language model. So how it can be performed, guys. So let me show you another example. So here I'll again create this Wikipedia data loader. Now see, inside query and this load max, you don't need to pass anything. Just write query is equal to name and keep it as default. No need to change anything. And simply execute this line of code. Okay, see here I'm importing prompt template from the prompts. Then chat promptlet from message. I think I already explained, okay, what is prompt template, how to create the prompt template and all. I already clarified. And here is the human prompt I'm giving. Answer this question. Here is the extra context. And from where I'll get the context? I will get the context from where? I'll get the context from the Wikipedia. Okay, I'll get the context from Wikipedia. Let's say whatever user will ask. Okay, whatever user will ask. So this, let's say query, first of all, will go to the Wikipedia. Wikipedia will return me the documents, and these documents I will give the context to my large language model. Okay, and this will give me the answer. Okay, so it's still running. So let me stop the execution and again re-execute again. Okay, so what I can do, I can delete this part. It's not required. So let's say whatever Tesla information I got now, so I can pass as a context. That would be fine. So here I'll give, let's say, Tesla. Tell me about about Tesla. Okay, tell me about Tesla. Now see, whatever answer I'm getting from my Wikipedia, I'm giving as a context. You can see loaded data. The loaded data I'm giving as a context. That means what is happening, just try to see. Let's say this is my large language model, LLM. Okay, LLM. So here I'm asking, what is Tesla? This is the prompt I'm giving, right? What is Tesla? And here I'm also giving the information about Tesla. And from where? I'm getting from the Wikipedia. Wikipedia is giving me information related Tesla. Okay, this information I'm passing to my large language model as a context. Okay, as a context actually I'm passing. Then whenever you are asking what is Tesla, so what will happen? It will refer this particular context. This context it will refer. Okay, this context it will refer and it will give you the response. Okay, it will give you the response. So let me show you the execution. So if I now execute the program, so now let me do the invoke operation. So chat model invoke, I'm giving the message. Okay, now let me show you the content. See, this is the response I got from the large language model. Okay, now see here what you are doing, you are giving the complete actually data, complete data to the large language model as a context. Now just try to think, if your, let's say Wikipedia, okay, Wikipedia, let's say return, Wikipedia return, let's say 10,000 tokens, 10,000 tokens response. That means 10,000 tokens information. Let's say whenever you given the Tesla in the Wikipedia, let's say Wikipedia return 10,000 tokens, 10,000 tokens, let's information, and you are using GPT 3.5 turbo model, GPT 3.5 turbo model. Now if I go to the model documentation, let's say OpenAI model, sorry, not pricing, model list. Model OpenAI platform, let me open it up. Now if I go to the GPT series, GPT 3.5, GPT 3.5, just let me find out. Yeah, 3.5 turbo. If I'm talking about this model, now see what is the context window, guys. Maximum output tokens. Oh, okay, they have increased the context window. Let's say I'll increase it here. Let's say instead of 10,000, I'll just write 30,000. Okay, 30,000. Let's say 30,000 tokens you are having. Now you can see the model GPT 3.5 turbo takes context window, that is input token. It can take 16,385 tokens it can take as an input. Okay, this model can take, so let me just write here, GPT 3.5 turbo. This model can take 16,300 85 tokens as an input. Okay, and it can give the output 4096 token. 4096 token it can give you the output. Okay, so this is the limit of this large language model. Now let's say the context, you got from the Wikipedia, it is, let's say, 3000, sorry 30,000 token. In that case, if I give this data to my large language model as a context, so will it able to take it as an input? Because you can see the input token limit is 16,385, but you are trying to give 30,000 token. Possible? No, definitely it will give you the input error limit, right? Input error actually it will give you. And whenever you are giving 30,000 tokens to your large language model, that means how your model will charge. If you go to the model pricing, so if I show you OpenAI model pricing, it will charge you based on the token. Okay, token limit actually. Let's say if I am talking about the GPT 3.5 turbo model. So what is the turbo model, guys? Here is the turbo model, GPT 3.5 turbo. Okay, turbo model. Let's say I'm talking about this model. Now see, 1 million token. Okay, 1 million token input. It will charge you $0.50. Okay, and if it is giving you output is equal to 1 million token, it will charge you $1.50. Okay, now just try to think about. Okay, the tokens actually you are giving to the model, that means the input you are giving, if your token size is high, that means it is like huge, that time your charge will also increase, yes or no? Because it will charge you based on the token. If it is taking like big token, if it is giving, let's say, big token output, definitely you will have higher cost that time. Okay, and you can't pass actually 30,000 input to the GPT 3.5 turbo because the input limit is 16,385. Okay, so this is the idea. That's why there is a drawback. This is the drawback actually. We can't directly load our custom data. We can pass to the large language model. It is not possible. Okay, because of that issue, because of the input issue. So what I can tell, guys, you can see the drawbacks. The first drawback I saw, input issue, input limit issue. Okay, then the second drawback you saw, which is nothing but cost, higher cost. Yes or no? Okay, so how to overcome this issue? How we can overcome this issue? Is there any way we can overcome this issue? I want to use, huge document. Let's say inside this TXT file, let's say I'm having very huge amount of data, let's say I'm using one books. Okay, I'm using one books. So inside the books, actually you'll see there would be 1,000 pages, there would be 2,000 pages. And if you, let's say, extract all the data, if you extract all the data and if you, let's say, count the token, how to count the token? So for this, what you can do, you can simply copy some text and there is a token counter website is there. So OpenAI token calculator, token counter. I think this one, just let me open it up. See here, I can paste the text. Now see, inside this text, actually you are having 98 token and 414 character. Okay. Now there is also price calculator is also there. So based on the token, how much it will charge you. So here I think token price calculator, OpenAI. So here you can see set width and height. So this is for the image. Okay, this is the image model, multi-model. But if I'm talking about text model only, for text model also, I think they have also created the calculator. Not sure, but for image model it is available. So you can set the image height and image width. Based on that, you can see the like price. Okay, how much it will charge you. But I'm not sure about the text calculator. OpenAI API pricing calculator. Yeah, input token. Input token. Let's say you are having 1000 token as an input and 1000 token as an output. Number of API call, let's say you have given 100 times. So based on that, see, this is the pricing. So if you're using GPT 4.0 model, so this is the price. Okay, this is the price. So that's how you can see different websites are there nowadays. They will show you the calculator, let's say, I mean, how much it will charge you and all. And no need to worry, in future I will also show you how we can track the let's say cost and all. Okay, this thing we can also develop inside our application. So that is the issue actually. That is the drawback. That means there is the input limit and there is the cost issue. Okay, input limit and cost issue. So for this, researcher had actually has developed one technique called RAG. Okay, RAG. That means retriever augmented generation. Okay, this technique. Okay, retriever augmented generation. Now inside RAG, what is happening? Okay, what is the idea inside RAG? So that is what I will try to explain. I already created one notebook. Let me take a screenshot of the content and here just let me paste it. Okay, see, this is what actually your RAG. So intro to RAG, you can see load large dataset asset and ask the LLM question about it. That means with the help of RAG. Okay, with the help of RAG, what we can do, we can load large dataset. Okay, large amount of dataset. Okay, large amount of dataset we can load and we can perform the question operation with the help of large language model. Okay, now what if the loaded data is too large? If it is too large, okay, if it is like huge, then that time what we can perform, we'll be using something called RAG technique. See, always try to remember, if your loaded data, that means the data you are loading, let's say you are having a TXT file, the data you have loaded. Okay, if it is less than your model, okay, model input limit, okay, that time you can directly pass this data as a context to the large language model. There is no issue. Okay, but if it is like greater than the model input, let's say in this case actually my model input is, if I show you that model, so here I think I already written, yeah, 16,385. Let's say after extracting the data, you saw the token is like more than this size. That time what you can do, we can't directly give the data to the large language model. It is not possible. For this you have to use the RAG technique. Now inside RAG technique you are having some step. Okay, I can see when you load a documents, you end up with a strings. That means string kinds of data you are having inside that particular, let's say file. Sometimes the strings will be too large to fit into the context window. That means your input size may be too large, okay, to fit into the model. That means we saw the context window. That means the input limit of the model. Okay, in those occasions we'll be using RAG technique. Now inside RAG technique, the first thing you have to perform, you have to split the documents into smaller chunks. So the first thing, guys, you have to remember, inside RAG you have to split the documents into a smaller chunks. Okay, I'll tell you what is chunks. As of now, just try to remember. The first step you have to perform, you have to split the document into smaller chunks. The second step you have to perform, transform text chunks into the numerical chunks. That means you will be having the textual number, text data. And we know that we can't directly pass the text data to the model, any kinds of AI model. It's not possible we can directly pass the text data. So what I have to do, we have to convert this text data to the numerical representation. That means to the vector representation. Yes or no? Maybe you have already worked with machine learning, deep learning. I think you know. If you are using any image, if I'm using any text, first of all, I have to do the encoding. I have to generate the embeddings. That means the vector, that particular vector will be passing to the model. Okay, so this is what actually will be performing. That means we'll be transforming the text data to the numerical representation. And for this, we'll be using embedding model. Okay, there are different kinds of embedding model are available. We'll be using embedding model for this. Okay, now loaded embeddings to a vector database. That means we have to store these at the embedding to a vector database. If I want to perform the QA operation, if I want to perform the chat operation on top of my custom data, the first thing I have to load my data to the vector database, because vector database is like very powerful database. Okay, very powerful and fast like database. You can't use any kinds of traditional database here. Okay, traditional database doesn't support any kinds of vector store operation. So you have to always use vector database, and there are some vector databases are available. I think you know Pinecone is there, WebAT is there, ChromaDB is there, Fice is there. Okay, then Postgres SQL is there. Now we'll be loading the question and retrieve the most relevant embeddings to the responded. That means after storing to the vector database, we'll be creating the retriever. Okay, and what is retriever? Retriever means it will retrieve the similar kinds of response. Let's say you have asked one question, what is Tesla? So the information you have given to the model, it is also related to Tesla information. Now it will retrieve the information related Tesla, like what is Tesla? So what are the similarity, let's say results it will get, it will try to extract, it will try to retrieve. Okay, this is called retriever. Then send the embeddings to the LLM to format the response properly. That means we'll be sending that question as well as the retrieved output to the large language model, and large language model will process and it will give me the answer. Okay, so these are the steps you have to remember if you are performing the RAG system. Now we'll be breaking down each and every component. I will try to understand like what is chunks and how to, let's say, do the splitting operation, how to like generate the embeddings with the help of embedding model, how to create the vector store, how to create the retriever. Okay, and at the end I will also show you how we can create the complete RAG application. Okay, so these are the part we'll be discussing one by one. I hope guys, is it clear? So how we can overcome this issue if you are having huge amount of data, and if you want to give this data as a context to the large language model, in that case what we'll be doing, we'll be using RAG technique. So inside RAG technique there are 5 steps we have to perform. We split document into chunks, transform the text chunks into numerical representation, load the embeddings to the vector database, create the retriever, and we'll be sending the retrieved output as well as the query to the large language model, and large language model will give me the response. Okay, this is the entire idea. So this is what we'll be learning, and we can use any kinds of custom data. Let's say the first question I have asked you, remember? So tell me about DS with Bapi, and your model was not able to give me the answer about DS with Bapi, right? Now what we can do, I can create another TXT file here. So let's say I'll give DS with Bapi data. Okay, data.txt. Now inside that I can keep some of the information about my YouTube channel. So what I can do, I can, let's say, open up my YouTube channel. I will go to the about section and I'll copy, and this information you can keep inside the TXT file so that I can pass this information to my large language model. Okay, just let me reformat it. Okay, so this is the information about my channel. So whenever I'll create the RAG application, that time I'll tell you. Okay, now after creating the RAG, your model will be able to give me the response related DS with Bapi as well. Okay, that means I can use any kinds of custom document right now. It is possible. But before that, we'll be learning some steps. So these are the steps we'll be learning. How to perform the chunking, how to let's say convert our text to the numerical representation, how to store to the vector database, and how we can create the retriever. Then at the end, we'll be running the RAG technique. Okay, so this part will be covering in the next session. Next session, we'll try to wrap up everything. Whenever I'm talking about RAG, actually, we'll be performing, these are the steps inside RAG. That means these are the components you are having inside RAG. So first thing, we'll be splitting the data into smaller chunks. Then we'll be transform text chunks into numerical representation with the help of embedding model. Then we'll be loading this embedding model to a vector database. Okay. Then we'll be loading the question. We'll be actually creating the retriever. Then with the help of this retriever, we'll be passing the retrieved answer to the large language model as well as the question. Then my large language model will be able to give me the response. Okay, with respect to that. So these are the actually component we'll be trying to understand. Okay, so first of all, let's try to discuss about this one is splitting. So here I have already written. So first of all, we'll be discussing about is splitting. Okay, this one. So what is splitting and why we should perform the splitting operation and why it is required. So first of all, we'll be discussing about splitting. Splitting. Splitting or splitter. See, what is a splitter? It's nothing but divide a large data asset in small parts. Okay, so this is called actually splitting. Now let me show you one example what I'm trying to say. So I already have one example, just let me show you. So this is the example, guys. You can see, let's say you are having one let's say a large amount of data. Let's say you are having one original text. Let's say you have loaded this data from the TXT file, PDF file, okay, JSON file, or any kinds of file. You have loaded the data, and let's say this is my entire corpus. Okay, this is my entire corpus. Now what I told you, I can't directly pass this data to my large language model. It's not possible because large language model is having some input limit. Okay, that means context window, fixed context window. Okay, so what we can perform splitting. What is splitting? Splitting means you will be actually dividing the large amount of data in a smaller part. So let's say this is my entire data, and now after splitting you will see that you will be getting different chunks. So this is your first chunks, this is the second chunks, this is the third chunks, and this is the fourth chunks. Now how it is creating the chunks? So there are some technique we'll be following to perform this splitting operation. So we'll be using something called recursive character text splitter. Then we'll be using something called character text splitter. Okay, these two methods will be applying. Then we can divide this larger amount of data in a smaller part. Now you can see inside the text actually you will be having new line. Okay, new line. So why am I talking about new line? Let me show you one example. So let me open up my previous example. So inside data, so if I open this particular file, let's say bgood.txt, now you can see after this line there is an empty space. Okay, there is an empty space. That means how, see, whenever I'm talking about actually programming language, how program will get to know after this sentence there is a space. Okay, after this sentence there is a space. That means it is starting from here, because by default here it will consider as a /n. /n means new line. Okay, new line. That means after this sentence there is no text. That means you have to go to the new line. Okay, so if you load any kinds of data with the help of Python programming or any other programming, you will see these kinds of actually symbol. Okay, /n/t. So these are the symbol actually you'll be seeing. So whenever you are having the /n, that means it's a new line. That means one sentence is completed and it is talking about the next sentence. Now if you see here this example, so here this is the sentence we are having. Now here we are having a /n. /n means this is a new line. It is writing in the new line. Okay, new line it is writing. So whenever I perform the splitting operation, that means this is considering my first chunks. Okay, now again it is splitting with respect to the /n. With respect to the /n it is splitting. Now this sentence is considering as my second chunks. Okay, now again we are having the /n. Again it will split with respect to that. Then we'll be getting the third chunks. Then there is another /n. It will split. Then we will be getting the chunks 4. So that's how actually we can get the chunks. So that means we are having a bigger data. That means huge amount of data. We'll be applying the splitting operation, and split will split the data with respect to the /n. And here we'll be getting different kinds of chunks. Okay, so this is the idea of chunking. Now you can ask me how we can perform the chunking. Inside LangChain actually we are having two kinds of method. So the first method you'll be using something called character text splitter. Okay, character text splitter. I will tell you how character text splitter will work. Then there is another one called recursive character. I think it's a recursive text splitter or character text splitter. Just a minute. Yeah, recursive character splitter. Okay, so these two methods actually we'll be learning. Now, first of all, let me show you how we can use the character text splitter. So I'll open up my code, and here I'm going to create a file 04. I will name it as, let's say, rag components. Okay, so here I'll select the kernel. I'll select this kernel. Fine. Then after that, first of all, I'll be loading the env file because I will be using the OpenAI model. In case you can use any other model, you can use Grok model or any model, you can use it. It's up to you. So let me load this OpenAI API key. All right. Then the next thing we'll be loading that data. So inside data, we are having different kinds of data. We are having HTML, PDF, TXT. So let's load one TXT data. So here I'll be loading this data actually, bgood.txt. So you can see this data actually I'll be loading, and you can see this data is a little bit, bigger data. You can see we're having huge amount of text inside this file. Now I can't directly pass this data to my large language model. For this, first of all, I have to perform the splitting operation. That means we'll be dividing the this bigger text to smaller chunks. Okay, this is the idea. Now, first of all, let me load the data. So this syntax will load the data. I think you remember. Now this is the entire loaded data. Okay, entire loaded data. Now, if you want to see the page content, simply you can call the page content. You'll see the content of the data. Now, if I want to use character text splitter, this is the syntax, guys. Okay, you can see. First of all, you have to import a character text splitter from the langchain underscore text dot splitter. Okay, so from here you have to import this particular character text splitter. After that, you have to initialize one object of the character text splitter, and it will take some of the parameter. So the first parameter, it will take separator. Okay, separator. Now you can ask me what is separator. So here I have given one example. So I already told you, whenever you are loading any kinds of data. So if I show you with the help of langchain, I loaded the data. Now you can see this /n is visible. Yes or no, guys? So if I show you the data, this /n is visible. See, okay, /n is visible. That means /n means it is referring the new line. That means after this line, okay, another line will start. Okay, which is nothing but this one. So that's why we are having this kinds of separator. So what I'm telling, so wherever you are getting this /n, that means if you see here, we are having the /n. See, /n. Okay, /n. So wherever you are having the /, so you can see / we are having also here. Then if you find here, you are having most of the /. Okay, /. So wherever you are getting the /, try to separate the data with respect to that. And chunk size I'm giving 1000. That means what will happen? So let's say here you are, this is the entire corpus. So let me clear. Let's say this is the entire corpus. So whenever it is creating the first chunks, okay, so let's say it will create from here. Then here, what is the parameter I have given? I have given chunk size is equal to 1000. That means it will count 1000 token. So let's say this is first token, second token, third token, fourth token, fifth token. That's how it will count. How many, guys? 1000. Let's say in this sentence we are having 1000 tokens. That means it will consider as my first chunk 1. Okay, chunk 1. So first of all, it will count 1000 token, whether it is having or not in this particular chunk. Then it will try to split that particular sentence. Okay, otherwise it won't be splitting. Okay, so this is the parameter you have to assign. Now you can ask me how to define this chunk size based on the model context input. Let's say if your model is taking 4096 token as an input, that time you can keep 1000 chunk size. Okay, so I've seen most of the people, they are using 1000 chunk size, and chunks overlap they're using 200. Okay, now you can ask me what is chunks overlap. Chunks overlap means you are overlapping the chunks. That means whenever you are creating the second chunks, second chunks again, it will start from here. Yes or no? It will start from here. But what you have given chunk overlap is equal to 200. That means it will go back 200 tokens. That means it will go back 200 tokens. Let's say 1, 2, 3, 4, 5. That's how it will go back 200 tokens. Let's say 200 tokens ends here. Then it will start the chunks from here. Then again it will count 1000. 1, 2, 3, 4, 5, 6, 7, 8. Let's say 1000 ends here. Okay, ends here. So this is going to be your chunk 2. Okay, so this is called chunk overlap. Now you can see there is an overlap. Okay, there is overlap you got. And with this overlap, okay, with this overlap, your model will try to understand after this sentence is coming, because there is an overlap. There is a common token is coming. Okay, that's how your model will automatically get to know after this particular sentence, this particular chunks is coming. Okay, after this chunks is coming. That's how you have to perform for all that, let's say, data you are having. Okay, unless and until this chunks is getting over, So you'll be keep on applying this particular chunking, and you don't need to manually perform. So LangChain will automatically take care. So with the help of this character text splitter, will be automatically performing this thing. But I showed you, okay, what will be happening internally. So whatever code they have written internally, they are doing like that. That means they are looking for these kinds of double slash. They are separating the data. They are counting the chunk size first of all. If chunk size is missing, then they are also checking the chunks overlap, like how many chunks overlap you have to take care. So based on that, you will be taking the chunks overlap. Then what you will be doing, you will be creating the next chunks. That's how you have to complete for all the data you are having. And after that, you will be getting your chunk, like how many chunk you will be getting, okay, after splitting your entire corpus. So this is the idea about chunk overlap as well as the chunk size. Got it? And length function, because it should count like how many tokens it is having, okay, and how it will count with the help of length function. Okay, is separator regex is equal to false, so you don't need to give it true. Just try to keep it as false. Let's say you want to use any regular expression and all that, I mean that regular expression you can also use. Okay, so this is like very powerful function they have created. You can send so many parameter. So if you go to the documentation of character text splitter, you will see there are so many let's say parameter it can take. But we are not going to use all the parameters. Just keep it everything as default. Only you just need to change this chunk size and chunks overlap. Okay, these two you have to change. Let's say you don't need chunk size 1000. You want to increase. In case you can increase, and if you want to decrease, in case you can decrease. Okay, that's how you have to change the parameter. That's it. Okay, so now let me execute and let me show you the output. So now this is the final code. So you have to call this object text splitter. Then there is a function called create documents. Inside that you have to pass your documents. So the documents actually we got. Okay, so we are giving the paste content only. Okay, the text only. You can see inside that I'm passing the text. Now see if I execute, so it will have all the chunk right now. See, so how many chunks it has created? If you want to see that, just pass it to the length function. So it has created two chunks. You can see first document and second document. All right. Now, if you open this TXT file, this bgood TXT file, now you can see the first here. So if you count, okay, if you count all that token, that empty token also, you will see that it is, getting 1000. Okay, 1000 token, because this empty space would be also counted. Okay, that's why you can see in the first chunks it is getting this one, bgood, and the second chunks it is getting this one. Okay, this is the idea. Now you can take any big document and you can try. You will see that it will create so many chunks. So later on, whenever we'll be creating the RAG based application, that time we'll be loading the bigger documents. Okay, that time I'll show you, it will create so many chunks for you. Okay, now if you want to see them, simply you can give the ID. Let's say I want to see the first chunks. This is the first chunks. If you want to see the second chunks, you can also see the second chunks. Okay, this is called actually character text splitter. Character text splitter. Now the second splitting we'll be learning called recursive character text splitter. Okay, this one. And for this you have to import it from the LangChain. So this is the syntax: LangChain text splitter, recursive character text splitter, and this is the syntax. Okay, recursive character text splitter. Now you can ask me how recursive will work. So let me first of all give you one text and let me show you how it will work. So what I'll do, I'll just try to pass the text. So here is the chunks I got. Now see how it is working. So let me open up my Blackboard. See, whenever I'm talking about recursive character text splitter, so it will actually perform the splitting with recursively. Okay, what is recursive? I think you know. Recursive means repetitively. That means first of all it will split the documents with respect to double slash. Okay, double slash. Sorry, double slash n. Okay, double slash n. You can see double slash n. Okay, so once double slash n is completed, then it will actually split with respect to the single slash n. That means in some times actually you'll see in the text you will be having single slash n as well. Let me show you. So here, see, there you will get double slash, then you will be also getting single slash. See, single slash. That means two kinds of slash n you will be getting. One is the double slash. Double slash means two new line, and single slash means one new line. So first of all, it will split the documents with respect to double slash n. Then it will again it will apply another loop. Okay, so let's say in the first loop, it will first of all split with respect to the double slash n. Okay, then inside that they will be performing another loop, let's say second loop. Then it will split the document with respect to the single slash n. Okay, then it will perform the splitting operation. So this is what actually recursive character text splitter. That's why they are calling it recursive. That means they are performing recursively. Okay, this is the idea. So both technique you can use. Okay, with the help of both technique you can split your data. Either you can use character, either you can use recursive. Okay, both will work fine in that case. Okay, so we have learned the first technique, which is nothing but our splitting. Okay, splitting. Now what is the second technique? Second technique is nothing but I have to know how to do the embeddings, like how to generate the embeddings. Okay, so let's try to see how we can generate the embedding. So for embedding, we'll be again opening this file. And I can comment it. So what is the embedding? Here I can comment. So embedding is nothing but here transform the small parts of the text into the number, that means vector, that are easily stored to the vector store and searched by the vector database. Okay, so how we can like generate the embeddings? For this, what we'll be using, guys, we'll be using embedding model. Embedding is also a large language model. Okay, it's a large language model. With the help of that, you will be generating the vector embedding. Show the embedding model. Okay, so you can load different kinds of embedding model. So here I'm going to load OpenAI embedding model. So OpenAI is having also embedding model. You can see OpenAI embeddings. Okay, embedding models. So it is having different embedding model. See, text embedding 3 small, text embedding 3 large, text embedding ADA. So that's how it is having different kinds of embedding model. Okay, so let's load one embedding model. So by default, I think it will load this model, text embedding ADA. Okay, this model maybe it will load by default. So let me load this embedding model. Okay, that means what will happen? So here we'll be using embedding model. So let's say this is my embedding model. Okay, embedding model. And he will be giving the input text. Okay, and this will return you the vectors embedding. That means numerical data. Okay, numerical data. Okay, so that you can store it to the vector database DB. Okay, this is the idea. Now let me show you. So let's say here I'll be taking list of the sentence. Okay, so chunks of text we are having, let's say hi there, hello, what's your name, okay, James Bond, and so on. Now we'll try to convert these at the sentence to the numerical representation. So for this I'll be passing this list to the vector embedding model. You can see embedding model.embed document. So this document I'm passing inside the embedding model and it will give me the embeddings. Now you can also see the embeddings. Let me show you. See, this is the embedding, guys. Now you can see this is the numerical representation. Okay, numerical representation. I can see it's a minus 0 you are having. You can also see the plus 0 as well. Okay, that means it's a coordinate. So it has created one higher dimensional coordinate space. So that's how it has created one coordinate space. Okay, and these are the coordinate number. Okay, like minus coordinate, plus coordinate, I think you know. That's how it is storing the vector. Let's say this vector will store here, another vector will store here, another vector will store here, another vector will store here. Okay, that's how it is storing the vector in the multi-dimensional space. Okay, based on that, it will decide which vector is closely. Let's say these are the vector are close. Then these are the vector are close. Okay, these are the vector are close. So that's how it will make a cluster. And whenever you are doing the similarity search operation or vector search operation, that's how it will identify. Let's say if there is any another vector, let's say this vector is there. Now this vector is close to this particular cluster. That means this cluster it will consider. So that's actually it is performing similarity search operation. I can see this is the vector representation, entire vector representation of your data. Okay. Now if you want to see the dimension, what is the dimension of the OpenAI embedding? So this is the dimension. You can simply check the length. See, 1536 dimensional vector you are getting. That means one sentence. Okay, one sentence is representing in the 1536 dimensional space. So as a human, we can only visualize 3-dimensional, guys. This is a 3-dimensional, but our data is storing 1536 dimension. Okay, it has created 1536 dimension. Okay, in that space actually it has stored all of my embeddings, all of the vector. So as a human being, it's not possible for us to visualize that one. Okay, I hope you got it. So now let me open up my code. Now if you want to see the first 5 numbers, you can also do the list slicing, because at the end it's a list. Okay, you can see the first 5 number. Okay, yeah, and these are the pre-trained model. Okay, the model actually we are using, these are the pre-trained model. So that's why these are the vector is pretty good. If you give to the model, so model can understand easily. Okay, this is the idea. So we have learned how we can perform the splitting operation, and we have also learned how we can convert our text to the embeddings. That means vector representation with the help of embedding model. Now the next thing we'll be learning about vector store. Okay, we'll be learning about vector store. Vector store, that means vector database. So there are some vector databases are available, like ChromaDB is there, Fice is there, Pinecone is there, WebAT is there. Okay, then PostgreSQL is there. Nowadays actually Red Hat also created the vector database. That's how we are having different kinds of vector database. So let me show you some of them. So what is vector database? Vector database is nothing but it stored the embedding in a very fast searchable, it stored the embeddings in a very fast searchable database. Okay, this is called actually vector database. Now let me show you some of the example of the vector database. First of all, let me show you the ChromaDB example. So this is the ChromaDB. You can see if I want to plot the ChromaDB, guys, if I want to import the ChromaDB is already available inside LangChain Chroma. Now if I open the requirement.txt, so LangChain Chroma we haven't mentioned. So first of all, we have to install one package. So this is the package, guys, we have to install called LangChain Chroma. Okay, so try to open up your terminal and try to install the requirements again. Then it will install the LangChain Chroma. So LangChain, what they did, they created separate library for the vector database. Let's say you want to use LangChain ChromaDB, you have to install LangChain Chroma. Let's say you want to use any other vector database, that time you have to install with respect to that name. Okay, so that's how they have created different kinds of functionality. So here we are importing the Chroma from the LangChain Chroma. You can see. Then we are loading the text loader. That means we'll be loading the text embedding model, because first of all I have to generate the embeddings from the text. And why splitter? Because my data would be huge. Okay, first of all I have to create the chunk. Okay, with the help of that chunk actually we'll be creating the embeddings. That means it's a step of execution, guys. Try to remember, first of all you have to load the data with the help of text loader. Then you have to perform the splitting operation. That means you can see I'm performing the splitting operation. After splitting, we are getting the chunk. So with the help of embedding model, we'll be creating the vector embedding. Okay, and this particular vector embedding will be storing to the vector database. So this is the step of the execution. So here I have already written, I think, remember. So here split numerical representation, then load the embeddings to the vector database. Okay, then we'll be getting the retriever. Then we can perform the RAG operation. That means we can perform the query operation on top of it with the help of large language model. So here is the example. First of all, I'm loading the data. So I'm loading this data actually. So inside the data, I'm having one file called state of union.txt. So state of union.txt. So this is the data actually I'm loading. Okay. After that, I'm performing the character test splitter, and chunk size 1000, chunks overlap 0. I haven't given any kinds of chunks overlap. Then I'm splitting the data. Okay. Now let me show you how many chunks you will be getting. So this is the chunks. See, you are getting so many chunks. So let me show you the length. You are getting 42 chunks here, guys. 42 chunks you are getting. Okay. Now, this thing, what I will be doing will be generating the vector embedding, okay, and will be storing to the ChromaDB. And ChromaDB is nothing but it's a local database. So it will store everything in your memory. In memory, it will store the data, guys. Okay. Always try to remember ChromaDB is a local vector database. So for this, you have to give the chunks, okay, inside the ChromaDB. So there is a function called from document. You have to give the entire chunks and you have to give the embedding model. So what it will do, it will take the embedding model. That means it will perform this operation. It will take the input data. It will take the embedding model. It will give you the vector store. Okay, vector embedding, and it will store to the vector database, which is nothing but my ChromaDB. Okay, so this is what actually we are doing in this line. And with the help of one line, actually we are able to perform because we are using LangChain. Okay, if you are not using LangChain, that time you have to write the manual code. So that's why actually we are using LangChain. LangChain is a complete orchestration framework. So it will give you all kinds of functionality so that with the help of very less line of code, you can perform all the jobs. Okay, now let me execute. See, it is storing. It is converting all of the data in the like vector representation, and it will store in the vector database. Okay. Now, see, it has loaded. That means this vector DB, this is my object right now. This is my vector database object right now. You can see this is an object. Now I can perform similarity search operation. Okay. That means, let's say here I will be asking one question. What did the president say about the John Lewis Voting Rights Act? So if you open these documents now, so it is related this John Lewis and all. So these are the information we are having. Now here what I'm doing, I'm calling the vector database object and I'm performing similarity search operation. So this question I'm giving, that means what will happen? So whenever you are asking this question, it will go to the knowledge base, that means to the vector dimension, and here it will search the similar results. Okay, similar results from this particular vector, and it will give you the similarity response. Now let me show you. So these are the similar results I got, guys. 4 similar results you got. Okay, but I don't want this kinds of output. I want the exact output. So the question I have asked, I want the exact output. Let's say this question, if I ask to the ChatGPT, okay, if I ask to the ChatGPT will give me the exact answer, yes or no. See, it will give you the exact answer. Okay, exact answer. What is the answer actually you are looking for? But in case here I'm not getting the exact answer. Okay, I'm getting the similarity answer only. Okay, so how to get the exact answer for this will be connecting our large language model. So whenever we'll be creating the RAG, that time I'll tell you, okay, how to connect the large language model. As of now, we are only doing the similarity search operation. Okay, this is the idea. Fine. Now there is another way you can retrieve the information. So this is called actually retriever. Let me show you one retriever example. Vector store as retriever. That means finding the embedding the best answer your question. So it will give you the retrieve output. Even it will also show you the metadata. That means source document, like from where it is retrieving the data. So let me show you one example. So what I will do now, let me show you another vector database example. So first of all, let me load one data. So I'm loading the state union txt again. Then we'll be using FIAS. Okay, FIAS is another vector database. You can see FIAS is another vector database. Again, it's a local vector database. Okay, it will store the data locally. Now again, I'm importing OpenAI embeddings and character text splitter. First of all, loading the documents, doing the chunking. That means creating the chunks, doing the splitting operation. After that, initializing the embedding model. And you can see inside FIAS, I'm giving the chunks as well as my embedding model. That means it will convert my text to the vector embedding and it will store to the vector database, which is nothing but FIAS. Okay, and it will give me the vector DB object. So this is the vector DB object. Okay, now we'll be creating something called retriever. How to create the retriever? That's how we can create the retriever. Vector DB, there is a function called as retriever. Okay, as retriever. See, always try to remember, whenever you are creating RAG based application, you have to use this function as retriever, not the similarity search. Okay, similarity search. So we won't be using this method. We'll be using this method because this is more powerful. Why? Let me show you. So let me ask one question. So I'll be asking this question. The retriever.invoke, what did he said about Ketanji Brown Jackson? Okay, let's say this is my question. Now if I show you the response, see, it will give you by default 4 response. Okay, 4 response, 4 retrieved output. Now you can see it is also giving you the meta sources, like which document it is referring, from which page content it is giving you the information. See, it is giving each and everything. Okay, these are the most relevant answer it has filtered out from the TXT document, the documents actually you have given. Okay, see, it is referring this document actually. Okay, so that's why it is more powerful than your similarity search, because similarity search is not giving this kind of particular metadata information. But I want to understand which document it is referring, which line it is referring. Okay, if I want to understand, I'll be using the retrieve at that time. I hope it is clear. Okay, now if you want to see the length, simply you can also see the length. So here it has given me by default 4, because add retriever it will give you by default 4. Okay, 4 response. You can also tweak this parameter. For this there is a parameter called top k. I'll tell you how to change the parameter. So let me show you how we can change the parameter. So whenever I created the retriever, so here I can mention this parameter, search keyword. Here search keyword k is equal to, so here if I give 2, it will only give me 2 answer. Let me show you. See, now it has given me 2 answer only. Okay, 2 retrieve output. If you give 3, it will give you 3 answer. So this is called k parameter. Okay, see, 3, but by default they said 4. Okay, it will give you 4. If you give 1, it will give you only 1. Okay, so what we have learned, first of all we have learned that a text splitter, that means we have learned about the splitter, how to create the chunks. If you are having bigger document, how to convert into the smaller chunks. After that we have learned how to do the embeddings. That means we'll be using some embedding model. Okay, with the help of that we'll be generating the vector embedding. After that we learn how we can store these are the vector embedding to the vector database. Okay, I showed you some example of the vector database. Then we have learned how to perform the similarity search operation here. Okay, then I told you we'll be using something called retriever, because retriever is more powerful, because retriever gives me the sources. Okay, sources as an output as well. Okay, so this thing actually we have learned. Now with the help of these are the components, we'll be creating one RAG system in the next class. This is the agenda. So inside RAG component you are having these are the component. So first of all you have to split the data, then you have to generate the embeddings with the help of embedding model. Then you'll be storing that embedding to the vector store, that is vector database. Then you'll be creating the retriever, and if you want you can also set the top k parameter. Then what you can do, you can perform the retrieve operation, either you can perform similarity search operation. But whenever actually I was performing the retriever operation, similarity search operation, so it was only returning the similar kinds of response. Okay, like the best results actually it was returning around 4 to 5 response it was returning, but that is the answer I'm not looking for. I'm looking for one accurate response. So if I want to get the accurate response case, what I have to do, I have to connect my large language model. Okay, after connecting the large language model, we'll be able to get the correct response from the let's say custom documents, whatever I'm asking. So this thing I'm going to show you how we can connect our large language model with our custom data. Okay, so first of all I will draw the architecture what we are going to perform, then I will start with the coding. So here we'll be implementing one basic RAG. Okay, and whenever I'm talking about RAG, that means I'm talking about my custom data. So it can be any kinds of document. So let's say here I can consider custom. Okay, custom data. So it can be any kinds of data format. It can be PDF, it can be TXT, it can be Excel, XML, JSON, anything you can consider. Okay, so I'm just calling as a custom data as of now. So first of all, what I have to do, guys, this custom data, anyone remember? If I want to perform the RAG operation, so I can't directly pass this data to my LLM. Okay, so for this, first of all, what I have to do, I have to perform the splitting operation. So we'll be performing the splitting operation. Okay, splitting, or you can also call it a chunking. Chunking. So after getting these chunks, what I will do, we'll be using one embedding model. Okay, embedding model. So in case you can use OpenAI embedding model, you can also use some open source embedding model, you can use Grok API, it's up to you. Then after that, we'll be creating vector embedding. Okay, we'll be generating the vector embeddings. Then we'll be storing this vector embedding to the vector database. Vector store, or you can also call it as vector database. So this will become my knowledge base. This will become my knowledge base. Okay. Then what will happen? User will, let's say this is the user. User will ask some query. And your vector is stored. That means you will be creating a retriever here. Retriever. Okay, retriever here. So it will give you some rank results. Rank result. Okay, based on the k parameter. So here I can write top k. Okay, based on the top k parameter. So let's say it has given you 3 response. Okay, 3 response. Let's say k is equal to 3. It will give you 3 response. Now I don't need the 3 response. I need accurate response. Okay, let's say here I'm asking. Let's say here I'm asking. Let's say what I can ask. Let's say what is the capital of India? So as a return, guys, what should I get? Okay, as a return, what should I get? Definitely Delhi, right? So it should give me the Delhi, but here it is giving me some rank results. So let's say it is giving some content related Delhi, and apart from which is, let's say, relevant to the Delhi, it is also giving me that one, but I don't need. I need the accurate response. So for this, what I will do, I will use my large language model. So here we'll be using large language model, LLM. Okay, so in case actually we'll be using like ChatGPT model, but you can use also any other model. You can use Grok API, it's up to you. So here what we'll be doing, so the rank results actually you are getting, so we'll be passing this rank results to my LLM. Okay, we'll be passing this rank results to my LLM, and whatever question user is asking, okay, the question also I'll be passing to the large language model. And now what will happen? Large language model got the context. So this is called context. This is called context, okay? And this is called query. This is called query. I think you remember. I showed you one example. So here, let me show you. So here, I think DataLoader RAG demo. Wikipedia loader. I think whenever I was talking about Wikipedia. So here, can you see here what I was doing? I was searching about Tesla, and whatever data actually I was getting, I was passing as a context, okay, to my large language model. Then I was also giving the question, like, tell me about the Tesla, the same thing. But now what we are doing, we are doing some more step because my data size is huge. So first of all, I have to split the data. Then we have to create the embeddings. That embeddings will be storing to the vector database. Then what we'll be doing, user will give some query, and this query actually will go to the knowledge base. Knowledge base will return some rank results, and this rank results I'll pass to my large language model as a context, as well as the query. Now LLM will process, okay? LLM will process, and it will generate a accurate response. Okay, accurate response for you. Response for you. So to the user. Okay, to the user, it will give me the response. Okay, so this is the entire RAG architecture. Okay, I hope it is clear. So as of now, we have created till retriever. Okay, we haven't connected our large language model. Now we'll be learning how we can connect the large language model. Okay, so now let's try to implement this architecture through our code. So let me open up my VS Code, and here I'm going to create a file. So let me name it as 05 RAG, basic RAG, implemented. So the first thing what we usually do, guys, first of all, we'll be loading the OpenAI API key from my environment, because here I'm going to use the ChatGPT model. You can also use Grok model. Okay, Grok. You can also use Grok API to load the model. Now the next thing, RAG component, and there I showed you the retriever, how to create the retriever. So first of all, we load the data, then we perform the like chunking operation, that means splitting operation. Then we use embedding model. We create a vector store with the help of vector database. Then we create the retriever. And whenever you are asking something into the retriever, it will retrieve some relevant information, okay, with the help of metadata as well. Okay, so till here we have done. Now we'll be learning how we can connect the large language model. That means the information I'm getting from my retriever, I'll pass to the LLM, as well as I'll also pass the query. Okay, whatever query user is asking, based on that, LLM will try to process and it will give you the accurate response. So for this, you can see this code is already familiar with you. So I'm importing the FIAS. FIAS is a vector database. Then OpenAI embedding, because I need an embedding model to generate the vector embedding. Then character text splitter I need for creating the chunking. Okay, so let me import all of them. So first of all, I will load the data. So let me load one data. But before loading the data, I need to import this library as well. So text loader. So I'll be loading one TXT documents. So this TXT document will be loading a state of union TXT. So let me load it. So this is my data. Now you can also see this is the entire data we have loaded. Okay, now the next thing will be creating the chunking. We'll be doing the splitting operation. So this is the code snippet. So here you can see I'm given chunk size is equal to 1000, chunk overlap 0. And whatever document I have loaded, I'm passing to the split document. Now it will give me the chunk. So you can see the complete chunk. See, that many of chunk it has given me. If you want to see the length, you can also check the length. So 42 chunks it has given me. Okay. Then what we'll be doing, guys, will be loading the embedding model, and we'll be creating the vector embedding, and we'll be storing in the FIAS vector database. Okay, so let me do it. So it has created one vector database, and it is storing in your disk, okay, local disk. And now we'll be creating the retriever. So this is my retriever, guys. Okay, and by default, how many retrieve parameter actually it will have? I think you know. By default, it will have 4 retrieve parameter. Okay, 4 retrieve parameter. You can also test. So let me show you. So I'll be asking one question. So retriever.invoke, what did he say about Ketanji Brown Jackson? So if you open this documents, so you will see the information related Ketan G Brown Jackson. Now if I ask it, so it will give me some response. See, it has given me 4 response, 4 relevant response. Okay, now you can also play with this parameter. So I think you know there is a top k parameter. You can set search kw args is equal to k is equal to 1. That means it will give you only one information. Okay, so let's say I want to take 3. Okay, 3 information. Now if you ask the question again, now see, guys, your response would be 3. Okay, you can see you got 3 information. Okay, now you can play with this parameter. It's up to you. Fine. Now we'll be creating the RAG. That means we'll be connecting our large language model right now. And here we'll be using LangChain expression language. Simple use with LangChain expression language. Okay. And today I'm not going to discuss like this LangChain expression language. For this, I'll be keeping one dedicated session. Okay. So now let's create the chain. So before that, first of all, I need to import some library. So here is the library, guys. So first of all, I'm importing Chat OpenAI. Why? Because we'll be using Chat GPT model. That means GPT 3.5 turbo model. And I'll be using Chat completion model, not the completion model. And Chat prompt template. Why? Why Chat prompt template? I think you know. Whenever I want to give any, let's say, input to my large language model, that means if it is a chat like a completion model, that time I also need to pass the system prompt. Okay, system prompt as well as the user prompt. So for this, we'll be using the Chat prompt template. We'll be creating the prompt template. Okay, then we'll be passing the prompt. Then this is the new thing, guys. LangChain as proposed, it is available in the second generation LangChain, which is called LangChain expression language. And to perform it, you need these are the library: str output parser and runnable pass-through. Okay, there are some more, let's say, functionality they have created. I will discuss each and everything. As of now, just try to get it as a high level. So if you want to use this LangChain expression language, you need these are the functionality from the LangChain. Okay, LangChain core, output parser, output str output parser, and runnable is equal to runnable pass-through. Okay, now let me import all of them. Now, first of all, I'll be creating the template. So this is my prompt template. So first of all, I'll be creating the prompt, then I'll be creating the prompt template. So this is the prompt. Answer the question based on the only the following context. That means user will give the context. Context means the retriever, okay, the vector database. Okay, this context as well as the question. Okay, so here I've already written the diagram. So it will first of all give the context to the LLM as well as the question, whatever question user is asking. Okay, now if I want to create the prompt template, I'll be using this chat prompt template function. So see guys, chat prompt template, and here I have to give the template, and this will give me the prompt. Okay, now I'll be initializing my OpenAI model. So here we'll be using chat OpenAI. That means we'll be using GPT 3.5 turbo model. Okay, great. So let me execute. Now here I'll be creating one function. I'll tell you why we are creating the function as of now. Just try to remember this function will format the output. Okay, so now this is the chain, and you can see the syntax is written with the help of LCEL. That means LangChain expression language. See, chain is equal to, I have given a bracket. Again, I have given a bracket. Now here I'm writing the context is equal to retriever, because you remember what is context? Context is nothing but my rank results. Okay, the retriever. So this thing I have to pass to the LLM. So you can see this is the retriever I'm passing. And format documents, this function object I'm giving. Okay, format documents, and question is equal to runnable pass through. Okay, now you will have some doubt. I know that initially if you're starting with this LangChain expression language, this would be confusable for you. No need to worry. In the next session, I'll try to discuss each and everything about this LangChain expression language. As of now, just try to remember whatever input user will provide. Okay, this input will come here as it is, and it will save inside the question. Okay, question actually a parameter. Then the prompt we have prepared. See, this is the prompt we have prepared. Then the model, then the output parser. That means what is happening? Let me show you. So I'll open up my annotator pen. Let me select the color. See, first of all, you are see, you have given the bracket. So this bracket is called parallel. Okay, parallel runnable. I'll tell you what is parallel runnable. It will run everything as parallelly. You can see I have given too many statements. So this is the first statement, retriever. This is the second statement, that means the function object, and this is the third statement, which is nothing but the input. Now you can see here is a pipe symbol. And what is pipe symbol? This is the LCL symbol, LCEL, LangChain expression language. Okay, so with the help of this pipe symbol, we create this actually chain. Okay, now I'm giving the prompt model as an str output parser. So what will happen? First of all, you are executing this one actually. Okay, that means your context and input will come. So let's say user has given what is Tesla. Okay, what is Tesla? This is the question. So this question, where it will go to the prompt template, and it will create the prompt template. I think you remember. So how to create the prompt template? That's how it will create the prompt template. So answer the question based on the following context. So context, that is retriever. Retriever will come in the context, and question, whatever question. Let's say what is Tesla? Tesla will come inside that question. Okay. Now this question, where we have to pass to the model. You can see we have to pass to the model. That means this question will go to the model. That means my large language model, and model will give me what? It will give me response, yes or no. Okay. And I think you know, whenever we are getting the response from the LLM, so what format it will return? It will return as a AI message format. Okay, but I only need the content of it. And if you only need the content, you have to use this str output parser. I think we have already learned output parser. Remember, inside I think DataLoader, not DataLoader. I think inside this one, talk with LLM part 2, we have learned about output parser. So with the help of output parser, we can format our output. That means if I want to get a JSON output, if I want to get a TXT output, everything you can customize here. So this output parser will by default will return as a string output, str. Okay, str. Okay, so this is what actually we are using. That means first of all, we are giving the context, then we are taking the input from the user. We are saving into the question variable. Okay, then format documents. What format documents will do? Whatever response actually it will give you. Let's say, see what happens actually whenever we perform the retrieve operation. Let me show you. So here is the retrieve operation. See, whenever we perform the retrieve operations, what happens? It will give you, these are the retrieve output. Okay, these are the retrieve output. But here what I need, I only need the page content. I don't need the metadata information. It's not required. I only need the page content. So what will happen? This function will automatically filter out only page content. Okay, I don't need the metadata. I only need the page content. So this will extract the page content and it will return. Okay, here. Okay, and this input will go to the model. Okay, first of all, it will create the prompt, then it will go to the model and it will give you the output. Now let me show you. So here I'll be asking one question. So the same question will be asking chain.invoke, what did he say about Ketanji Brown Jackson? Okay, now let me execute and let me show you the response. See guys, this is the response, and if you see the type, it will be string. Okay, it says str because of that output parser. Okay, so this is what our basic LCEL, that means LangChain expression language. Okay, but previously I think you remember, those who have already worked with this one older version of the LangChain, we used to use chain functionality. I think remember chain functionality. We used to import I think chain. Okay, instead of using the like default chain from the LangChain, we have created the LangChain expression language. And see, always try to remember, it's not like that this inbuilt chain has been deprecated. No, still LangChain suggests to use that chain as well, chain functionality as well, because still chains is under development. Okay, still the chains under development. That's why LangChain is also suggesting you have to use the older technique if you want to create any kinds of project. I'm getting the correct response right now. Okay, from my application. Previously it was only giving me the related information. Now I connected my LLM. Okay, now if you ask any kinds of query, it will give you the accurate response. The architecture we have drawn, see, accurate response.
Hi guys, in this video we'll try to understand what is model inference. So I think you already know what is model inference because previously I already showed you how we can work with the large language model. Let's say here we have a LLM. Okay, LLM. So first of all, we just try to use the LLM. Either you can like download it from the Hugging Face, either you can use this LLM with the help of API request. Let's say if I'm using OpenAI, so OpenAI has one API key. With the help of that we can access this model. So what is the inference? So inference means, let's say here you are giving a let's say input, and here you are getting a output. Okay, this is called model inference. So I think you remember we did one fine-tuning let's say demo. So there I showed you how we can fine-tune Llama 2 model. Okay, so after fine-tuning, what I did, I just pushed this model to the Hugging Face hub. Okay, Hugging Face hub. So from the hub itself, again I just downloaded the model, okay, in my Google Colab, and there I did the inference operation. Okay, inference operation. So that's how actually guys we do the model inference. That means here after training, or let's say if any model is available, you are calling the model, you are giving the questions, and you are getting the response from the model. Okay, this is called model inferencing. Now here you can either use API key to access the model. Either I showed you how we can get the model from the Hugging Face hub, or there is another alternative way I'm going to show you. This is the free one. So here you don't need to pay. So there is a platform called Grok. So from there also you can access the model. Okay, and again this is another LLMOps platform you can talk about, because it provides the API, because the model is already hosted there. Okay, you don't need to worry about the like model download and all. Okay, only you just need to create one API key, and with the help of the API key you'll be able to access the model. Now let me show you how we can use this Grok API to access different model. So guys, just search for Grok Playground and make sure you have to create one account here. So I already have the account. Let me log in. Okay, so I already logged in with my account, and this is the playground, guys. So you can see the interface is I mean similar kinds of chat GPT. So here you can send different messages, and you can also give the system prompt if you want, and here you can select different model, and all the latest model is also available, like Llama recently published Llama 4 model. It is also available. Then you can see Gemma model is there. Then from Alibaba, this QWQ model is also there. DeepSeek is there. Then from Grok, this compound beta. Okay, so Grok has also published some model you can also use. Then Mistral, OpenAI has Whisper model, Play AI, okay, and SDAIA. Okay, so I don't know, but again there is another model. So recently they have let's say updated lots of model, okay, in their platform. Now we can access these are the model with the help of API request. So here you can also send the message from this web interface. Let's say if I give hello, I will submit. So it will give you the response. Even you can also upload the image, okay, if you want. Then let me show you the studio. So here is the studio, guys. So in studio, what happens? Let's say you can give the message like that, okay. Even you can create a new message, and right hand side you can see the response, okay. Even you can also change the temperature parameter, max token parameter, okay. These are the thing you can change. Now let me show you how we can access this model, okay, with the help of API request. For this you have to create API key. So there is an option called API key. Just click here. Now here you can create a API key. So previously I created some API key, so let me delete some of the API key here. Then I'll create a new one. So here let's create a API key. I'll give the name, let's say demo. So this is my API key. I'll copy. Now here I already have one code snippet. So first of all, let me add the API key in the environment variable. So what I will do, I'll open up my .env file. So here you can see I have my Grok API, okay. And these are things you can ignore as of now, because I already showed you previously how to use the line graph and all, okay. So I'm using that particular file only. So here we'll try to change the Grok API key only, okay. Make sure you are updating your API key, guys, okay. And this was my open API key. This is not required. So this is the alternative way, guys, if you want to use the model with the help of API request. And again, all the model are hosted there. You don't need to worry about everything. So here you will be getting the quick response. And if you're using low configuration machine also, it's completely fine. Now once it is done, just try to select your environment. Then let's execute the code. So it will load the credential from the environment. Now here you can see I'm importing this Grok from the Langchain underscore Grok. So for this you have to install Langchain Grok. So here you can see this particular package you have to install. So I already installed. Keep install Langchain Grok. If you do, it will install that. Now you can see I'm importing Chat Grok, and inside Chat Grok I'm passing the model. So here I'm using Llama 3 70 billion model. So here I think this model is available. If I go to the playground, Llama 3 70 billion model. So this model I think I'm using, okay. This was the model. Okay, so now let me show you how we can access. So if I execute now, again you can load another model. So here I'm also loading Mistral model. So Mistral also has some model, okay. You can load it. So let me also load the Mistral model. Then here I have the prompt. Let's say I'm giving the system prompt first of all, because this is the chat completion model. You are an historian expert in the Kennedy family. I think you know about Kennedy. So Kennedy is a politician, maybe. Yeah, so you can see Indian president. Okay, so he was the president. So here I'm asking the question regarding him. So here this is my prompt. How many members of the family died tragically? So if I execute, so now let's say if I invoke the operations, okay, it is giving you an error. Invalid API key. Okay, it is telling invalid API key. Let me do one thing. Let me restart everything, because I already just created the API key, so it should work maybe. Okay, so now it has done, because previously what I did, I changed the API key, but I didn't restart the kernel. So sometimes it happens if you're using the Jupyter notebook. Now this is the response. So here I'm using llama model, guys. You can see I'm using llama model, and from the llama model, this is the response I'm getting. So that means here we are doing the inference operation with the model. Now let's try with the Mistral model as well. So here bad request again, the model Mistral has been okay. So this model is deleted from the playground. So what you can do, you can use any other model. Let's say let's use this one, DeepSeek R1, this model. So for this is the, you just copy this ID. Okay, copy this ID, and here you just try to paste it. This ID you need, okay, to access the model. Now let's say this is our DeepSeek model. Now let's see. Okay, now it's working. Now if I show the response, okay, so it doesn't have any content. Okay, sorry, I think I have to give this response. So deep response. Okay, now let's copy it and let me paste it. So here is the response, guys, I got. Okay, so that's how, okay, you can use any kinds of model, okay, whether it's llama, Mistral, Whisper, Play AI, KWK, okay, any model you can use. Got it. So guys, you can try with this this Grok Cloud. Okay, this is the free one, but there would be some limit actually at the end. So for this you have to upgrade their plan. Okay, but for the, let's say, experiment purpose, for the demo purpose, you can use this particular platform. And again, this is on amazing platform, okay, if I talk about, because all the open source model are already hosted here. So yes guys, this was the demo of the inference model inference. I think you got it. Thank you guys for watching. Hello guys, now I will show you how we can actually serve an inference the large language model with the help of this fast API. I think you remember previously I also showed you how we can serve the model with the help of MLflow. From there I did the inference. Now let's try to create one REST API, and I will try to create some route, and with the help of this route you can access your model. Okay, so let me show you the entire demo how we can use fast API for this particular development. You have to create one environment. Okay, you have to create one conda environment here. So for me, I already have the environment. Let me show you. So conda env list. Okay, so here previously I already created one environment called LLM app, but if you don't have the environment for this, you can write this command. So conda create, okay, -n, then you can give the name of the environment, let's say LLM app. Then you can also specify the Python version. Python is equal to 3.11. Okay, then -y. So this is the command, guys, you have to execute. Once you run the command, it will create the environment for you. Now for me, I already have it, so I'll just try to activate. So conda activate LLM app. Okay, and if you see the version of the Python, it's 3.11. So now let me do the exit operation. Okay, fine. Now what I will do, guys, I'll just try to create the folder structure. So the first thing, you need the requirement.txt file. So let's create a file called requirement, okay, .txt. Then the second file you need called schema.py. Schema, I think. Then third file you need called model loader.py, and the final file you need called main.py. So these are the like files I need, okay, for this particular demo. Now guys, what I will do, first of all, I will just mention all the requirements I need here for this particular demo. So these are the requirement I need. I'm installing the fast API, UVCon to run the fast API, that's a file. Then transformer, because I'm going to use the large language model from the Hugging Face. For this I need the transformer, and dependency wise you need the PyTorch, then Pydantic for the schema management. Okay, now let me install all the package. So to install the package, you have to run this command. So pip install -r requirements. Okay, requirement.txt. So it will install everything. For me, it is already installed because previously I already installed. For you, it will take some time. Okay, so once it is done, now start writing the code. So first of all, I'll write the schema.py. So here we have to write a schema. Okay, schema means, let's say I'll be using a large language model, and you know that we can also provide some parameter to the LLM, like prompt, maximum length, temperature value. Okay, these are the thing. So what I can do, I can create a template, a schema template, and from there I can get that particular, let's say, information. So for this, I'll be using Pydantic library. So you can see Pydantic is a library in Python, and I'm importing something called base model. So here I'm going to create a class. So the class name would be generate request, and I'm inheriting with the base model. And inside that I have some parameter like prompt, maximum length, and temperature. So prompt I'll be taking from the user. Maximum length, it is already set, and temperature, it is also set. I think you know these are the parameter, right? Temperature means this is the creativity like parameter of the large language model. Then I'm going to create another class. So this will give you the generation response. Okay, that means whatever generated text your model will try to return, it will try to return, okay, with respect to this particular class. Now this schema is ready. Now we'll be writing the model loader. So inside model loader, what we'll do, we'll just try to load the model. So here I'm going to load one model called GPT-2. So here, if I go to the Hugging Face, so here you will see the model section. Now here, what you can do, you can search like GPT-2. Okay, GPT-2. See, this is the model will be loading. So how to load this model? So here you can load like that. First of all, import the pipeline from the transformer. Then you can load the model like that. Okay, so here this is the text generation model. So here in the pipeline I'm given text generation. Okay, because I want to perform the text generation, and GPT model I'm loading, GPT-2 model I'm loading, and this will give you the generator object. Okay, so once it is done, now I'm going to write the main file called main.py. So here, first of all, we'll be initializing the fast API, and we'll be importing all the necessary library. So you can see I'm importing the fast API, and from the schema I'm importing this class and this class. Okay, both I'm importing, you can see. Then from the model loader, I'm loading my generator model object. Okay, so once it is ready, I'll be initializing the fast API. So I will give a title actually like LLM Inference API, and you have to give like that. Then I'll be creating a default route. So once you hit the fast API, now you execute the fast API app, it will launch this particular route. Okay, so here you will be getting one message called LLM Inference API is running. Now let me show you to run this. Open up your terminal, and this is the command. So Gunicon, evcon main, because we are running the main.py file, and inside that we have app. Okay, our flask fast API we have initialized as an app. So we are running app and -hyphen reload. Now if I execute, you will see that your application would be running. It is running on localhost port number 8000. Now if I come here and search for localhost port number 8000, okay, 8000, so you'll be able to see that message. LLM Inference API is running, and it will download the model. Okay, for me, my model got already downloaded, that GPT-2 model. But if you're doing it for the first time, you will see one loading option. Okay, model will be downloading from the internet. So everything is running fine. Now we'll be writing the main route. Okay, the route a user will hit to get the generate response. So this is the route, guys, I have created. And all the code example you will be getting from the fast API documentation they have given. Okay, like that's how we have to create the route. So this is the route, guys, generate. So once you hit the generate routes, what it will do, it will run the generation model, and it will get the prompt, max length, temperature, and number returns a sequence. Okay, now prompt I will be getting from the user. Okay, there will be getting an input box. From there will be give the prompt, and prompt will come here. That's why we are using the Pydantic class. Okay, now once I got the generation response, I will also try to show in the first API console. So now let me show you how it will work. So for this, I'll come here and I will try to reload. Now here you have to give /docs. So see, this is the interface of your fast API. Okay, by default you'll be getting a web app like that. Now this is the route I'll be hitting. Now here and this is the post request. Okay, you have to get the post request. Now click on try it out, and here you can pass the prompt. So let's say prompt wise I will give once upon a time. So it will complete the text because it's a text generation model. You can also change the max length and temperature parameter if you want. Now if I click on execute, so it will give me the response. So guys, here I got the response. You can see generated text. So once upon a time, okay, our university was ruled by the by one man, and blah blah blah. That means it is giving you the complete completion of that particular sentence. Okay, so that's how, guys, we have created our custom API and we can hit any kinds of route right now. Okay, and we can easily do the inference with our large language model. So I hope you guys you got it. So very easily and very quick way we can create these kinds of API with the help of fast API. So we need this particular concept, guys, because going forward, whenever you will be creating the application, definitely you have to do the inference, and with the help of fast API you can easily create the API inference, okay, for your LLM. So yes, guys, this is all. I hope you got it. Now you can try with different model, and you can create your own API. So thanks for watching, guys. So guys, now we'll see how we can dockerize this entire let's say inference. Okay, the inference we have created with the help of fast API. I think you remember whenever I showed you the CI/CD deployment, there also I used the Docker. And what is the advantage to use the Docker? Because with the help of Docker, we can containerize the entire applications. Okay, so here what happens, let's say if I share you this code, so what you have to do, you have to manually set up your environment, then you have to like install all the requirements. So sometimes what happens, if any requirement it changes, so you will be getting the error, okay, in your terminal. So it's better to dockerize the entire applications and try to run as a container, because Docker manages everything, okay, all the setups and all. So only you just need to install Docker, and you can use my, let's say, Docker image, and you can execute in your system. Like everything will work automatically. Okay, this is the advantage to use the Docker. Now let's try to see how we can dockerize the entire application. So for this I have to create a Docker file. So Docker file, okay. You can also write Docker ignore. Let's say if you want to ignore any kinds of file, you can write inside Docker ignore, but here I don't need to ignore anything, so that's why I'm not going to create the Docker ignore file. Now here you have to write some Docker related commands, okay. So first of all, you have to take a base image. So from here I'll be taking a Python image, okay. So Python, I need 3 point, okay, that's a 3.11 I'll be taking this image. Then after that you have to run some update commands. So this is the commands, okay. I think there's some error, let me check. From Python 3.12, I think it is fine. Okay, I think it is fine. So you have to upgrade some tools, then we'll be creating the working directory. Then in the working directory we'll copy all of our source code, okay, all of our source code. Then after that you can install the requirements, okay. Then we'll run the commands, okay. Python 3 app.py. So sorry, here it is a main.py. So what I can do, I can write it's main.py, not app.py, okay. Here you can see that. And if you want, you can also give the host and port number. Let me show you. So for this you can add this line of code. So here you need this evcon package, okay. So let me import evcon. Because we have, I think, installed evcon here. Yeah, so now instead of running the evcon commands, I can run like that. So now if you write just python main.py, it will run your app, okay. So here it's app, okay, it should be main app, because this is available in the main file, okay, main.py file, and the endpoint you have created, it is app. Now it will run on the local host and port number. Here I'm giving 8080, and reload is equal to true. So this is the command, okay. Now let me save. Now this Docker file will work for you, okay. This file will work for you, but here I'm getting one error. Not sure what is the error. Let me check. Okay, I think it is fine. Let me try. So what I will do, guys, I will, so make sure, guys, you install Docker Desktop if you are using Windows. So Docker Desktop for Windows, okay. So from here you can download it, and if you're using Linux or Mac OS, so they have also given the guidance, okay, how to install it. So for me, I already have the Docker Desktop, so let me just open it up. Docker desktop. Even you can also set it up on the AWS cloud. I think I already showed you. I already shared you the commands. You can follow the same commands. Now let me open up my terminal here. So this is my terminal. Okay. So here what I will do, see this this should be running. Okay, engine should be running. And if I show you, currently I have one image. So let me just delete it. Container, I don't have any container. Okay, so now let's create our image. So for this you have to execute one command. So you have to execute docker build command. So let me show you the command. So here what I will do, here is the command. So docker build -t. Here you can give your username. So username means you have you should have one docker hub account. So docker hub. So I already have the account in my docker hub and the username is entbappi. So let me sign in. So Docker Hub you need, let's say later on if you want to push your image to the hub, you can do it. Okay, and you can see username is entbappi. So that's why with the help of that I'm tagging the name, because it will give you one unique name. And here I can give, let's say, LLM app. Okay, apps I can give and latest tag. Now let's copy, and here I can build the image. So it will follow all the commands one by one. First of all, it will take the Python 3.11 image, then it will upgrade. These are the tools. Then it will create a working directory, copy all of the source code in the working directory. Then it will install the requirements. Then after that, it will run the main.py. Okay, that means your image would be ready. So it will take some time, guys. So let's wait. I'll pause the video. Once this is complete, I'll come back. Okay, one thing, guys. You have to remove this line, make sure, because it will work because I haven't saved this file. Okay, but you have to remove this line because this was I have added just for testing purpose. Okay, now let me open it up. So guys, as you can see, my execution is done and my image is also built up. Let me show you. So if I go to the image right now, you can see my LLM app image is created. Now if you want to run this image as a container, so what you can do, you can execute another command. So let me show you. So this is the command, guys. So here it is running on 8080, right? So let's expose to 8080 only, and it was LLM apps. Okay, so we are running in the detached mode and we are doing the port mapping. So let me run that. And if you want to see the docker images, okay, you can write this command. Now let's execute. Now guys, it is running. Now let's go to your browser and search for localhost port number 80. You can see LLM inference is running. Now you can give that /docs. Okay, you can give the /docs and you can go to that particular, let's say, route I think I showed you. Okay, and then you can give the message. You will be able to get the response from your LLM. So that's how, guys, we can dockerize any kinds of LLM inference, and this is the recommended way. Okay, if you're following actually the deployment or any other thing, let's say you're getting the app and you want to share with anyone, just try to dockerize the entire applications. And this is another LLMOps actually technique we usually follow. So yes, guys, this is all about. I hope you liked it, and all the resources I'm going to share you can download and you can try from your end. So thank you so much.
You can see the LangServe documentation. So LangServe helps developer deploy LangChain runables and chains as a REST API. That means with the help of that, you can create a API or you can create an application, and this application you can deploy. Okay, you can easily deploy, okay, as a REST API. I think you know what is REST API. That means you will be getting one API interface. With the help of that, you can send the request. Okay, not only that, you will be also getting some web interface, because they have integrated web interface as also. Let's say you will be getting the input box and all. That is also possible here. So you can see this, the entire documentation, like how we can use this and all. So in which port and which route you have to go, everything they have given. Okay, but again, I told you LangChain documentation is a little bit hard to understand. So what I will do, I will first of all show you like how we can use this particular, let's say, LangServe in our project. then you can go through the documentation. Each and everything would be clear, because you can see they have given so many examples. Okay, and I know that initially it would be a little bit hard for you to understand, okay, what they are writing and all. But first of all, let me show you my implementation. Okay, then you can go through the entire documentation, and I will recommend, guys, please try to go through the documentation. Unless and until you are not going through the documentation, so you won't be able to get the in-depth idea. Okay, I'll show the demo how we can use this LangServe. But if you want to learn more about the LangServe, you can go to the documentation. Okay, that should be my suggestion, all of you. So now let me show you the demo how we can actually use this LangServe in our implementation, and how we can create the REST API. Okay, so I'll show you. And one more thing I want to tell you, see, this LangServe they have created, in the backend they're using fast API only. Okay, they're using fast API only. So it is the high level of the fast API. Okay, if you go through the fast API documentation, you'll see that to use the fast API, you have to write so many code, right? So many configuration you have to do. But if you're using LangServe, you don't need to do it. Based on the fast API, actually, they created this LangServe. Okay, LangServe, this tool. Now, let me show you how we can use this one. So for this, I'm going to open up my VS Code. So here I'm going to see if you're using actually LangServe, instead of running from your Jupyter notebook, you can create a Python file. That would be better, because see, Jupyter notebook we won't be using whenever we are developing the application. Okay, so whenever we are experimenting the things, that time we'll be using. But whenever we are creating any application, that time we'll be using the Python file. So let's me create a Python file here. So I'll name it as 10. I can name it as, let's say, LangServe. Okay, LangServe underscore demo.py. So the first thing, you have to install the LangServe. Okay, in the requirements, you have to mention the LangServe. So let me mention it. So here is the LangServe package, because LangChain actually created this framework separately. So you have to install it separately. Okay, so you can see I'm installing this LangServe 0.2.2. Okay, you can also use any other version, but I'm using this version because this is the stable version I'm using. Now I have to set up it. So to set up it, guys, what you have to do, just open up your terminal in your directory. So let's say this is my directory. I'll open up my terminal, and I think you remember we created a virtual environment. So inside this readme, I shared the command. So this is my environment I created. You can activate, and simply you can run this requirement.txt command. Okay, so it will install this LangServe in your actually environment. So for me, I already installed, so that's why I'm not going to install it again. Okay, now here simply I'm going to create a simple app. Okay, simple actually translator app. So let me just write here. I'm going to implement what? Simple translator app. Okay, translator app. Okay, so what this app will do, it will take actually two input. One is the, let's say, language you want to translate. Okay, other one is the text you want to translate. Okay, so these two input this application will be taking. So let me just come here. So for this, I think you know how to actually initialize the large language model and all, because I already taught you in my previous session. So first of all, let me import all of the necessary package I need. So I think you are already familiar with these are the package, guys. Okay, so chat prompt template, str output parser, chat OpenAI. Okay, then python.env, because I have to load my OpenAI API key. So let me select my environment. So this is my environment, LLM app. Okay, this one. Apart from that, I also need something called operating system. Then I'm going to load my OpenAI API key. So let me load. So this will load your OpenAI API key. Okay, then I'm going to initialize the OpenAI model. You can also use Grok API. If you don't have the OpenAI account, that time you can use Grok API. So this is my LLM wrapper. Then I'm going to also create the output parser, and I think you know what is output parser. Okay, we can reformat the output. Then I'm going to create a prompt. So first of all, I'm going to create a system prompt template. So this is the system prompt template, and here I'm giving the system prompt, translate the following into this specific language. The language actually user will give. Let's say user want to translate in the Hindi, Bengali, Spanish. Okay, that time user will give the input and it will come here. It will create the complete prompt. Okay, now I have to create the prompt template. I think you know how to create the prompt template. So this is the syntax. The chat prompt template from message. Inside that, give the system prompt, and whatever user input will provide, okay, will pass in the text variable. This is the idea. Now we'll be creating the chain. So here we are using LangChain expression language to create the chain. You can see prompt template, then LLM, then output parser, sequence of execution. And to create the actually REST API with the help of LangServe, you have to import first of all Fast API. Okay, you have to first of all import Fast API, and you have to import another library from the LangServe called add routes. Okay, these two things you have to import, guys. Try to remember these two things you have to remember. And inside Fast API object, you have to mention these are the syntax. See, so we have already imported Fast API. Inside that, I'm passing the title. Title is simple translator. You can give anything. You can also give any kinds of version. I have given 1.0. And this is the description I have given. A simple API server using LangChain's runnable interfaces. Okay. Now we have imported another library called add routes. Okay. Inside that, we have to pass this object. See. So app routes, I'm passing my app. Then whatever chain actually I have created and the path. Okay. Path should be the chain. /chain. Why /chain? I will tell you. Whenever I will execute the application, you will see that I have to go to the /chain. Okay. /chain actually route. And this route actually it will execute. And I also need to initialize the application. For this, I need this package actually called UVCon. And with the help of UVCon, we'll be starting the application. See, that's it. That's it. So UVCon run, give the app, give the localhost port number, anything you can give. I've given 8000 port number. This is, this is what you have to write. Okay. Now, see, if you go to the Fast API documentation, you have to write so many code. But here, we haven't written so many code. We are only using LangServe. Okay, with the help of that, easily we are creating the REST API. Now, how to execute, guys? So for this, just open up your terminal. Okay, open up your terminal. Just a minute. And you have to execute this file. Okay, so you have to execute this demo file you have created. So let me execute Python 10 langserve demo.py. Now see, if I execute, so it will see automatically it will install initialize langserve. You can see langserve would be there. Now this application is running on your local host port number 8000. Now see, if I open this localhost port number 8000, you will see there is nothing. Okay, so for this you have to go to chain route. So chain, okay, chain/playground. This is the route, guys. Chain/playground. Okay, if you go to this route, you will see the application interface, and this is the REST API, guys, we have created. Now let me zoom. See, this is the interface, and by default, LangServe has created this interface. Okay, so you don't need to write HTML and CSS code for this. Now you can see we are having two input. One is the language, another is the text. The input actually you have written here. I think you remember. So I need two input. One is the text, another is the language. Okay, these two input automatically it is coming. Okay, now here you can test this application. Let's say I will give language. Let's say I want to translate in Hindi. Okay, and text, let's say I will give my name is Bappi. Okay, or anything you can give. Now simply you can start the translation. Now see, mera naam Bappi hai. Okay, now again you can give the prompt. Another prompt you can give, let's say here I can give tell me about Python. See, so amazing response actually we are getting. See, okay, amazing response we are getting. Now if you want to, let's say, hit this particular REST API, so for this you can also execute this code. So here Python SDK code I'll copy, and I'm going to create another file called test.py. Okay, inside that I'm going to paste it. See, this is the code. Okay, this is the code. Now here simply you have to give the message. Let's say you want to perform the invoke operation. So here you can write this thing. So inside this invoke, you can give the input text. Let's say this is my input text. Language is Spanish, and text is equal to generative AI is the bigger opportunity than internet. So this thing I want to send the request. So I can execute. First of all, I'll be taking another terminal here. Just a minute. So my previous terminal is running, and now I'm taking a new terminal here. So first of all, let me activate my environment. Okay, then I will execute this test.py. So Python test.py. Okay, I'm not getting any output because okay, chain.invoke we are doing. So we have to first of all save inside a variable, and this variable we have to print. Now let me try. See the response we are getting. Now let's say this is your server. Okay, this is your development server. That means the demo server, POC server. You are running your application, and your manager, or let's say your client, are testing your application. Okay, how it is working. Either they can test with the help of web interface. Okay, either they can test with the help of web interface. Either they can use this particular code. Okay, the syntax I shared with you, Python SDK. Okay, with the help of API request also they can test your application. So this is called actually Langserve. Okay, so during development environment you'll be using this particular tool. Okay, just to test your application whether it's working fine or not. Now let's say everything is working fine, it is ready for the production. That time your front-end developer will come and they will create one beautiful interface and they will connect your application, and this application would be available in the production server like the ChatGPT. Okay, I hope it is clear. So this is the simple demo of the Langserve. Now simply you can go to the documentation. Okay, the entire Langserve documentation. Now you'll be able to understand, okay, whatever things I showed you.
Hi guys, in this video I will show you how we can do LLM evaluation with the help of MLflow. Here I'm not going to only use the MLflow, I will also use something called DAXUp. So this is another amazing platform. So there you can let's say trace all the experiment and you can visualize. Okay, that means you will be getting one graphical user interface there of the MLflow, and you can see all the, let's say, metrics, all the graphs and everything. Even you can also compare with different let's say parameter. So everything I'm going to show you guys, no need to worry. And this is one of the amazing actually LLMOps tool you can talk about, because previously I also showed you how we can use this MLflow for the experiment tracking and all. Okay, now I'll show you how we can use the MLflow for the LLM evaluation purpose. So you can see ML and GenAI made simple this MLflow. So they are having different example. So here you can see this is the documentation of MLflow LLM evaluations. So you can go through the documentation, guys, after watching this particular video. Then your understanding would be more clear. Okay, if you want to deep dive into the different let's say evaluations, you can go through that. So the example I'm going to show you guys, this will give you the entire idea how we can perform the model evaluation part. So guys, you can see there are different evaluations, like you can perform evaluation on top of the question answering, on the text summarization, on the text model, on the retrievers. Okay, so anywhere you can actually apply this particular evaluation technique. And for question answering, we're having some metrics, like you can see toxicity, then ARI grade level, then flesh kin said grade level. Okay, so these are some metrics are available. Let's say if you want to see the toxicity, just try to open it up. So here they have already mentioned what should be the toxicity score. Okay, best toxicity score. So I think somewhere they have given, even they have also given the example. So if you go through it, so they have, I think, already given the best toxicity score you have to achieve, okay, whenever you are using the LM. Otherwise you can search here. Let's say I'll copy the name, best toxicity score for LLM question answering, question and answer. Okay, so here if I search, so I think it will give you the score. So you can see there isn't a single best toxicity score for the LLM question answer, as it is depends on the specific context of the goal application. However, generally accept the range of the safe response where the toxicity minimal would be below 0.2 to 0.3. Okay, so that's why if you search for any kinds of metrics, guys, let me show you. If you search for any kinds of metrics, let's say airy grade level, then flesh kinside level, you will see some specific score. Okay, and after doing the evaluation, you have to check whether this particular score you are getting, it is close to that or not. So let's say for text summarization, you can use row score, again toxicity, okay, and so on. And that's how actually you are having different score. Okay, now let me show you one example, guys, how we can use this MLflow for the LLM evaluations. So first of all, let's try to save the log, that means save the evaluation logs on the local system. Then I will also show you how we can save the experiment on the DAX hub. Okay, DAX hub server. So let me show you. This is the DAX hub, guys. So DAX hub is a platform. Actually, here you can get a remote server to connect with your MLflow. Okay, and there you can like add all the experiment. See, you can track the experiment here. Even you can curate and annotate, you can manage the model. Okay, so actually it has actually different functionality, you can use it. So first of all, what you have to do, guys, here you have to log in. Now make sure you have one account. So for me, I already have the account. Let me just try to log in with my account, guys. So guys, as you can see, I already logged in with my DAX hub. Okay, and previously I already did some project, that's why it's showing like that, but for you it would be completely empty. Okay, I'll show you how we can connect with the let's say GitHub, how we can create the MLflow server, everything I'll try to show you. So first of all, guys, what I'll show you the code example. So let's say first of all, if you want to do it in the local machine, so just try to comment this 2 line, because if you want to track in the DAX hub, then you have to activate this 2 line. Okay, but as of now, I'm not going to add, I'm going to save everything in my local. That's why I have commented this particular line. Now guys, this is one code example and the resources would be shared in the resources section. From there you can download and try. So first of all, what you have to do, first of all, just try to create a environment. So for me, I already have the environment. So the environment Python version should be 3.11. okay, just try to create the 3.11 environment. I think you know the commands conda create -n, then give the environment name, then specify the Python version. Okay, so after creating it, you have to install all the requirements. So these are the requirement, guys, you need. Okay, so just try to install all the requirements. So to install the requirement, guys, what you can do, just write pip install, okay, pip install -r, then requirement.txt. so once you execute it, so it will install everything, but for me it is already satisfied because I already installed everything. Okay, now guys, here you can see this is the code example. So here, first of all, I'm importing all the necessary library like MLflow, OpenAI. So here I'm using OpenAI large language model. You can also use Grok or any other, let's say, model. You can also use Hugging Face model. But again, whenever you are using Hugging Face model, what you have to download it from the Hugging Face and you have to load in your machines. Okay, and if you're using port configuration machine, definitely there would be an issue. Okay, so that's why for production level application, most of the time we use API based services like OpenAI is there, Grok is there. Even I will also show you some LLMOps platforms. Okay, like AWS Bedrock, GCP Vertex AI. So those platform also provides like foundation model and functionality. You can use there to create different applications. Okay, now guys, you can see here, first of all, I have created one evaluation data. So here I just generated some data, like let's say what is MLflow and what is Spark, and this is the ground truth. So this is the MLflow definition and this is the your Spark definition. So what I will do, I will also ask the same questions to the LLM and I'll try to compare the results. Okay, whether it is close to or not. Okay, so this is called actually evaluations. You are evaluating the response, okay, whether it is correct or not. So for these guys, here you can see this is the data I have prepared. Now here if you want to start the experiment with MLflow, you have to write MLflow.set experiment. Then here I have given the experiment name. Then with MLflow start run. Inside that, first of all, I'm creating a system prompt. So here I'm writing answer the following questions into 2 sentences. Okay, now here you have to wrap the model, okay, to the MLflow. So for this you can use MLflow OpenAI, because I already showed you MLflow is having different let's say framework integrations. Like if you're working with machine learning, you can use scikit-learn. If you're working with deep learning, you can use TensorFlow. If you're working with GenAI or any other, let's say framework, let's say you are working with OpenAI, that time OpenAI. If you're working with Grok, you can give Grok. Okay, so that's how it supports everything. You can go to the documentation, you will be able to understand. Now log model, and here I'm using GPT-4 model. Okay, now you can ask me how it will access the model. For this you have to export the OpenAI API key. Okay, how to export? So here is the command, guys. Okay, so make sure, guys, you give your OpenAI API key. Okay, not my one, because I already I will remove this API key. Okay, after the video, just try to copy this. Make sure export command you are running and open up your terminal and just try to export the export the key. So I think it's not a valid identifier. Okay, so what I will do, let me copy again and let me execute. Okay, so there is some error, guys. Let me check. Okay, now it has executed successfully, because previously you see that here I have given a space. Okay, so you don't need to give the space. So there should not be any kinds of space. Okay, otherwise it will give you the error. Now actually it is done. Okay, now let me show you the further step. So guys, you can see here I'm logging the model, and this is the path to log the model, like artifact path model, and here is the system prompt as well as the like questions. Okay, so this is your actually complete model. I think you already know that how to initialize the OpenAI model. Now here is the evaluate code. So here you can see I'm using MLflow.evaluate functions. So inside that I'm passing my model URI and my evaluation data. Okay, evaluation data, because your model will try to give the answer related to this particular questions. Okay, and that answered and my ground truth. Okay, ground truth, whatever actually I have here, you can see ground truth answer. I'll just try to compare. Okay, on top of what? On top of my question and answer. So this particular question and answer. Okay, so whatever questions I have given, I'll try to compare. Okay, question answer, because here we are doing the model here we are doing the question answering operation, because here I showed you, here you have different task. Okay, here you have different tasks: question and answering, text summarization, text models, okay, retriever. So here you can specify, okay, what you want to perform exactly. So here I want to perform question and answering. Let's say I'm doing text summarization, I will give text summarization that time. Okay, so model type you have to specify. Then extra metrics. So you can see, guys, I already showed you there are different metrics like toxicity, then flesh, this inside grade level. Okay, so these are the metrics you have to define, okay, one by one. Got it? Apart from that, you can also specify some more metrics like latency, then answer similarity. If you want, you can also do it. Now if you just mention this toxicity, you will see that it will also let's say log those are the metrics as well. Okay, these are the metrics as well, like flesh, kin say grade level, everything you'll try to log. Okay, so once you can see I will get the results, I will also print the results on the terminal. Then I will create a table. Okay, then I'll try to save the table as a data frame, and this is the CSV file I'll try to save, okay, in my local. Now let's try to see whether it will work or not. So for this I will execute the code. So to execute the code, guys, just write python demo.py. okay, so if I execute it, now see it is running. Okay, so here I got one error. Let me check the error, guys. So guys, now you can see execution is done. So the issue was there, you have to install this httpx with this specific version, okay, then it will work. So I've already added in the requirements. Again, just try to run the requirement.txt, it will install. Then just try to run your demo.py. So once it is done, guys, you will see that one mlruns folder has created. Now this eval.csv also created. Okay, now let me open it up. So in the CSV file, so maybe I can show extension for the eval CSV. Do you want to install recommended rainbow CSV? So let me install and let me show you the CSV, okay, whatever we have inside that. Extension, I think it is installed. But how to show it? Rainbow CSV. Okay, so here I'm not getting any preview option. Okay, maybe what I can do, guys, I can just open it here. Okay, so let me just double click, and or else let me see some CSV viewer, because currently on my system this Excel is not there. So let me just view from here only. So guys, here you can see here it has loaded the CSV, and here it is showing the results. You can see here I have you can see inputs, ground truth, outputs. Then we have latency, token counts. Okay, then answer similarity and justifications. Okay, now you can do the big screen. Now you can see the score. Okay, you can see the latency score, you can see the token, you can see the similarity score. Okay, and just try to search over the Google what is the best score, and just try to compare. Okay, so in this case I think our score is fine because the generated output we got, okay, you can see it is similar. Okay, so that's how guys we can do the comparison if you are doing the evaluation. So that's how guys we can do the comparison if you are doing this kinds of evaluation. Now let me just track this entire let's say metrics over the DAX platform. Okay, for this what I will do, first of all you have to create a GitHub repo. So let me open up my GitHub. So here I'll create a new repository. Let's give it as LLM evaluation with MLflow. So let's keep it as public, add readme file. Then you can also add git ignore. Let's say Python. I think readme I already have, I'm not going to do it. And let's create the license as well. Now let's create the repository. So once it is done, just try to copy the link address. And here what you can do, you can just try to open up your terminal. I already have the terminal. Let me just clone it. So git clone, paste the link. Okay, I think it is done. Now let me go inside that. Let me copy all of the file and let me paste it here. Now I can delete it. Okay. Okay, it is already opened in another program. So I think I can close the terminal. Now let me try. Okay, let me also close the VS Code. So again, I'll open up my terminal and Panda activate LLM app, and I will export again that credential available in my readme. Copy and let's export it. Okay, and after exporting, because I'm going to actually push these things in my GitHub. Okay, that's why I'm going to remove my API key. Okay, here you have to give your API key. So let me save. Now I think everything is fine. So ML run, what you can do, you can either delete it, either you can keep it. Okay, it's up to you. So let me keep it, or let me remove it. Okay, as of now, because I'm going to push it. Otherwise you can also mention in the .git ignore. Let's say ML run, I'm not going to take it. So ML runs, I'm not going to take it. Now let me push this code. So git add space dot okay, space dot, then git commit -m update and git push origin main. Done. Now if I go to my GitHub, refresh, so it is available. Okay, now I can connect this repo in my DAX app. So how to do it? So come to the DAX app, click on the create new repository, and connect a repository from the GitHub. So here I will add and revoke the new repository. So let me select my original account. Let's give the password. Once it is done, now let's try to find the repository. Okay, so here selected repository, here the repository name is LLM evaluation. So let me copy. Here you can paste it, so it will give you the repo. Let's select it, and now let me save it. Okay, once it is done, again what you have to do, just get back to your DAX app. Because sometimes it throws this kinds of error. Okay, now if you again come here, so see MLflow demo. No, I think this is not there. I think somewhere it is there. So let me connect the repo, GitHub. Now I think this should be there. CLLM evaluation. I'll select and connect the repository. Okay, it is connected. So here I'll give no thanks. Okay, now guys, if I want to like take the remote server of the MLflow, click on the remote and you can see the experiment. Okay, just go inside that, and this is nothing but your MLflow tracking, let's say server. So you, if you want to like track it, so you have to copy this particular code snippet. Okay, you have to do, initialize the DAX app. So what you can do, you can copy this code. I already copied, so let me show you. So here is the code. Okay, here is the code. So here what you have to do, you have to give the owner name. So owner name is ENT oh no, sorry, this is the owner name. I'll copy the entire code and let me just replace here. I think that should be fine. So this is the owner name. I'll copy, and this is the repo name. Okay, make sure you replace it here, and you have to give the tracking URI. So where you will get the URI? To get the URI, guys, so here is the URI. Okay, just try to copy and just try to mention it here. Okay, now everything you can remove. So this configuration you only need if you want to track the experiment to the DAX app. Fine, and make sure you install the DAX app because it is already available in the requirements. Now I think it will work. So here let me launch my MLflow UI. So initially it would be empty. Okay, initially it would be empty. The same thing you can also do in the AWS cloud. I already showed you how to perform on the AWS cloud also. Okay, there you have to do additional setup, but here we are using the DAX app. So now what I will do, guys, I will run the same code. Now let me execute. So Python, then another file. Let's keep the accept. So once authentication is done, now see it is login everything. So it will take some time, guys. Let's wait. Okay, execution is done. Now let me get back to my MLflow, refresh. So see, guys, you will see the first experiment here. Okay, now you can open it up and you can see all the parameter. See all the metrics, actually it has logged. Okay, all the metrics. It's amazing, right? You can see the metrics here. Now you can actually do different let's say experiment. Let's say I will again execute. Let's say you have changed those questions. Okay, save those prompt. Again you are executing the same thing. So it will create another experiment. Then you can also compare. So see, execution is done. Now if I go back, see another execution has created. Okay, now here you can see the metrics. Now you can do the comparison operation. Let's say select all and compare, and you can figure out the best let's say experiment from here with the help of this parallel coordinate okay, this particular plot. So you can plot everything here, okay, one by one, and you can actually select the best one, okay, from here. So this is one of the amazing things, guys, this MLflow. It provides not only experiment tracking, even you can also track the evaluations. Okay, everything you can do here. So guys, I think you got it, how we can do the evaluations. Okay, So that's how we can do the evaluations. Let's try to go to the documentations, and whatever evaluation you need, let's say for the question answering, for the text summarizations, for the language translation, you can check that and just try to do it, okay, similar way. So yes guys, I hope you got it. So yes guys, this is all about it. Thanks for watching.
So I'll open the LangChain website. So the first thing, you have to create one account in the LangChain website, guys. Okay. So everyone, if you don't have the account, first of all, try to create one account in the LangChain website. So for me, I already have the account. If you don't have the account, guys, just try to sign up with your email address and you will be getting one account. So for me, I already have the account. I'll just try to do the sign up here. See, for me, it will automatically log in. See, okay. So initially, we'll see these kinds of interface, but for me, see, I already created actually one project here. I was tracking one project. That's why you can see this particular project name. But if you're opening for the first time, you'll see that it would be completely empty dashboard. Okay. Now, the first thing what you have to do, guys. So you can see this is the Langsmith platform. Now you can also open up the documentation. I think so. They have also given the documentation link somewhere. So let me open the documentation. See, this is the documentation. So this is the Langsmith documentation. So here they have already written with the help of Langsmith. It's a platform for building production grade LLM application. It allows you to closely monitor, evaluate your application. So you can ship quickly with the confidence. Use of LangChain is not necessary. Langsmith works on its own. That means you don't need to configure so many things here. Only you just need to set some environment variable and all, and everything will be tracing automatically. Okay. Even they have also given some example like how we can install it. Okay, so if you're using LangChain, so you don't need to install Langsmith separately. Okay, it will be working fine. Now you have to create the API key of the Langsmith. Then after that, you have to set it as an environment variable. And if you're using any other operating system, you can also export it. Okay. And they have also given some of the demo. But again, I told you, LangChain documentation is a little bit complex for the beginner. So first of all, see my code example. Okay, whatever application I'm showing you, first of all, try to see, then try to go through the documentation. Okay. Even they have already given the like tutorial related evaluation, prompt engineering. Okay. Even they have also integrated LangGraph, like cloud. If you want to, let's say, integrate the Lang server and all, you can also do it. Okay. But as of now, it's not required. We'll be using the Langsmith for the monitoring our application. Okay. This is our main objective. So for these guys, first of all, let's create one API key. And how to create the API key? So for this, open up your dashboard. And left hand side, you will see there is a setting option. Okay. Now click on the setting option. Now here you can create the API key. Okay. See, there is an option, create an API key. So if you don't have the API key, guys, just try to create an API key. For me, I already created. Okay. So you can see for me, I already created. So let me, what I can do, I can delete this API key. The API key actually I created. I can delete it. Now I'll be creating a new one. So create API key. You can give the name. Let's say I'll give my key and create it as a personal access token. And create the API key and make sure you copy it and paste it inside your env file. Okay, now see, this is my env file, and here you have to write this particular key name, LangChain API key. Okay, inside that you have to paste this particular key. So let me paste my key. Okay, don't use my key, guys. I'll try to remove it after this session. Okay, just try to create your own API key and try to mention here. Then you have to give another key, which is nothing but LangChain project. That means the experiment actually it will be tracking, right? So it will save as a project. So you have to give the project name. So by default, whatever name actually you'll be providing here, it will use that particular name. So here I will give, let's say, my LLM app. The previous I already created one app called my LLM app. Now what I can do, I can, let's say, change it. So I'll give test. Okay. Test app. So I've given this name. You can give any name. Okay. It's up to you. Now let me save, and it's done. Now let's create out. Now what you can do, you can create a Jupyter notebook. So for me, I already created a Jupyter notebook, guys. You can see, and I have already written the code example. Okay, how we can use this particular Langsmith. So again, these are the code snippet. I think you already familiar with. I already explained everything inside LangChain. Okay. So here I'm importing operating system library, then chat OpenAI because we'll be using the chat completion model. Then chat prompt template, HTR, output parser. Okay, then load env. So I think you already familiar with these are the packages. Okay, now let me import them. Now the next thing, you have to load the like secret credential. Okay, you have to load the OpenAI API key. You have to load the LangChain API key. Okay, And you can, in case you can also use any other model, you can use Grok model, okay, any other model you can use. So here I'm using the OpenAI model. And so if you're using LangSmith, one things you have to assign, which is nothing but LangChain tracing v2 is equal to true. So if you go to the documentation of LangSharp, let me show you. So if I go to the documentation, so they're telling, see here, so this one, LangChain tracking v2 is equal to true. You have to provide this particular statement, okay? If you're not providing, your execution won't be, okay, logged inside LangSmith, okay? That means it won't be tracing. But if you're giving it as true, it will automatically start tracing your experiment, okay? So this is super important, guys. And this is what you have to remember in LangSmith, okay? Nothing else. Everything will take care by LangChain only. Got it? Now see here I have mentioned LangChain underscore trace tracking underscore v2 is equal to true. And why v2? Because we are using second generation of LangChain, okay? Second generation of LangChain. That's why we have given the v2 version 2. Got it? Now let me load the environment. Now here I'm creating the chat prompt template. I think you know what is chat prompt template. If I want to give some prompt to my LLM, first of all I have to create the prompt template. So here I'm creating my prompt template, and here I'm using the chat completion model. That's why I have to give the system prompt as well as the user prompt. So this is my system prompt. You are a helpful assistant. Please respond to the user request only based on the given context. Now this is the user. So user, in case actually what user will pass the question, and they can also pass the context, okay? So context wise they can also pass. So this is my entire prompt template I have created. Now I'm initializing the model. I'm using the GPT 3.5 turbo model and as well as the output parser, okay? Now this is a basic simple chain I'm creating with the help of LCL, that means LangChain expression language. And I already told you this kinds of ecosystem supports latest LangChain, okay? The second generation of LangChain. Okay, if you're using the legacy LangChain, in case actually it won't be working. Okay, that's why I already told you, you have to learn the second generation of LangChain. Now this is my simple chain prompt model and output parser. So first of all, prompt will be created, then it will pass to the model. Model will give me the response, and it will pass to the output parser, and output parser will return the string output. Okay, this is the idea. Now let me create the chain. Now here is my question. So here I'm giving one question. Can you summarize this story? And story wise, I've given this particular story. You can see inside the context. So I have copy pasted this story from Google. So if you can search like English story, you will be getting different story. So here you can paste anything, or if you have any other documents, you can also pass it here. Okay. Now this is my question. Can you summarize this story or not? Okay. So this is my question. Now here I'm passing it to my actually chain. So chain.invoke question is equal to question I'm giving, and the context is equal to context I'm giving. Okay. Now see if I execute it. So here I will get the summary. Okay, this is the entire summary actually I got. Now if you go to the LangSmith, okay, if you go to the LangSmith, and if I go to the, let's say tracking project, okay, in this section, now you'll see that the latest actually track would be visible. So this is my previous one. Okay, this is my previous one. You can see the timing. Okay, in this timing, at this time actually I was experimenting this application. Now this is the new one, test app. The name actually I have given inside my environment variable. It is utilizing the same name. Okay, now you can see the created date and everything. It would be visible. Now you can also see some of the like messages like error rate. So are you getting any error or not? Then latency. Okay, like how much actually time it took to execute the application. Okay, so different actually log you can see. Now total token, total cost. See, now you can track you can monitor your cost, like how much it is charging. So here we are using OpenAI model. So the request actually I send. Okay, so based on the request, what is the charge? So see, it is charging $0.0000181. Okay, and this is the date. Now I can also open it up and I can see detailedly, okay, what it's trying to say. Now see, entire log you can see here. Okay, like the run count, like only one time I executed, the total cost, okay, then token and latency. Okay, everything you can see here. Okay, everything, all the metadata you can visualize here. Okay, in this LangSmith platform. So this is one amazing platform they have created. Now if you want to see in detail, so what you can do, simply you can click here. See, it is logging as a runnable sequence. Okay, now I think you can answer me why runnable sequence, because I already told you whenever we create a change, that means we are executing runnable, yes or no, sequence of runnable. Okay, that's why it is logging as a runnable sequence. Okay, now inside runnable sequence, what we have, guys, we have different kinds of runnable. Okay, like we have our model, we have our a prompt. Okay, then we have the output parser, and you can see this is the input. Okay, this is my input and this is the context. Based on that, it has given me this particular answer, output. Okay, if you want to see as a JSON, you can also see. If you want to say as a YAML file, you can also see. Okay, now status is success, that means there was no error. Now you can see the feedback. So if any feedback is required, it will automatically give you the feedback. It will also show you the metadata, like what is the version and everything you are using. Okay, so everything it will show you. Everything it will show you. That means each and everything you can monitor here of your application. Okay, so this is one of the amazing product actually Langchain team has developed. Even personally, I prefer a lot. So it will give you the entire clear-cut idea about your application, like the cost, everything. Okay, everything. Even you can also evaluate your application. Okay, so I think future will also show that how we can evaluate our application. Now see, apart from that, I think some more functionality are there. So let me open it up. So what I can show you the monitor section. So inside monitor section, it will show you the graph based on the, let's say, hour and day basis. So I just executed my project as of now. That's why there is nothing. But after 1 year or after 9 days, okay, or 1 day, you will see it will show you the different graph, like volume, latency, tokens, cost, okay, streaming, everything it will show you. Now setup wise, if you want to set up it, so they are also giving the tutorial, but I don't need it. I already set up this project. Now I'll go to the run section. I'll click on the all runs. And inside all runs, you'll see whatever runnables you had, everything it will show you. Let's say, so I had different runnables, get, remember. So prompt was there, model was there, output parser was there. Okay, so you can see output parser, our model, okay, then our prompt. Okay, now this is the sequence runnable, that means the entire runnable. Now you can also open them individually. Let's say I want to see the output parser only. In case, I can open it up and I can see, okay, what output parser is doing. It is giving me the string as an output. Okay, that's how we can see the model size, model as well. So what is the model you are using? Okay, the model input, model output, everything it is visible. Okay, and the token, the cost, okay, everything it will show you. So with the help of this Langsmith, we can do some more advanced stuff. Maybe in future I will also show you, but as of now, that's how you can monitor your entire application. Okay, in MLOps, if you have used something called MLflow, anyone, so I think you can relate, okay, MLflow with this Langsmith, because in MLflow also we can track our experiment. Okay, so inside this Langsmith also we can track our experiment. Let's say you are executing for the next time, second time. So what I can do, let's say I can change this question. So here I can write, can you summarize this story? Instead of that, I can just write, what is this story all about? Okay, all about. Now if I again execute, okay, now see, if I go to the Langsmith again, and if I just click here, test tab, now see the second execution, okay, the second log, just 1.92 seconds ago. Okay, sorry, it's a latency, but you can see the time as well. So I can show you the time. I think time, you see, you can see the time. Okay, got it. So you can see this is the next experiment. Now if I open it up, so you can see this is the question, and this was my actually context, and this is my response. Okay, so that's how we can track a different experiment. Okay, with different actually, let's say, runnables, different actually input output. Okay, everything you can trace. So this is why important. I think whenever you are creating production grade application, so you should also integrate this kinds of functionality. And to integrate it, so you only just need to add this particular syntax. Okay, that's it, and everything would be automated in the platform itself. I hope now you are clear with this Langsmith. Okay, how Langsmith works. So guys, I think so far you have learned about Langchain. Okay, Langchain. Then you learn about Llama Index. Okay, then you also learn about open source large language model. Okay, open source LLM. Even I also taught you the OpenAI. Okay, OpenAI, and OpenAI provides actually commercial model, because all the models are paid here. If you want to use them, you have to pay for that, right? And how it will charge you based on the token limit, and this will give you the API key. Okay, API key. With the help of API key, you can access this model. But apart from that, there are so many actually foundation model. I think I already discussed inside Hugging Face. Okay, Hugging Face platform like Llama was there. Okay, then Mistral was there. Then Falcon was there. Okay, then Gemini, Jimma. Okay, and so on. There are so many model. If you open the Hugging Face platform, you'll see that there are so many models are available, and these are the foundation model. And this model is pretty good, guys. If you see this model is like very powerful model. It's very powerful model. Even I already showed you some of the demo. We created some of the application with the help of open source large language model. There I think you saw the power of the model. Yes or no, right? But I think one issue you saw whenever I was using this open source large language model, the issue was this model size is very big. Let's say if I'm considering Llama 2, just try to consider about Llama 2. So now tell me, Llama 2 having actually how many variant? I think you know Llama 2 is having 3 variant, like 7 billion parameter model. Then it is also having 13 billion parameter variant model. It is also having 70 billion parameter model. Even recently there is another model you will see called Llama 3. Okay, Llama 3, and Llama 3 is very huge than your Llama 2. So you can open up the Hugging Face hub and there you can search for Llama 3, you will see the model. So here I already told you, if I want to use this model, actually I have to use GPU based machine, GPU based system, yes or no. And if I'm not using GPU based machine, so what will happen? I won't be able to execute this at the model. But if you see, there are so many developers, there would be so many enthusiasts, they will prefer to use these at the open source large language model. But most of them will not have the GPU based machine. Okay, because it's obvious now. Because if you see nowadays, actually whatever laptop, whatever let's say system we usually buy, people usually take this actually GPU, let's say 3060, okay, Ti. So I can consider RTX, okay, RTX 3060 Ti. If you have actually less budget, then you can buy this GPU. If you have more budget, you can also buy higher configuration GPU. But there are very less people, they will buy the higher configuration GPU. Let's say who have the huge amount of earning, they will buy it. Okay, but if you have actually less budget, because the majority of the person will have the less budget whenever they buy any kinds of system. So they will have, let's say, this GPU 3060 Ti. Okay, so this GPU having actually, I think around 4 to 8 GB, I think VRAM. Okay, VRAM it is having. Okay, now just try to consider, let's say I'm loading this Llama 2 7 billion parameter, okay, this model in this GPU. So what would be the inference time? As of now, let's try to consider, let's say it will take 5 minutes. Okay, 5 minutes to give you the response. Now just try to consider, if your application is taking 5 minutes to execute only one prompt, will people use your application? Tell me. If let's say I'm using ChatGPT, and if I'm giving any prompt to the ChatGPT and ChatGPT is taking, let's say, 5 minutes to give me that response, so will I use the ChatGPT again? No, definitely I will not use, because nowadays you will see that people will have very less time. They want actually quick response from any kinds of application. So what you have to do, the system you are developing, this should be very fast. Okay, the inference time would be very fast here. Otherwise, people won't be using your application, right? Then let's say you are loading this 13 billion parameter model, okay, in the RTX 3060 Ti GPU. Let's say now it is taking 10 minutes to execute. Okay, 10 minutes to execute. And after that, let's say you are taking 70 billion parameter model in the RTX 3060 Ti, and you will see that sometimes it will give you memory, okay, memory out of space, okay, out of space error. Okay, because this GPU doesn't have the capacity to load this 7 billion parameter model, because I told you it is having 4 GB and 8 GB VRAM. Okay, so that time actually we are not able to use this kinds of foundation model. But let's say somehow we are using this foundation model. Let's say we are using small variant of the model, let's say 70 billion or 13 billion. But what is happening? Inference time is very high here. Okay, it is like very slow here. So again, people won't be using my application. So this is another issue. Got it? Now let's say somehow you created one application. Let's say it is taking 5 minutes to execute. Now what you have to do? If you want to publish this application to the audience, you have to deploy this project, yes or no? Let's say you want to do the deployment. You want to do the deployment. Okay, deployment. Now, I think previously I showed you one deployment, right? We deployed one end-to-end medical chatbot project. There I was using actually AWS. Okay, AWS. So I was using, let's say, EC2 service from there. EC2. Then I was using ECR. Okay, Elastic Container Registry. Then I was also using something called Docker. Okay, so these are the services actually I was using there one by one. Now, see, there I was actually deploying the OpenAI based application. That means I was using OpenAI model. That's why I was able to deploy this project in the cloud platform with the help of these are the simple service only. But whenever you are using open source large language model, so that means this model you have downloaded in your local machine, and now what you have to do, you have to move this model to the production server. That means your cloud machine. And there, just try to consider if you are using this kinds of 8 GB, let's say, instance like T2 large instance, will it work? So I think remember we use something called T2 dot large instance there, and it was having 8 GB memory only. Okay, 8 GB memory with CPU code. So it won't be working, right? If I'm loading this Llama 3 or Llama 2 in this machine, it won't be working. So for this, what I have to do, I have to purchase actually a GPU based machine there. So if you see the EC2 instance, you will see that there actually will also have GPU based machine. So there actually you can also purchase GPU based machine. Apart from that, AWS provides another service called AWS SageMaker. Those who are from actually MLOps background, they already know what is AWS SageMaker. So SageMaker is a complete actually platform. So here you can actually ingest, okay, train, evaluate, okay, evaluate and deploy any kinds of machine learning or deep learning project. Okay, and it also provides different virtual instance. That means virtual computer. Okay, virtual, let's say computer, it will also give you. So there actually you can take any kinds of instance and you can, let's say, host your model. It is also possible. So SageMaker provides actually lots of service. You can search over the Google, you'll see that it provides different services. Okay. Now, a few months back, actually, I was going through one actually research article. So there I found if I want to, let's say, deploy any kinds of open source large language model, let's say my custom created, let's say, server. Let's say I want to launch my own server, and there I want to host my model. For this, what I can use something called SageMaker. Okay, AWS SageMaker I can use because SageMaker will give you different kinds of instance. Okay, so there actually you can host your model. And if I want to use SageMaker and if I want to, let's say, deploy this kinds of open source large language model, because see, if I want to use this kinds of open source large language model, I have to use different library. Like I told you, we have to use Hugging Face. Okay, we have to use LangChain. So different things we have to install. Even if I want to use Hugging Face, I also need to install Accelerate, Bits and Bytes, because this model access the GPU, right? And to access the GPU, I also need these are the package. Okay, I already explained in my Hugging Face session. So if I want to install these are the package, whenever, let's say, I'm taking any EC2 machine, there you will see installation issue. So most of the time you will see lots of installation issue actually will get. But what they did actually, they created one service called DLC. Okay, DLC, that means deep learning container. So this service is already available in the AWS. Okay, you can use with the help of SageMaker. SageMaker, you can use this DLC, that means deep learning container. So inside deep learning container, you can install any kinds of deep learning package. Let's say you can install Hugging Face, you can install, let's say, PyTorch, TensorFlow. So all the, let's say, library would be already pre-installed there. So you don't need to, let's say, manually put the effort to install these at the library. Okay, with the GPU configuration, everything would be already there. Okay, only just need to take the DLC, let's say, instance, and you have to connect with the SageMaker. That's the idea. Okay, so with the help of SageMaker, with the help of DLC, you can host this model. Let's say you are having one open source model. Now you can host this model in the DLC platform. Got it? And to get the, let's say, endpoint from the model, what you have to do, you have to use something called API gateway. Okay, API gateway. So this is another service from the AWS. With the API gateway, what you can do, you can create an API. Okay, API. Like we saw like OpenAI API. Now we used to use one API. So here also you can create an API. With the help of API, other people can access your model. Let's say this is a user. So user can access your model with the help of API request. So this API will request this, let's say, model. That means, let's say you are using Llama model. Okay, and Llama model is present inside DLC. That means deep learning container. It is running on the SageMaker actual instance. Okay, from there actually you can get the response. Now let's say somehow you deployed this a model like that. Okay, the way actually I showed you with the help of SageMaker, DLC, API gateway, okay, all the services. Let's say you deployed this model, and now let's say it is working fine. Now there one issue we'll get. The issue is cost. Okay, so it will actually charge you huge amount of money. Let me show you. So in that research article, I got one image actually. Let me show you the image. So I have already taken the screenshot. So this is the image, guys. I think this image is visible. See what they did actually. They have taken different Llama model. You can see they have taken different Llama model. Let's say Llama 2, 7B, 7B chat, 13B, 70B. Okay. And this is the model ID, and this is the max tokens. Like what would be the input length, okay, of this model? I think you know, Llama 2 takes actually 4096 token. Okay. And this is the default instance type actually they are suggesting. Let's say if I want to use Llama 2 7B model. So I have to take ml.g5.2x large machine. Okay. And this machine is available in the SageMaker platform. Now let me show you the SageMaker. So if you just search for SageMaker, okay, SageMaker pricing. Just search for SageMaker pricing in Google. So you will get one website, machine learning service, Amazon SageMaker pricing, AWS. Just try to open it up. Now here, if you just go below, you will see SageMaker will give you all kinds of price list with respect to all kinds of, let's say, machine type. Let's say if you want to use MLT3 medium, it is having actually 4 GB RAM, and here you will get 2 vCPU, and this is the price per hour. Like that, actually it is having actually different instance. Actually you can see it is also having large instance. So you can see it is also having large instance, X large instance. Okay, then 24x large also instance it is also having. Now see, the more good configuration instance you will be taking, that means your vCPU is increasing, as well as the, let's say, memory is also increasing. You'll see that price is also increasing. So this is the per hour price. Let's say per hour price, it will charge you $6 if you're taking ML M5D 24x large. Now see, if I show you the chart now, so this chart also they have also suggested. Let's say you are implementing one project with the help of Llama, let's say Llama 70, okay, Llama to 70 billion parameter, and now see this is the configuration you have to take. This is the configuration you have to take. MLG5 48x large, okay, configuration machine. But let's try to consider Llama to 13 billion. Okay, let's say you want to use this actually configuration model. Now let's find this configuration, MLG5 12x large. So here you can find out that configuration. You can see there are different series are available. This is the M5, C5. You can also find out the G5. So as of now, let's try to consider this machine. Let's say ML M5D 24x large. Okay, let's say I want to use this. Okay, this machine. I want to use this machine. This machine is having 96 actually CPU, and it is also having 384 GB memory. Now, what is the per hour cost? Per hour cost is, you can see, $6. Okay, almost $6.5. You can consider $6 as of now. Now let's calculate the pricing. So what I'll do, I will open up my calculator. I'm going to actually calculate the price per day. Actually, per day, how much actually it will charge me. Let's say the price, you can see it's $6. Okay, $6 times, I want to run 24 hours. This model, okay, this model I want to run, let's say 24 hours in my actually SageMaker, okay, platform. Because see, 24 hours your application should be keep on running. It's not like that you are running for 2 hours, again you are stopping. No, people won't be using your application. ChatGPT is running 24 hours, okay, 7 days. It is all I mean running every time. So you will see there is no downtime. So whenever you are creating your application, it should be always running in 24 hours. Okay, so let's say I want to consider per day how much actually it will charge me. So 24, 6 times 24, so it will charge me actually $144. Only just one day it will charge me $144. Now if you're from India, if you're from Bangladesh, if you're from any other country, just try to convert the currency, okay, in your, let's say, money, and try to see how much money actually it is taking per day from you. Got it? Now let's say I want to run this model. Let's say I want to run this model, let's say 7 days. So what I'll do, I'll just multiply with 7. Now see, this is the 7-day cost I got, $1,008. So it is more than 1 lakh rupees. Okay, more than 1 lakh rupees actually it will take if you're running this model 7 days. Let's say I want to run this model 4 weeks. So this is the charge actually it will take. Now let's say I want to run this model 1 year. So I can multiply with 12. See, this is the 1 year cost actually you are getting. $48,000. Okay, 384. So now let's see, if you're running a small startup, if you're running a small company, so will you afford that much amount of money? Will you be able to pay this much amount of money? No, definitely you are not. So at the end, your cost is increasing. If you're using this kinds of open source large language model, if you're deploying on these kinds of, let's say, platform on the custom, let's say, hosted server, so you will have lots of cost at the end. So better to use the OpenAI model that time, yes or no? Because OpenAI model will charge you less, very less than, okay, very less than this amount of money. Got it? So that's why actually LLMOps comes into picture. So what big tech company actually did, they came up with actually different kinds of LLMOps platform. So I think you saw, not recently actually, this LLMOps platform came actually long back. So Google actually came up with one LLMOps platform called Vertex AI. Okay, Vertex AI. So previously, when you used to use MLOps, also we used to use something called Vertex AI for the MLOps also. Because this Vertex AI provides all kinds of functionality, all kinds of, let's say, pipeline for the machine learning operation as well. Okay, nowadays they also integrated generative AI, okay, in the Vertex AI. Even AWS, that means Amazon Web Service, they also came up with another LLMOps platform called Bedrock. Okay, Bedrock. Okay, Bedrock. So Bedrock is also one LLMOps platform. And this is the new service actually they have launched in the AWS, actually, let's say, website. You will see that there will be one section called Bedrock. Okay, so Bedrock also provides all kinds of LLMOps services. Let's say you want to use any kinds of foundation model. You want to use Llama, Mistral, okay, any kinds of foundation model. So this model is already hosted. See, this model they have already hosted in their server. Let's say whatever Llama model, whatever Mistral model, whatever model you see, these are the model is already hosted in this LLMOps platform. Like that, Google has also hosted lots of foundation model in their server. It's not like that they're only hosting their model. Let's say Google is having their own model. They are having Gemini model. They are having Gemma model. Yes or no? Apart from these are the model, they also hosted some of the foundation model from any other organization. Let's say from Meta AI, from, let's say, Mistral. So what they did actually, they collaborated with these are the organization. Even they hosted their model in their platform as well. And they created one endpoint. They created one API. Okay, they created one API. Now, as an user, what I can do, I can use this API to interact with this model. That means, like, our OpenAI will send the request, okay, will send the request to this kinds of LLMOps platform with the help of API. And here I will mention what kinds of model I want to use, and this will give me the response. That means I don't need to download these are the model in my system. Okay, so this is the main benefit to use this kinds of LLMOps platform. Okay, and it is having all kinds of flexibility. Let's say you want to connect the data, you can easily connect. Let's say you want to connect the vector database, you can easily connect. Okay, that means all kinds of storage, all kinds of flexibility this LLMOps platform will provide you. It's not like that manually you have to take from any third party, let's say, tool. It's not like that. Complete, like, let's say, pipeline it is already having. Even let's say you are thinking to fine tune this kinds of foundation model, you can also fine tune. You can also perform the fine tune operation. So fine tuning will happening in their server only, not your system. Only you just need to set the configuration of the model. Then you have to pass your data. Automatically, it will perform the fine tuning in their server. Yeah, it is sure they will charge you, but you will see this price would be very less than your this cost actually. Whatever cost actually I showed you here. If you're, let's say, manually creating your server, if you're using manually different kinds of services, that time price would be high. But if you're using this kinds of LLMOps platform, your price would be very low, guys. Trust me. It would be very low. If you see the pricing, I'll tell you whenever we'll be exploring these are the LLMOps platform. There I'll also show you the pricing. You'll see the pricing, it should be very low. Got it? So that's why actually LLMOps is required. We need the LLMOps if I want to use these kinds of foundational model. It's not like that we only need to rely on the OpenAI model, because we saw that there are so many models which is more powerful than my OpenAI model. Even there is another cloud provider, I think you know, Azure. So Azure also having one LLMOps platform called Azure OpenAI. Okay, Azure OpenAI. So they have, what they did actually, they collaborated with OpenAI and they bring the OpenAI platform in the Azure platform only. Okay, on top of that, they created some more services and it is running on the Azure right now. So if you know about OpenAI, so you'll be also work with the Azure. Okay, Azure, let's say OpenAI. So OpenAI wise, we already saw how we can use OpenAI with the help of OpenAI Peki, how we can access different kinds of foundation model. Okay. So yes, guys, this is the complete idea of our LLMOps and why LLMOps is required. Okay. So in the next video, we'll be learning about one amazing actually LLMOps platform called Vertex AI from the Google side. So we'll see the entire platform, what kinds of service it provides. Even we'll also do lots of practical. We'll also do the hands-on. We'll be creating different, let's say, LLM-powered application with the help of Vertex AI. Even I will also show you the AWS Bedrock, how we can use the Bedrock, okay, to implement any kinds of end-to-end LLM-powered application. Even we'll also learning how we can deploy these at the project as well. Fine. So yes, guys, this is all about. I hope you liked it. So thanks for watching, and I will see you in the next video. Hi everyone. In this video, we'll be starting with our very first LLMOps platform called Vertex AI. And I think I already told you, Vertex AI is the platform from the Google. So it is available in the Google Cloud. So Google has developed this platform. So here we'll be doing this complete generative AI on the Google Cloud. We'll be learning how we can use different kinds of foundation model. Even with that, how we can create different kinds of LLM powered application. So guys, here you can see this is the complete revolution at the Google inside artificial intelligence. I think you remember in 2017, they bring actually one architecture called transformer. So whenever this transformer architecture came in the market, after that actually so many revolution happened in the field of language model, in the field of large language model. That means whatever architecture you can see nowadays, all the architecture are using this transformer architecture in the backend. Even I already created one video, right? I already took one session on the transformer architecture, like what was the main component inside transformer architecture and why it is so powerful, right? So then after that, actually in 2018, actually they came up with another model called BART, B-E-R-T. So this is one of the actually language model they brought. Then they brought actually T5 model. Then slightly actually in 2020, actually they brought one large language model called Lambda. So Lambda was an amazing model in the field of large language model. Then 2021, they actually published AlphaFold model. Then 22 Palm model. And in 2023, they introduced something called BART model. Okay, B-A-R-D, BART. I think we used to use Google Bard, right? Google Bard, that means it is the ChatGPT kinds of interface, I think, remember. Nowadays, this Bard has been, let's say, replaced with the Gemini. So we now actually we search for Gemini, but previously we used to search for Bard, right? So this was the first application from the Google, actually they published. And you can see the model summary, like what are the tasks this model can perform. So as you can see, T5 can perform text-to-text generation. It's a transfer learning model. It is having actually 10 billion parameter and it's open source model. Then Google Lambda model. Then you can see the Lambda model trained to converse. Then AlphaFold predict structure for all known proteins. Then Palm, actually, this is the industry leading actually large language model. They introduced something called conversational AI, the service powered by Lambda. Okay. Then in 2024, I think you can see from the Google research, we are having Gemini. Then Imagen 2, okay, this can actually generate image, okay, with respect to the text prompt. Then we're having also something called Zima. Okay, Zima is one of the large language model. Then there is another model called Sharp. This is the model, it can generate speech to text. So that's actually revolution happened. That means it took actually lots of time to came up in this position. And Google introduced actually so many research, so many model, okay, so many technology. And nowadays actually we are using this kinds of technology, okay, in the field of generative AI. And guys, here you can see these are some actually first party foundation model like Palm for text. You can customize language tasks. Then Palm for actually chat. So here you can perform conversation. Okay. Then you can do the image gen. Okay. For the text to image. That means if you give any, let's say, prompt, it will generate the image. Okay. Then we also had something called embeddings model. That means embedding API. Let's say you want to generate any kinds of embedding for the text or image. You can use this kinds of embedding model. Okay. Then chart model, speech to text. Then code generation model was also available. So this was the first party foundation model in the Google research. Okay. Then they introduced something called Model Garden. Okay. So what is Model Garden? So here you can access, customize and experiment with different foundation models and its API. Okay. That means what Google did actually, they introduced one platform called Vertex AI. So Vertex AI was the platform in the Google, and it's been actually long. This platform is available in the Google Cloud, but only we used to perform MLOps operation with the help of Vertex AI. But whenever actually this generative AI came, so they updated this Vertex AI and they introduced something called Model Garden. That means inside Vertex AI, you have one Model Garden. Inside Model Garden, you are having all kinds of Google model. Whatever model actually Google has published now, all the model you will get, all the foundation model you will get in the Model Garden. Apart from that, you will also get something called open source model. Like whatever open source model I think I showed you now, from the Hugging Face, from different, let's say, organization like Llama, Mistral, Falcon, right? Different kinds of open source model I think I already introduced in the Hugging Face. So what they did actually, they also hosted this kinds of open source model in the Model Garden. That means you can use all kinds of open source model from the Model Garden itself, okay, from the Vertex AI. Then it is also having some partners model. So what is partners model exactly? So they collaborated with different kinds of organization. They collaborated with the different kinds of company. Let's say Cloud is a company. Then we are having Meta is a company. Okay, that's how we are having different kinds of company. So this company has also introduced so many large language model. Okay, so what they did actually, they collaborated with the company, collaborated with the organization, and all kinds of actually model they introduce in the model garden. So this is called actually partner models. Now let me show you the Vertex AI platform right now, how it looks like. You can see guys, this is the previous Vertex AI platform. Okay, that means here we used to only perform the ML operation, that means machine learning operation. That means you can perform the experiment, train and deploy, okay, for the data science workbench. Now what they introduce actually on top of this platform, they introduce generative AI. You can see they introduce something called generative AI platform. That means here you can perform the prompt designing, fine tuning, generative AI studio, okay, foundation model, open source model, okay. Then you can also perform actually LLMOps, everything you can perform in this platform right now. That means instead of replacing the previous actually, let's say Vertex AI services, on top of that, they created one additional layer, and this is called actually LLMOps platform nowadays on the Vertex AI. Okay, now I think it is clear. Now, as I already told you, they introduced so many actually partners model. Okay, I already told you they introduced so many partners model in the model garden. So these are the partners. Okay, these are the partners actually with Google. I think nowadays they also collaborated with so many organizations. If you open the Google Cloud Vertex AI, will see different kinds of actually partner models are available. So here you can see AI21 Labs. These are another organizations that they collaborated with the Google. Then Anthropic, Cohere, then Contextual AI, okay, Midjourney, then OSM, then Resistant.ai, Meta, okay, Runway, and so on. So these are the actually partners model actually it will be getting in the model garden. Now let me show you this GCP, okay, GCP Vertex AI. So let's open up our account and let's open up the Vertex AI there and try to see whether these are the things are available or not. So for these guys, what you can do, just search for GCP, okay, GCP console in your Google, and make sure you have one GCP account. Okay, if you don't have the GCP account, guys, so you won't be able to use the Vertex AI. So make sure if you don't have the account, just try to create one account. Initially, it will give you $300 credit. Okay, so let me log in with my console. So guys, as you can see, this is my GCP console. So here, what you have to do in the search button, just search for Vertex AI. Okay, Vertex AI. So you'll see this is the platform. This is the LLMOps platform you will get. See, this is the complete Vertex AI. Now, left hand side, you will see different kinds of services. So here, I already told you it is having model garden. So let me click on the model garden. So here, you will see all kinds of model. So guys, as you can see, whatever model I showed you, all kinds of model are available. Apart from that, they have also actually brought new model here. You can see. So foundation model, okay, then partners model. See, all kinds of models are available. Okay, as you can see, Meta model is available. That means Llama 2, Llama 3. Okay, then Palm model. You can also show all the model here. See here, I can click on the show all model. See, all kinds of model are available. See, Mistral also is there. Then Jamba model. Then you can see Cloudy. Okay. Apart from that, you will see different kinds of actually foundation model you will get. Okay. And these are the actually partner, okay, partner company. Apart from that, you can also filter out. Let's say you need language model. So here you are having 63 language model. You can filter out all the language model. Let's say you need vision model. You are having 11 vision model. You can also filter out all the vision model. Okay. Now let's say you want to use this model. Just click here. And you will get all the guideline how to use this model and all. Okay. They have already given the source code, everything they have given. Okay. How to use the Python SDK for, let's say, using this model and all the, let's say, guideline they have already given. Okay, I'll tell you how we can use these are the model one by one. Okay, now let's say you want to also play this model in the model garden. Okay, it is also possible. Let me show you. So let's say this is my model garden. Let's say I want to, let's say, play with this model Gemini 1.5 Pro. So I'll just click here. Now you can see open in a Vertex AI Studio. So here you can open this model in the AI Studio. So they are also having one AI Studio. Let me show you. Even you can also open with the help of Collab Notebook, and there also you can also play with this model. Now let's click on the I agree and continue. Now here you can pass any kinds of prompt. Let's say I will give hello, and I will send this prompt. And this is the response actually I'm getting. Okay, so that's how actually you can play with different kinds of model before using it, like how this model is working on all, what is the performance of the model, everything you can perform here. Okay, then you can also search by the model name. Let's say you need Jimma model, Llama model, anything you can search here. You will also get these are the model. Got it? And guys, these are the model is already hosted in the Google Cloud, so you don't need to manually download these are the model in your system. You can use these are the model with the help of API request. As I already told you, that's how. So that is why we call it as a LLMOps platform. Okay, so they gives the API kinds of functionality with the help of API request. We can use these are the model in our let's say project implementation. And don't you worry, I'll tell you how we can access different kinds of model. We'll be also implementing some kinds of application. Now, apart from that, Vertex AI also provides so many services. You can see it provides the pipeline services. This is the pipeline for the MLOps. Let's say you want to perform any end-to-end pipeline, data ingestion, data validation, model training, model evaluation. You can use the pipeline services. Apart from that, it also provides the notebook services. That means, let's say you want to, let's say use one large language model. You want to fine tune one large language model. You can use their Colab Enterprise. That means you can take the machine. Okay, good configuration machine, good configuration Colab notebook in their Google Cloud service. Okay. Then you can also take the workbench as well. Then you can see different studio is there. You can perform different kinds of, let's say, task demo. Let's say you can perform chat demo, vision demo, translation, speech. Okay, you can play with these are the functionality. As of now, I'm not showing. Then you can also download different kinds of extension for the generative AI from the extension market. Here you will also get something called feature store dataset. Okay, labeling task, then training, experiment. Okay, so some of the services you will see, these are the MLOps services, not the generative AI services. Apart from that, you will also get something called vector search here. This is another super important service from the Vertex AI. Let's say you don't want to use any other vector database. What you can do, you can use this Vertex AI vector search. This is another vector database. Okay, and this is hosted in the Google Cloud. That means in the Vertex AI. So going forward, I will also show you how we can use this vector search. Okay, vector search functionality from the Vertex AI itself. So yes, guys, these are the services actually Vertex AI provides. So unless and until you are not exploring all the functionality, okay, you won't be getting. So try to open this account, guys, and try to explore all kinds of functionality. Okay. And now there I told you we can perform different kinds of operation. Okay, different kinds of this operation. It will give you all kinds of functionality. Okay, and I showed you the model garden and all. So then I already told you we can also perform something called fine tuning. So it's not like that you can only use these are the foundation model for the inference. No, you can also perform the fine tuning operation. That means this Vertex AI will give you the functionality. You can also improve the model performance with the help of fine tuning. Okay, on top of your custom data. You can also perform something called human feedback to increase your model usefulness. Like I think previously you saw in the ChatGPT, it used to give one feedback box, right? Let's say how is your experience. So that you can give your experience rating. So that kinds of rating also you can pass if you're using this kinds of Vertex AI. Then here you can also generate customized images for your business. Then here you can also improve Google's predictive AI with your own custom data. Okay, everything is possible here. Now you can ask me what kinds of tasks actually I can perform here. You can perform all kinds of tasks. So you can perform language, image, video, okay, documents, speech, tabular. So here all kinds of tasks you can perform with the help of Vertex AI. Okay. And what Vertex AI actually provides, as I already told you, it will give you state-of-the-art foundation model. Even you will also get end-to-end governance. That means you can do the prompting, tuning. Okay. You can also perform MLOps operation on the Vertex AI. Even here you will get the data privacy. So whenever, let's say you are uploading your custom data to the Vertex AI, it's not like that your data would be leaked. It would be secure. Okay. So this kinds of actually ensured you will get if you're using a Vertex AI platform. That means you will have the complete data security. So no need to worry about your data. If you're having any custom data, all the data would be secured here. So now I think you got the difference between MLOps and LLMOps. So in the Vertex AI, we have the MLOps like services already. On top of that, they created the LLMOps. Okay. So here we don't need to throw out your existing MLOps investment. Okay. So here what you need to do, you just need to understand the unique MLOps need for the generative AI. That means whatever additional, let's say functionality they have given, just try to understand and try to use, let's say those are the service in the generative AI field. Okay. That means you can see in the Vertex AI, you will see multitask model prompting. Okay. Then model garden, customization, managing new artifacts, evaluation monitoring. Okay. Connecting with the enterprise data. Let's say you want to connect with different kinds of data sources. It is also possible in the Vertex AI. So now as a high level, you can see the complete MLOps on the Vertex AI. So this was actually our traditional Vertex AI. That means here we can perform experiment, training and deploy and predict, okay, for the machine learning operation. And now in the Vertex AI, you can also perform something called prompt predict. Okay, then you can also use something called foundation model. That means all kinds of generative AI based functionality you will get here. Then I already told you, you can also connect with different enterprise data. Let's say you want to connect any external sources, any API, any website, you can also connect, okay, with the help of Vertex AI. So guys, all kinds of flexibility you will get here if you're using Vertex AI LLMOps platform. So no need to worry about anything. So yes, guys, this is the complete introduction of our Vertex AI, the complete generative AI on the GCP cloud. In the next video, we'll try to see how we can build different kinds of transformative LLM powered application, okay, with the help of this Vertex AI platform. With that, guys, thank you so much for watching this video, and I will see you next time. Hi, guys. So far, we have discussed about LLMOps and this generative AI Vertex AI. Now, in this video, we'll be trying to use this Vertex AI as a practical. That means, let's say if I want to use any kinds of foundation model with the help of Python code, so how we can do it. Okay, that means we'll be doing the entire hands-on in this video. So try to open up your Google Cloud, guys, everyone, and just try to open up your Vertex AI. I already showed you how we can open up the Vertex AI, right? Now, after opening the Vertex AI, the first thing you have to do, you have to enable all the recommended APIs. So there you will see one option, enable all the recommended APIs. So make sure you have already enabled all the recommended APIs. So after enabling, in the notification bar, you will see all the API has been enabled. So these are the API you should enable. Otherwise, sometimes actually will get different error. So that's why make sure you enable all the API. Now here you can either open up your Google Colab to perform all the, let's say, operation I'll be doing here. Either you can also open up this Colab Enterprise or Workbench. Okay, so here I'm using this cloud platform, that means LLMOps platform. So in this video, I'll show you how we can use their services actually. Let's say if I want to use Colab Enterprise, how we can use Colab Enterprise. You can also launch this Workbench. So what is the difference between Workbench and Colab Enterprise? Let me show you. So in Workbench, actually, you can select the machine configuration. So here you can create a new Workbench. Just try to click on create. Now here you can select the machine configuration, like what should be the machine name, what is the reason. Then you can also select the instance type. Okay, that's how actually you can change the configuration. Okay, all the configurations you can change here. Okay, everything you can change here. That means if you want to create a custom machine as per your requirement, you can change here. And here you can see the pricing summary. That means per hour, it will charge you $0.18. You can see price is very less. It's not like a very huge amount of money they will be charging. It's like very less money. So you can also create your custom configuration. But here I'm not going to create the custom configuration. What I'll do, I'll use the Colab Enterprise. Okay, this one. So it will give me Google Colab kinds of interface. And there I can actually do my coding. So after clicking on Colab Enterprise, so here you will get one option, create a notebook. Okay, so just create a notebook. You can also select the region, but I will keep the default region, US Central 1. Okay, that's it. Now you can give the name. I can rename this notebook. Let's say I'll rename it as Vertex AI Demo. Okay, you can give any name. I've given this name. Now, if you want to increase the size of the notebook, if you want to increase the size of the cell, let's say if I write something, so the text is like very small here. So I can also increase the size. So for this, what I can do, I can click on the settings. You just go to the editor. And here you'll see this font size. Just try to make it as, I can take 28. Okay, 28, I think it is fine. Now, the next thing what you have to do, guys, you have to connect this notebook. So let's click on the connect button. See, guys, once you will be connecting the notebook, it will give you this kinds of pop-up screen. That means you have to select an account. Okay, like which account you want to use. So make sure whatever actually account you are using for the Google Cloud Console, that means for the Vertex AI, that account you have to select here. So this is my Google Cloud account. I'll just try to select. Now it is also asking for password. So let me give my password and I'll click on next. So if you're doing for the first time, so it will give you this kinds of authentication. It's just a one-time authentication. Okay, that's it. So guys, as you can see, my runtime is connected. Now, if I execute the cell, if you want to execute the cell, just press Shift and Enter. The same thing, the way actually you execute any Colab notebook, you can execute as the same. Now see, I'm getting the OK output. Now you can also download this notebook. So there is a download button. You can also download the notebook. So first of all, let's do the coding. After that, you can also download this notebook. Even I will also share this notebook with you in the resources section. Fine. All right. Now see, here we'll be using actually Vertex AI. Okay, we'll be using Vertex AI services. That means we'll be using Model Garden. So from the Model Garden itself, what we'll do, we'll try to access different kinds of foundation model. Got it? And if I want to use Model Garden, that means the complete Vertex AI, I have to install one library. So you have to install Vertex AI SDK for Python because we'll be using Python code, right? And if you're using Python code, you have to install this library. So here I want to install the upgraded version of the package. And this is the package name, Google Cloud AI Platform. Got it? If you want to use Vertex AI, you have to install this Python package. Now let me install. Okay, now after installing, it will tell you restart the runtime. Just click here. So it will automatically restart the runtime. After that, you just need to import Vertex AI. Okay, just to test whether everything is fine or not. Now see, if I import, it should work. See, it's working fine. There is no error. Fine. Now see, those who are running this code from the Colab notebook, you just need to do two configuration here. So let me show you. So the first configuration you have to do, this one. That means you have to authenticate with the Google Cloud first of all. So here, let me write the code. So first of all, you have to authenticate with the Google Cloud, okay, from the Colab notebook. And for this, you have to execute this line of code. So here, everything I'm running from the Vertex AI only. That means I'm using Colab Enterprise from the Vertex AI. I don't need to perform the authentication. But if you're running from the Google Colab, that time you have to do the authentication, guys. Okay. So let me show you one example. Let's say if I want to load any model from the Colab Enterprise, that means if I'm using Vertex AI services, I don't need to authenticate it. I can easily load it. Let me show you. So for this, let's import some of the library first. So here I'm importing some of the library. You can see generation config, generative model. Okay. I'll tell you why I'm importing them and what is the use of it. First of all, let me import all of them. Now let's say I want to load one model. Let's say I want to load this Gemini 1.0 Pro model. So you can see there is a model Gemini 1.0 Pro. Just click here. If I click here, you will see the model ID. You just need to copy the model ID from here. Now if you just go below, they have already given the source code. Here you can see this is the model ID. Just try to copy this ID and try to paste it here. Okay, that's it. Now see, if I execute this code, it will automatically load the model. See, there is no error. But if you executing from the Colab notebook, you will see you will get one error. That means your notebook is not authenticated with the Google Cloud. Okay, so that's why you have to execute this line of code. It will what it will do, it will authenticate. First of all, it will ask for the email address. That means which email address you are using for the Google Cloud account. That email address you have to select first of all. Got it? Then the next actually configuration code you have to run this one. Let me show you. This one. If you are using Colab Enterprise, guys, you don't need to execute. But if you are using Google Colab, you have to execute. Now see, this is the code you have to execute. So here you have to pass the project ID as well as your location. Okay, that means region. Now how you will get the project ID? So here you can see on top you have the project ID. Just try to click here. Now see, I'm inside my first project. So here is the project ID. Just try to copy the project ID and try to mention it here. Okay, in this box actually, you just need to paste it here. Then you have to give the region name. And what is your region name? You can see I'm inside US Central 1. So try to mention US Central 1 here. Okay. Then if you execute, it will automatically initialize with the Vertex AI. That means it will authenticate with the Vertex AI with your configuration. Now it will get to know, okay, now you are the correct user. So once it is authenticated, then you will be able to use all the services from the Vertex AI. That is all the foundation model, all the services you can use. Got it? So this two line actually you have to execute if you are using Google Colab. See, Colab only. And if you're using Colab Enterprise, no need to execute, guys. Okay, you can run as it is. I hope it is clear now. Okay, so now I think you saw how we can load the model. To load the model, you have to use one function called generative model. You can see I've already imported this generative model from the Vertex AI preview.generative AI models. Now import generative model. Inside that, you just need to give the model ID. Now, if you want to use any other model, simply just try to open. Let's say you want to use 1.5 Pro model. So just click here. Okay, so you can see Gemini 1.5 Pro model. Now just try to go below. And here is the model ID. So try to copy the model ID. So this is the model ID. Just try to copy and try to paste it here. So that's how, if you want to use any model from the model guidance, just try to copy the model ID and try to paste it inside this function. It will automatically load that model for you. So now let's test this model. So here I'm going to pass one prompt. So here I've already prepared one prompt. Let me show you. This is the prompt, guys, I have prepared. Okay, see, so here I'm using the model object and I'm calling one function called generate_content. Inside that I'm passing the prompt. Why is sky, so here is the prompt. Why is the sky blue? And stream is equal to true. Why I've given stream is equal to true? Because if I show you, if I, let's say, open the Gemini or ChatGPT, if you can open anything. Let's say if I give this same prompt here now. So if I, let's say, pass the same prompt, why is the sky blue? Any kinds of prompt if you give, it will give you stream kinds of output. See, it's not actually one shot output. It will give you stream output. So I think here you saw it will give you stream output. That means after one word, it is coming another word. Okay, that's how it is giving stream output, not in one shot. So that's how we also want to get the output from my response. Okay, that's why I've given this parameter stream is equal to true. That means it will give you stream output. Got it? Now see, if I execute, so here you will get one response object. See, this is the object. Okay. So it would be an object. See, this is a generator object. Now here I can apply any kinds of iterator, that means looping, and I can get the response. Now let me show you. So here you can apply looping. So here I'm applying looping for response in responses, and I just wanted to print the text. Okay, whatever text actually I'm having from the response, I want to print it. Now see, if I execute the for loop right now, you will see the response. See, this is the response actually I got, and this response is actually short response. That's why you didn't saw the streaming output, but if it is generating bigger output, you will see the streaming output would be visible. Got it? Now we can try with different prompt. Let's try with another prompt. So I'll give another prompt here. Let's say I'll give what are the latest developments in the automotive industry. Okay, now if I execute, so it should give me the response. Okay, see, this is the streaming response I'm getting, guys. I think you saw. Okay, this is called actually streaming response. See, the complete response I got. Great. Now see, here I pass the prompt directly, okay, in the generate content function. But if you want to pass as a parameter, you can also do it. For this, I've created another example. So this is the example, guys. Just a minute. Just see that. So here I created a variable called prompt, and inside that I've written the prompt. Let's say this is my complete prompt. Create a numbered list of the 10 items. Each item in the list should be a trend in the tech industry. Each trend should be a less than 5 words. Okay, try. Now we can give any kinds of prompt. Now here what I'm doing, I'm calling the model object generate content. Inside that I'm giving the prompt. Okay, whatever prompt actually I've defined, stream is equal to 2. Then again I'm performing the looping operation. Now see, if I execute, it should give me the output. Okay. Now you can also customize the prompt. Let's say here I can give translate in Hindi. See, I'm also getting the Hindi translation as well. Got it? So that's how you can also customize your prompt. It's up to you. Now, I think you remember whenever I was like going through the model garden. So I can also open this model in a Vertex AI Studio. I think I showed you. So let's open this model in the Vertex AI Studio. See, if you open the Vertex AI Studio, right hand side, you can see, you can also set some of the model parameter like temperature, output token. Okay. So these are the thing you can also change. So how we can change with the help of Python code, because as a developer, we have to use with the help of Python code, not from the UI interface. Got it? From the UI interface also you can use the model, but as a developer, we have to use from the Python SDK. So here we can also set the model configuration. So let me show you. So for this, you have to use this function actually. So I think you remember the generation config. Okay. So let me show you. So I already prepared. So inside generation config, I'm passing all the parameter. Okay. Let me the temperature, top P, top K, candidate. Okay. Max output and so on. And I think you already know these are the parameter I already explained previously. What is temperature? What is top P, top K? Got it? Here temperature means here you are assigning the model creativity, like how much creativity you want from the model. If it is close to 1, that means it will take risk. It will be more creative. If it is close to 0, it won't be taking any kinds of risk. Okay, that's the idea. Now this generation config you have to pass as a parameter of generation config. Here you can see generation config is equal to generation config, and the same prompt I have given, stream is equal to 2. Again, I'm looping through the response. Now if I show you, now I'll see that your output would be more creative. Okay. So previously, I think you remember we got actually very short output. Now see, this output is more creative right now because we given the configuration model parameter right now. Okay, I hope it is clear. Now let me show you another thing you can do. This is called actually test chat prompt. Now what is test chat prompts? Let me show you one example. Let's say here I ask one question: why is the sky blue? Okay. Now this prompt actually I have given, and my Gemini will try to remember this prompt. Now if I ask, give me the answer in bullet point. Okay. Now see, here I haven't mentioned I want this answer. I just give me the answer in bullet point. It will automatically remember my previous, let's say, context. Okay. That means I want to ask this particular response. Now see, it has given me in the bullet point. Okay. So this is called actually memory. That means it is trying to remember the chat history. So that thing you can also perform here. So let me show you. So for this, you have to use one more line here. This is the line, guys. Model.start chat. So this start chat will automatically remember all the conversation you are doing with your large language model. Now this is the prompt actually I have given. My name is Bappi. You are my personal assistant. My favorite movies are The Lord of Rings and Hobbit. Suggest another movie I might like. So this is the prompt I'm giving, and this is the stream is equal to 2 I'm giving. And now see, if you are using chat, that time you have to use chat.send message. Okay, chat.send message, because here you have initialized the model. I think you remember. Now see, if I execute the program. So guys, as you can see, I got the output. Okay. Now what I will do, Now what I will do, based on this answer, I will ask another question. So because it has remembered my previous context. So here now asking, are my favorite movies based on a book series? This is what actually I'm asking. Now see, if I ask this question, see, it will refer my previous actually context. Yeah, you can see both the Lord of Rings and the Hobbit trilogies are the based on the book series, okay, by J.R.R. Tolkien. Okay, now I can show you the story. So if you want to see the story, just write chat.story, so it will show you the entire story. See, so first of all, you ask this prompt, your model has given this answer. Then again, you ask this question, your model has given this answer. Got it? I hope it is clear. Fine. So that's how actually we can use any kinds of language model. Now let's try to see any multi-model. That means we'll be also using some vision model. So I think you know, here actually we are also having some vision model as well. So this is my model garden. Now just click on the vision model. You will see there are different kinds of vision model are available. So from here, I'm going to use one vision model. So Gemini 1. Pro vision model. So you can search this model here. Now, if you want to load this model, you can load like that. This is the model ID. So let me show you this model. I'll copy the name and in the model garden. So here you can search this model. You will see Gemini 1.0 Pro vision model. Okay. Now see, this is the vision model. So with this model, actually, you can also work with the images and videos. Okay. Now this is the model ID you have to give. Now I've given the model ID. Now let's load the model. Fine. Now here I'll be working with images and videos, and to work with images, videos, I need some helper function. That means this helper function will help me to load the image, visualize the image. Okay. So here I have created some helper function. Let me show you. So these are the helper function I created. You can see different helper function I created. Display image. So it will display the image. If you want to get any image as a bytes from the URL, you can get with the help of this function. Load image from the URL, you can use this function. Get URL from the GCS, you can use this function. Print multi-model prompt. That means if you want to print any multi-model prompt, you can use this function. Okay, so that's how we can create some utility-related function, and this function you will get over the internet. If you just simply search how to display image, give me a function, you will get this kinds of code. Okay, so I have initialized. These are the utility-related function as of now. Okay, so here the first thing I'm going to show you how to generate actually caption from any image. Okay, so for this, let's see one example. This is the example, guys. So here I'm downloading one image. You can see this is the image URL. So guys, you can see this is the image. Okay, this image actually will be downloading. So here let me show you. And how we are downloading the image, we are using gsutil command. Okay, so if you execute this command, it will download the image from the URL. Then I'm loading the image. Then I'm giving a prompt, describe this image. Okay, I'm passing the image as well as the prompt. Then I'm using the multi-model. That means the model we have loaded, I think, remember this Gemini 1.0 Pro vision model. Okay, you can also use any other vision model. So simply go to the model garden and try to choose any other vision model. You can use as it is. Okay, now let's get back. Now whatever actually, let's say output I'm getting, I'm just rendering. Okay, that's it. Now let me show you. So guys, as you can see, this is my results I got. So here I've given a prompt and this is the image. Now it has given me the caption. So the image shown a gray cat with black strips walking in the snow. The cat has yellow eyes and long tail. You can see yellow eyes and long tail. Cat is walking towards the camera. Okay, that means this is a great caption my model has given me. Now let me show you another example. So I prepared another example. So guys, you can see I'm using another image. Now, if I show you this example, see, this is my prompt. I have given describe the image. That means describe the scene. Now see, this is the response I got. Now this is the response to pontoon boats are anchored in the Charles River in Boston. In the background are two breeze and Boston skyline. So guys, as you can see, this is a correct caption my model has given me. Okay. Now, if you want to use load image function, that means the function we created in the utility function to load this image URL, you can use this load image URL function as well. And with the help of that, we can also do the same thing. Okay, there are different techniques you can load the image. You can also use OpenCV to load the image. Okay, it's completely fine. Now see, I'm getting the same output. Now here we'll be learning another thing. Here we'll be combining multiple image and text prompt for the few shot prompting. That means here I'll be passing the few shot to my model, and my model will try to give me the response. So let me show you one example I prepared. So this is the example, guys. So here I'm using 3 images. So let me open all the images. So this is stored in the Google Cloud storage. Okay, you can see this is another image. So you can see this is one of the images, this is another image, and this is another image. So these 3 images actually I'm using here, and with the help of load image from URL, I'm loading both 3 images. Then first of all, I'm giving the prompt for 2 images. You can see these 2 images I'm giving the prompt. This one and this one. This one I'm not giving any kinds of prompt. Okay, you can see I've given city is equal to London, because you can see this is a London city and the landmark is a Big Ben. Okay, it's a Big Ben. So you can search on Google, Big Ben, I think. Yeah, see, this is the Big Ben. Okay, so that's why I'm giving some prompting. That means I'm giving the label. Okay, now prompt 2, the second image I'm giving, this is the Paris city. City is equal to Paris, and landmark, you can see it's Eiffel Tower. Okay, you can see it's Eiffel Tower. And the third image, I'm not giving any kinds of prompt. Now let's try to see my model is able to generate the actual, let's say, prompt for that particular image or not. So here you can see I'm passing my image 1, prompt 1, image 2, prompt 2, and I'm only giving the image 3 here, not the prompt. Now I'm using the multi-model and generate content. Now let's try to see whether it is able to identify that image or not. See, these 2 actually I have given, it's fine. Now see, third one, city, Rome, landmark, Colosseum. Okay, so let me copy and let me try to verify. See, correct. It's the correct one. Okay, so beautifully my model is able to generate the response. So this is called actually few shot prompting. Now also let's try to see some video example. So what I will do, I'll download one video. So this is the URL of the video. I'll download this video. Let me download and let me show you here. So I think you remember Google has launched one phone actually called Pixel. Okay, you can see this is the Pixel. This is the Pixel advertisement. You can see this is the Pixel advertisement. Okay, so this video actually I have downloaded from the URL. Now I will give this video to my multi-model and I will give some prompt. Let me show you. So I already prepared one prompt. This is the prompt. Answer the following questions using the video only. What is the profession of the main person? What are the main features of the phone highlighted? Which city was this recorded in? Provide the answer in a JSON format. Now see, if I give this video and if I pass it to my multi-model, it should give me the response. See guys, I got the response. Now you can see the person name is Sheikha Shimada. Profession is a photographer. Brand is Google. Phone brand is Google. Model is Pixel 8. And you can see the features: video boost, night sight, city Tokyo, country Japan. Amazing. Okay, amazing actually response I got. Now you can use any kinds of video. You can do the caption generation. Got it? So that's how guys you can export different kinds of model in the model garden. It's not like only Google model. You can also, let's say, use Meta model as well. Let's say you want to use Llama model. Just simply click on the Llama and try to open this notebook. So they have already given all the code example and everything. Okay, only just you need to execute and you have to see how we can access the Llama model and all. Got it? So just try to explore guys. This is up to you because all the model I can't show you. So I have just given the demo like how we can access different kinds of foundation model. Now you'll be exporting whatever model actually you need later on. Got it? Okay, and one thing guys, after implementing all the code, what you can do, you can download this notebook, and after that you can delete this instance. Okay, no need to keep on running, just try to delete the instance. Otherwise you can also stop the instance, but I will try to delete it. Okay, I'll just try to do the confirmation. So after some times actually you'll see that this notebook would be deleted. Okay, now see, this is deleted. So yes, this is the actually hands-on part of this Vertex AI. So in the next video, we'll try to see how we can do the setup, everything on our, let's say, local machine. That means how we can connect this Vertex AI with the help of local machine. That means we'll be coding everything in our VS Code. From the VS Code itself, we'll try to access the Vertex AI model. That means foundation model. Okay, so we'll try to access the model garden from the VS Code. So for this, whatever setup actually required, I'll tell you each and everything. With that guys, thank you so much for watching this video and I will see you next time. Hi everyone, welcome back. So guys, in this video, we'll try to see how we can use this Vertex AI from our local machine. That means we'll be doing the setup, everything in our local. So previously I showed you how we can use Collab Enterprise. That means everything I was performing in the G Cloud. But in this video, I'll try to use my VS Code. And to access this Vertex AI, what are the configuration we have to perform? We'll be learning each and everything. Because see, going forward, whenever you will be implementing projects, right, end-to-end projects, so you have to implement through the VS Code, right? And if you want to implement through the VS Code, you have to know how to configure this Vertex AI in your local machine. Okay, so that's why it's super important to know how we can set up everything in our local machine itself. So for this, guys, you need one tool actually. So the tool name is GCP CLI. Okay, GCP CLI install. Just search GCP CLI install on the Google. So after searching this GCP CLI install, if you just go below, you'll see this link actually. Install the G Cloud CLI. So just try to open it up. Now here you will get the installer. See, download the installer. So I'll click on the link. So it will automatically start downloading this CLI for me. See, it has downloaded. Okay. And if you're using any other operating system, let's say Linux, then Debian, Red Hat, CentOS, macOS. Okay. All the command is already written here. You can follow the command and you can install this G Cloud CLI in your system. Because see, with the help of this G Cloud CLI, we'll be doing the authentication with our account. Okay. That is the thing. Now I have already downloaded it. Now what you have to do, just double click and try to install. So the way actually you install any kinds of normal software, you have to follow the same step. Okay, there is nothing new. So for me, I already installed. See, after installing, just search for Google. So you'll see this Google Cloud SDK shell. Just try to open it up. So we'll see this kinds of window. Okay, if you are getting this kinds of window, that means you have installed successfully. Okay, now let me close it. Now what I will do, guys, I will open up my local folder, and here I'm going to open up my terminal. You can open up your any kinds of terminal, whether you're Anaconda terminal, Git bash terminal, anything. Now let's also open up my VS Code here. All right, so here the first thing what you have to do, guys, you have to create one virtual environment. After that, you have to install all the required packages. Okay, then after that we'll be writing our actually code, okay, with the help of Vertex AI. So to create the environment, you can execute this command. So conda create -n, let's say Vertex AI demo Python is equal to, let's say I'll take 3.10 -y. Now let's create the environment. Okay, it's done. Now let's clear. Before clearing, I have to activate the environment. So this is the command. Let's try to copy and try to execute it here. Now let's create a file called requirement.txt. So I'll just create this file, requirements.txt. Inside that, I will mention all the requirements I need. So these are the requirements, guys, I need. I think you remember. So I think you remember, to use the Vertex AI, we have to install this package, Google Cloud AI Platform. I think in the Collab Enterprise also we did the same thing. Then Streamlit I want to use because I want to create a simple user interface. There actually you can give a prompt and you can get the response. And Python.env because I'm going to manage my GCP credential. Okay, that's why. Now here, let me create this file as well. So .env. Okay, inside .env, you need actually your project ID. Okay, then you need region. I'll tell you how to collect this project ID and region, but before that, let's do the configuration, okay, with our G Cloud. So first of all, let's me install all the requirements. So I'll just write pip install -r requirement.txt. All right, so installation is completed. Now let's do the configuration with our G Cloud. So for this, you have to execute this command called G Cloud init. Okay, just try to execute this command, guys. So if I execute this command, you will see that. See, if you're doing it for the first time, you will get this kinds of window. You must log in to continue. Would you like to log in? I'll give yes. So guys, now here you have to select the account. The account actually you are using for your G Cloud account. So this is my account. I'll select. Now you have to provide the password. So this is my password and I'll try to do the next operation. Okay, and then click on the continue and allow. Okay, now you can see I'm done with the authentication. Now if I come back, see, now actually I'm getting my project ID. You can see I'm getting my project ID. Got it? So let me show you. If I go to my dashboard, now if I click here, this is my project ID. Studios loader 4361. I think you can see that. Studio loader 4361 and 2. Okay, so this is my project ID. Yeah. Now, if you already have one existing project, you can select it. Either you can create a new project. So for me, I already have the projects. I'll just select the one. I'll select the one. That means my existing project. Now it is asking for, do you want to configure a default compute region and zone? I'll give yes. Now it is telling which region you actually want to take. So what I will do, I'll take this region actually. So Central US. So let's say I will take this one, US Central 1 C. So I'll give 7 here. Okay, now I think it is done. Now let me clear my terminal. Okay, so everything is set. Now let's create one file here called main.py. Inside that, I'm going to write all of the code. Okay, that means we'll be trying to access one. That means here we'll be trying to access one model from the model garden. But before that, you have to set this env. So you have to give the project ID. So here is the project ID, guys. I think I showed you how to get the project ID. This is the project ID. Just try to copy. And here, try to mention it. Then you have to give the region. So I think region I already showed you. So here you can check the region. Click on the collab enterprise. Left hand side, you can see US-Central 1. Just try to select it. US-Central 1. Okay. Now just try to verify it. US-Central 1. Okay. So it's fine. Now let me save. Now let's create the main.py. So first of all, let's import all the necessary library. So these are the library I need, guys. I think remember I was also importing them in my collab enterprise. So Vertex AI, then Streamlit I need for the user interface. Then I'm also importing some of the necessary, let's say, function from the Vertex AI preview generative models. Okay. So I need generation config and generative model, and .env I need because I want to load this env file. Now let's select my current environment. So this is my environment. Okay. Now this error will be disappear. Now the first thing, I'll load my project ID as well as the region from my environment. Okay. For this code snippet you have to run. Got it. Then I'll be initializing. Then I'll be authenticating with my Vertex AI. So this is the authentication code, guys. Vertex AI.init. You have to give the project ID as well as the project location. That's it. Now let's load the model. So here I'm going to load one model from the model garden called Gemini 1.0 Pro. So let me show you. If I go to the model garden. So this is the model, guys, I'm trying to load. Just click here and you will see the model ID. So just try to copy the model ID and you can use it. So this is the model ID, guys, here. Just try to copy and mention it here. Okay, that's it. Then I've created a simple function. Let me show you. So this is the function I created. Inside that, what I'm doing, I'm just first of all creating my Streamlit title. First of all, I'm setting my page configuration like Vertex AI demo. So it will give you one name. Then I'm setting the header. That means what will happen? It will give you one title. So here you can give any name. So here I've given, let's say, Gemini on Vertex AI, or you can give Vertex AI local demo, because everything we're doing in the local machine. Okay. Then user will give one question. So that's why I've taken a text input box, and this question actually I'm passing to my model. You can see. Okay, if there is a question, it will execute this model. Otherwise, it won't be executing. Okay. After that, actually, I'm going through the response and I'm printing in my console. Okay. That means in my Streamlit console. That's it. Now, if I want to execute, I have to call the function as well. So let's call the function. That's it. Now let's try to execute and try to see whether it's working or not. So I'll write Streamlit run app.py. Sorry, main.py. I think it's. Now let's give the allow permission. So this is the interface, guys. Now here you can ask anything. Let's say I'll give hello. Let's see. You can also see the terminal to get the log. Okay, you can see it is giving me one error. It is telling Google authentication default credential. Your default credential are not found. To set the default configuration, you can visit this link. So let's open this link. And I think it will suggest me some command there. So let's copy this command. And now I'll execute from my terminal. I'll stop it. Now let's execute. I'll select my account. The account actually I'm using for my G Cloud. So I'll give my password. Next. So if you're doing for the first time, so you might get this kinds of issue. So once this setup is done, you can use it as it is. Okay, now I think it is done. Now let's execute the application again. Now let's give hello. Okay, guys, now see, I got the output. There is no issue. That means what you have to do, you have to set the credential is a default actually credential. So that's why we actually executed this command, gcloud auth application default login. Got it? Now see, I'm getting the output. Now here you can pass any kinds of prompt. So here I can give, let's say, tell me about Python. Okay, see, I'm getting the entire response. Okay, got it. So you can now ask any kinds of question. That means from our local machine itself, now we are able to access the model garden. That means by Vertex AI services. All right. Okay, great. So yes, guys, this is all about from this video. Now we'll be using this technique going forward whenever we'll be implementing any kinds of project. Okay. So in the next video, we'll try to see how we can implement a RAG-based application. Okay, with the help of actually Vertex AI platform, and we'll be using some Vertex AI services there. All right. So with that, guys, thank you so much for watching this video, and let's connect in the next video. Thank you, guys. Hi, everyone. So guys, in this video, we'll be learning about how we can implement RAG application with the help of Vertex AI. So as of now, we saw how we can use model garden. That means how we can access different kinds of model. On top of that, how we can perform the inference. But let's say if you have some custom data, and with the help of that custom data, you want to create a knowledge base and you want to connect your large language model there. Okay, and you want to perform the query operation on top of it. So how we can perform it, and this is called actually RAG. I think I already explained, okay, in my previous video. So if you're not sure about the RAG, guys, first of all, check those video, then you will be able to understand, okay, what I'm trying to implement here. So that means let's say here I'll be using my custom data, and with that custom data, what I will do, I will create a knowledge base. Okay, and I'll just try to connect my large language model there. Then I'll be performing the query operation on top of my data, the data actually I have uploaded. This is the thing we'll be implementing. And here technology wise actually we'll be using the Vertex AI, entire Vertex AI platform. That means here everything will be using Google Cloud services. Okay, we are not going to use any third-party services. That means to store our data we'll be using Google Cloud bucket, and to store our embedding we'll be using vector store. Okay, vector store service from the Vertex AI. This is one of the vector database they have created. Okay, this is called actually vector store. So we'll be using all the Google Cloud service only, not any other service. Okay, in this video. So for this, guys, you can see I prepared one notebook in the Collab Enterprise. So first of all, try to connect the notebook. After that, you can check with the help of OK command. And if it is giving the OK message, that means notebook is running. Then the first thing what you have to do, we have to install. These are the library. As I have told you, we'll be using some custom data. I'm going to use PDF document. That's why I'm installing this PyPDF2. Okay, this library. Then Google Cloud AI platform, because if I want to use the Vertex AI, I need to install this package. Then I already told you we'll be using custom data. That means custom document. And to store this custom document, I'll be using Google Cloud bucket. I think you know Google Cloud also provides bucket service. Let me show you. So if you just open Google Cloud and search for bucket, so this is the bucket. So here you can create different bucket, and inside a bucket you can store the data. See, I already created one bucket called start content 2024. Inside that I'm having one documents. I'll tell you how to upload this document here. As of now, just try to consider we'll be using this bucket services to store my content. Okay, and no need to create manually, it will automatically create. I've already written the code for it. So these are the packages you have to install. For me, I already installed everything, so I'm not going to install again. Now see, you have to import. These are the library right now. So here I'm importing stories from google.cloud, because I told you we'll be using bucket, and to install bucket I need this actually function. Then I'm also importing text embedding model from the Vertex AI language model, because here we have to perform the embedding generation, and to generate the embedding I need some embedding model, and here I'm going to use Google embedding model. Okay, from the Vertex AI, from the model garden. That's why I have imported this text embedding model function. Then I also imported AI platform PyPDF, and these are the library I also imported here. And here I'm using UIID. Okay, why I'm using UIID? Let me tell you. See, there is a reason actually I'm using UIID. See, if you're using Vertex AI, this RAG would be slightly different. Okay, slightly different. That means, let's say whatever documents you will be publishing. Let's say I will be publishing one statistics PDF I'm having. Let me show you the statistics PDF. So guys, as you can see, this is the statistics PDF actually I'm having. So this particular data actually I'll be using as my custom data. Now what will happen? First of all, I have to extract the documents from the PDF, yes or no. So after extracting, what I will get different documents. I think you know, I'll get different documents. That means doc1, okay, then doc2, and so on. Now what will happen? This document I have to convert to embeddings as well. That means it would be converted to embeddings. So let's say you will get some vector here. Let's say 0.29, 0.55, 0.88, and so on. Let's say this is the vector representation of this doc1 and doc2 and so on. Let's say I'll just create some dummy vector here. Now here what I want to do, with the help of this UI ID, I want to assign some unique ID. Let's say the document one it has extracted, I will assign one unique ID. Let's say this is the unique ID. Let's say 1210. Let's say this is the unique ID. Okay, it has assigned to the doc1. Then in the doc2 it will assign another unique ID. Let's say 1211. Okay. Now what will happen? This unique ID also would be assigned in the vector, because this vector is representing this documentation. Yes or no? Okay, that's why this ID would be there 1210. Then this ID would be also there because this vector is representing this document. So 1211. Now what will happen? Let's say whenever you will perform the similarity search operation, that time what happens actually, it will return the relevant answer, yes or no. I think you know, whenever you implement any kinds of RAG, whenever you perform similarity operation, it will give you some relevant answer. Okay, relevant answer you will get. Okay, and from where you will get the relevant answer? From the documents only you will get the relevant answer, the documents you are having. Okay, now let's say it will give you this relevant answer. Let's say doc1. Whenever it will give you doc1 relevant answer, that means it will return the vector, because your model will only return the numbers, not the text. Okay, and this particular number will map where? In this document. That means this document is representing this vector. That means whenever your model is generating this vector, that means it will map this documents, that means the text. Okay, how? With the help of this UI ID. Okay, with the help of this UI ID. So it will look for where this UI ID is present, that documents actually it will show you as a relevant answer. Okay, now I think it is clear why I'm using this UI ID to give to assign actually unique ID in front of my documents and in front of my vector embeddings. Okay, now I think it is clear. Now let me clear my board. Now the next thing what you have to do, guys, you have to initialize some of the variable. Now see, if you are doing this project from the Google Colab, first of all you have to authenticate with your G Cloud. And how to authenticate, I already shared you two code. I think you remember two configuration code I shared with you in my Vertex AI demo session. So you can refer the notebook and you can first of all authenticate with your Google Cloud. Okay, and I said until you are not doing the authentication, it won't be working. I'm running from my Colab enterprise, that's why I don't need to do the authentication. So if you're running from the Colab, Google Colab, so you have to activate this line actually, project. So you have to give the project ID here. How to collect the project ID? This is the project ID. Got it? So here I'm running from the Colab enterprise, so I don't need this variable. I'll just try to comment it out. So here what I need the location, and this is my location. Then PDF path. So where you have to upload the PDF. So in the files actually you have to upload the PDF. Let me show you. So here you can right click and upload and try to select the PDF. Whatever PDF you are having, just try to open it here. It will automatically upload here. See, for me, I've already uploaded, and these two files would be generated as of now. See, I already executed this project. Okay, that's why all the artifacts you can see. Okay, but for you, it would be empty initially. So this two file would be created. How it will be created, I'll tell you. As of now, just try to consider we have uploaded this statistics.pdf file. Got it? Then you have to give the bucket name. So you can give any kinds of bucket name and make sure this bucket name should be unique. So this bucket would be created automatically in the bucket section. See, it is already created for me. Again, this would be created automatically. You don't need to create it manually. Then here you have to give embed file path. What is embed file path? Because see, I already told you. First of all, we have to extract the documents from my PDF. Then what we have to do? We have to generate the embedding as well with respect to the documents. And these documents and this embedding, I'm going to save in a JSON file. Okay, that's why I'm just creating some JSON file. You can see these two JSON file I'm creating. Okay, starts embedding .json and start sentence.json. Inside sentence.json, it will store all the documents, that is the English text, and inside embedding, it will store all the your embedding. Okay, embedding of the sentence. That means whatever, let's say, documents you are having. That means whatever documents you have. Okay, with respect to that, it will store the embeddings as well. Okay, with the unique ID. So that is the thing. Then you have to give the index name. Index name means let's say here we'll be using vector search, and inside vector search we just create an index. The way actually we used to create the Pinecone index, I think remember, we create an index here. So this is the index name. It will automatically create that index. Now here I've written a function. This function will extract the sentence from the PDF. So it will take the PDF path and it will give you the sentences. That means all the documents it will give you. Then I have written some of the helper function, guys. You can see generate text embedding. That means this function will generate the text embedding. It will take the sentence and it will generate a text embedding with the help of text embedding model. You can see I'm using text embedding gecko model. So this is the model, guys, text embedding gecko 001. So this model is available in the model garden in Vertex AI. Got it? Then I have written another function, generate and save embedding. That means this function will actually add the unique ID in front of your sentence. That means documents, and in front of your embeddings. That means vector embeddings. Okay. that means it will generate this both file, okay, and it will save as a JSON file. You can see here I'm doing it. I'm first of all actually creating my embedding, okay, and I'm adding the unique ID. I'm also creating the sentence. I'm adding the unique ID. Then I'm saving in a JSON file. Okay, this is the thing actually we are doing. That means this function is responsible for creating these two files, and it will store your sentences, and it will store your documents as well as the embedding with the unique ID. Okay, that's it. Then there is another function I created called upload file. That means after let's say generating this file, I have to upload this start sentence.json in the bucket. And how I will push to the bucket, we will be using this function upload file. You can see if you go to the bucket section, so this file is already present. Okay, so if you want to push any kinds of file, you can use this function. That means we created some helper function. This helper function will help me to do certain operation. This is the thing. Now here another function I have written called create vector index. So this function will create the vector index in the vector source, okay, in the vector source vector database, and each of the dimension would be 784. I think you remember previously we used sentence transformer actually embedding model, and we used to create I think 384 vector representation. I think you remember, right? But if you are using this text gecko model from the model guardian, your vector dimension would be 780. 768. This is the dimension, and you can see with the help of AI platform actually library, we are creating the index. So this function will automatically create the index for you. Got it? Then after that, I'm calling these are the function. You can see first of all I'm calling generate and save the vector. I'm giving my PDF path, sentence file path, as well as the embedding file path. Then I'm also uploading this file to my bucket. That means if I execute this line, what will happen? It will create this two file first of all. Let me open it. So this is my sentence. That means this is my document, and you can see first of all it will show you the unique ID. Then it will show you the sentence. Okay, that means this is the document it has extracted from the PDF. With respect to that, it has also saved the embeddings as well. Let me show you. So this is the embedding, and here you'll see the unique ID. That means the same ID, and now this is the embedding representation. Okay, I hope now it is clear. Now, so once it is executed, then upload file will execute, and it will upload this sentence.json to my bucket. Now if I show you, see bucket would be created, and inside bucket actually you will see this start sentence.json would be present. Okay, because later on, whenever I'll perform the, let's say, similarity search operation, I need that file. I need to download that file. With that, I'll do the search operation. Okay, similarity search operation. That is the thing. Now, the next thing, what we'll be doing, we'll be creating the vector index. That means we'll be creating the index, and inside index actually will be storing all of my vector. Okay, so here you can see I'm giving the bucket name. That means from the bucket name, it will load this file. Okay, it will load this file. That means the sentence file. So sentence file it will load. Then it will also take the index name. And with the help of actually that embedding model, it will generate the embeddings of that documents. The documents actually we are having, and it will store to the vector database. That means inside my vector source. Now, if I execute this line, okay, if I execute this line, it will take some time. It will, that means it will process all the data and it will store to the vector embedding. After that, if you open it up, let me show you. So if you open it up, so you'll see that it will create an index. The name actually you have given start index. Okay. Now you can see both places you are getting this green tick icon. That means everything is executed successfully. If you are getting any red icon, it's not completed. Okay. That means there are some issue. Now, if I click on the deployed index, you'll see one ID here. So we need this ID later on. So guys, you can see this is the ID. The last number you can see, this is the ID. So we need this ID later on. Okay. See, this is the ID. This ID actually we need later on. So now let's get back to my collab. Now again, just import some of the necessary library. Then again, set these are the actually variable like your location, sentence file path, and index name. That means the same index name. Okay, same index name you have to give. Start index. Okay, that's it. Then just load the model, large language model here. So here I'm using Gemini Pro. You can also load any other model. Then just try to load the index. That means index endpoint you have to load. And to load the index endpoint, you just need to give this ID. And how you'll get the ID, guys? I already told you. So this is the ID. Just try to copy this ID and just try to paste it here. Now if you execute, it will load the index ID. Got it? That means this is going to be your knowledge base right now. And this is going to be your model. Now again, I have written some of the helper functions, generate text embedding. That means whatever user will give the prompt. Now let's say I have given one prompt. This prompt should be also converted to the embedding. Okay, then this function will help me to do that. Then I've written another function, generate context and load file. That means it will load that documents file and it will generate the context. Okay, that means if you are performing similarity search operation, it will give you some rank results, and how it will give the rank results with the help of these two function, it will give the rank results. Now here I've loaded the file. Then you can see. Then this is my query. Let's say what is correlation. First of all, I'm generating the query embedding with the help of that embedding model. And if you want to see the query embedding, see this is the vector representation, guys. This is the entire query embedding. Now let me comment it. Now this query embedding I will pass to my vector source. Okay, now you can see find neighbor. It will give me 10 ranked results. Okay, 10 ranked results actually it will give me. Then this response actually I'm giving to my model. Okay, this is the code snippet. My model will try to analyze this response, even the query I have given. Based on that, it will give me one response. Now if I execute, see, if I execute this last line of code, see, here you will get the response. Correlation is a statistical measure that indicates, see, blah, blah, I'm getting the output. And here you can also give the prompt based on the context delimited in the brackets, answer the query. Okay, that's how you can give any kinds of prompt. And that's how actually we can build retrieval augmented generation kinds of application, okay, with the help of Vertex AI platform. And all these steps, guys, I have mentioned here. So if you are implementing any kinds of RAG based actually application, you can follow the same step. Okay, even you can also perform in your local machine. That means I told you how we can connect our local machine. That means how we can connect our VS Code. So with the help of VS Code also, you can create this kinds of RAG application, and you can create a user interface. Let's say you want to create a Flask interface, you want to create a Streamlit interface, you can also create. So this task actually I want to assign you. Just try to create one user interface. So you have to use the same logic, only you just need to integrate one user interface. That is the idea. Okay, I hope it is clear. Now see, once it is done, now if you want to terminate all the instance, what you can do. So first of all, just try to delete this. So first of all, just try to delete the bucket. To delete the bucket, just try to select the bucket, and there is a delete button you will see. Just try to click on delete, and delete confirmation you have to give. So it will delete the bucket. Then you also need to delete the index. So to delete the index, just go to the index, vector search. So first of all, you have to do the on deploy. Then you can delete it right now, I think. Now there is a delete button. Just try to click on delete. So it would be deleted. Okay, so that's how you can remove all the instance you will be creating. Okay, so I think, guys, this is helpful. I showed you the entire like process how we can implement RAG. So in the next video, we'll be creating some LLM powered application with the help of this Vertex AI platform. Thank you, guys. Hello everyone, welcome back. So guys, in this video, we'll see how we can implement LLM powered chatbot with the help of Vertex AI. See, I think you already saw how we can set up everything in our local machine. That means if I want to connect with my Vertex AI, so what are the setup actually I can perform. So setup wise, I already covered in my previous video, so you can check it out. So here actually I've already prepared everything, because see, most of the code are similar, whatever things we implemented previously. So make sure first of all you configured everything, your account, then your, let's say, configuration, everything you just prepared. After that, in the env file, just try to change this project ID and region. So let me copy my project ID. So just try to click here. So this is my project ID, guys. Just try to copy, and let's mention it here. Okay, and region, I'm inside US Central 1 only, and you don't need to change it. Now the next thing, you have to create an environment. How to create the environment, I already told you. Okay, I'm using the same environment, Vertex AI demo. Now you have to install the requirement. So one more requirement I've added called Flask. So let me install the Flask, because in this project I'm going to use Flask. Okay, Flask framework to create the front-end application. So for this, just write this command, pip install -add requirement.txt. Now it should install the requirements. So guys, many people were asking me how to install actually GPU, NVIDIA GPU in our local system. For this, what I did actually, I created one video in my YouTube channel. Let me show you. So if you go to my YouTube channel, guys, this is my YouTube channel. You can also subscribe me here. Now, if I go to the video section, so here I already created one video. Here you can see the video, set up NVIDIA GPU. Okay, so here I showed you all these steps you can follow to set up your NVIDIA GPU for the deep learning task. Got it? So let's say if you're having good GPU and if you want to, let's say, execute open source or language model in your local machine instead of using Colab, you can refer this video that time. And make sure, guys, you subscribe to this channel, because here also I create lots of content related generative AI, MLOps, then end-to-end project implementation, okay, computer vision, everything. Now let's get back. So I think installation is completed. Yeah. Now see what I have done. I created one template file, and inside that, this is my HTML code, because you already know if I want to use Flask, I need a HTML, okay, HTML code to create my front-end part. And again, I used a Bootstrap website to prepare this front-end. I'll tell you whenever I'll execute how it will look like. Now, this is my endpoint app.py, and here I've imported all the necessary library. And these code are common. I think you know we are doing the authentication with my Vertex AI. Now this is the route I created. This route is my default route. It will launch my index.html page, and this is my prediction route. That means whenever user will give any query, okay, user input, I'm getting the user input, and this input actually I'm passing to my model, and whatever response actually I'm getting, I'm showing in my Flask server. That's it. Now let me execute the application. So what I will do, I'll run this application in the port number 8080. Save it. Now I'll open up my terminal and let's execute Python app.py. Okay, so it is running. Now let's get back localhost. Now see, this is how your user interface will look like. Now you can give any command. Now here you can give any query. So I'll ask what is Python. Now send a request. You can also see the log in the terminal. See, I got the response. So this is the complete response I got, guys. Got it? This is the complete response I got. Now if you want to ask another query, just try to refresh. Again, you can pass that query. Okay. Now that's how actually what you can do. The previous RAG application we implemented with the help of Vertex AI, you can create your custom RAG. That means you can use your custom documents like we did one project like, I think remember, medical chatbot. So that's how you can use your custom documents and you can create these kinds of application. And this is the front end you can use as it is. Got it? All the HTML code I will share with you. So yes, guys, that's how we can also create LLM-powered application with the help of Vertex AI. So yes, guys, this is all about from this video. Thank you so much. Hi, everyone. Welcome back with another video. So guys, in this video, we'll be learning how we can perform the fine-tuning operation on the Vertex AI. So as I already told you, in the model garden, you are having so many foundation model. And if you want to fine-tune, these are the model. So what are the steps you have to follow? In this video, I'll tell you each and everything. So I think remember previously, whenever we used to do the fine-tuning operation, first of all, we had to download that model in our system. Then I was preparing the data. Then I was fine-tuning these are the model. But here, if you're using these kinds of LLMOps platform, you don't need to download these are the model in your system. So here, what you have to do, you have to use that model endpoint. That means you will be accessing this model through the API, right? That means, first of all, you have to authenticate with the Vertex AI. I think I already told you how to authenticate with the Vertex AI. After that, just give the model ID, which model you want to use. It will automatically hit that model. So here, the only thing you have to do, you have to prepare your data. After that, all the thing would be happening in their server only. Okay. Now, let me tell you the step actually you can follow to perform the fine-tuning operation. So for this, what I will do, guys, I will use the Colab notebook. So I'll open up Colab notebook. You can also use Colab Enterprise. You can also do it from your local machine. It's completely fine. But as of now, we have explored like VS Code. We have also explored like Colab Enterprise. Now let's try to see how we can also use the Colab. Okay, like our Google Colab. So here, let me change my account. So let's say I'm going to use this account. Okay, this account actually I'm going to use. And make sure the account actually you are using for the G Cloud, the same account you have to use in the Google Colab as well. Okay, otherwise you might get some authentication issue. Now what I will do, guys, I'll just create a new notebook here. So let me create a new notebook. Now simply just connect this notebook. And in between, let me show you the fine-tuning step you have to follow. So see, you can follow this blog actually. So this is from actually Google. So Google developer. So they have already given all these steps actually you have to follow to perform the fine-tuning operation. So I already prepared all these steps you have to follow to perform the fine-tuning. Only I will show you one thing from this blog actually, the data format. Okay, so here let me show you the preparation and loading the data. See, if you are fine-tuning on the Vertex AI, you have to prepare your data in the JSON-L format. Okay, see this is the JSON-L format data you can see. So here they have already given one example. Let me open up. So you can see this is the train JSON-L format data, and it is present inside this GitHub. So what you can do from this GitHub actually, see this is the data. You can download this data. Okay, in your system you can download this data. So I've already downloaded. Let me show you. So this is the data. I'll open it with the Notepad++. Now if you open the data, guys, you will see it's a JSON. Okay, JSON structure. That means you will have one key here called input text, and this is the input text, and this is the BBC data, guys. Okay, BBC news data. So in the input text actually they are having the entire news, and they're having another actually key here. Let me show you. Or I can perform the Control F operation. Now here I will just write output underscore text. Now if I find it, now see guys, this is the output text. Okay, so inside output text actually what they are having the summary. Okay, summary of that news. So this is the data actually. That's how actually you have to also prepare your data. If you are having any custom data, what you can do, you can prepare your data with respect to that. That means what I'm trying to say, that means in the JSON file actually the first key will have the input. Okay, input underscore text. Okay, inside input text what you will have the entire story. Okay, entire story, and you will have another actually key called output text. Sorry, output text. Okay, so inside output text you will have the summary. Okay, summary of the entire story. So this is going to be your data format. Okay, that's how actually you can take as much as record you can. Got it? I hope now it is clear, the format. So whatever data actually we are having, try to convert in a JSONL format. And how to convert in a JSONL format? There are so many converter you will see inside Python. Simply you can execute those converter. It will automatically convert your data in a JSONL format. Got it? That is the idea. Now you can ask me, sir, where I will get these kinds of data? I think I already told you now. So you can use Hugging Face Hub actually. So there actually will have like so many kinds of data set. So you can use any kinds of data from the Hugging Face Hub. You can download it and you can convert to the JSONL format. And if you are using your custom data that time, you have to convert everything in a JSONL format. Okay, this is the idea. Okay, you can see the image also. They have already given the data format. So first of all, you have to take the input text. This is the entire BBC news you can see, and this is the output text. That means this is the summary of that story. Okay, this should be your data format. Now, apart from that, they have already given all the steps you can follow. So I've already prepared one notebook. Let me show you what are the things you have to do. Now let me also add this link in the notebook so that you will have the reference later on. So this is the link I have added. Now here, the first thing you have to install some of the library. So here I'm going to install Google Cloud AI Platform because I want to access the Vertex AI, then datasets, then Google Cloud Pipeline Components. Okay, these are the library I have to install one by one. Let me install. So after installing these are the library, you have to restart the kernel. And if you want to restart the kernel, you can use this code snippet actually. See, you can also do it from the UI. Just click on the runtime, restart the runtime. So there is a restart runtime option. Okay, restart the session. Otherwise, you can also execute this line of code. It will also restart your runtime. Okay, now what you have to do, you have to authenticate with your G Cloud account. For this, you can execute this line of code. So here I'm using actually Google Authenticator. With the help of Google Authenticator, actually I will authenticate with my account. Got it? So now let me execute. So it will look for your account. So it will give you one pop-up screen. Let's give the allow permission. Select your account. Let's say I want to use this account because this is my Google account. Now I'll try to select it. Now you have to provide the password. So guys, as you can see, my authentication is completed. There is no error. That means you are successfully authenticated with your this one, your G Cloud account. Fine. All right. Now the next thing, you have to select the project. So to select the project, you have to execute this line of code. So let me select the project. So I think you know how to select the project. Click here, copy the project ID, and just try to mention it here. And with this, actually, we'll be initializing our Vertex AI. So let me initialize my Vertex AI. Then let's say set some actually variable. That means my region and the project ID. Again, I'll give the same project ID. Now I have to set one configuration here. For this, you have to execute this line of code. Okay, you have to execute this command. G Cloud config set project. This is the project ID. Okay, the project ID actually I'm having here. Now let me set. Fine. Now let's import some necessary library. So guys, you can see I'm importing some necessary library. Now you can ask me from where actually I got this code. If you go to that blog actually, so they are suggesting install and import. See, they're also importing. These are the library. Okay, so just try to read this blog. Actually, will see all the steps actually they have written. I'm following the same thing only. Now let me import all of the library. Okay, so I have imported all the library. Now the next thing, I will load my data. So let's upload my data. Either you can upload in the G Cloud bucket. So from the bucket also you can download the data. If you're having, let's say, huge data, that time you can keep in the bucket. I think I told you. So it is already having one bucket service as well. So you can also open up the bucket. Inside that you can store any kinds of data and you can also load it here. Okay. So if I show you the bucket, so this is the bucket, guys. So here my data size is not used. So what I will do, I'll directly upload here. So I'll just upload. This is the data. Now with the help of pandas, actually, I'm going to load my data. So now we can copy the path and you can paste it here. Now let's execute. Okay, see, this is the data I have loaded. Now you can see this is the input text and this is the output text. Now if you want to see the shape of the data, you can also see this is the shape of the data. And now we can start the training, and it's like very easy. See, only you just need to execute this line of code. Your training would be started in their server only. Okay, not in my Google Colab actually. It will use their instance. Got it? Now see, here is my fine-tuned model name. So this model name actually I'm giving BBC fine-tuned model. You can give any name. So after fine-tuning, what would be your model name? Okay, that is what you have to give here. Then you can give the pre-trained model. That means which model you want to fine-tune. Here I want to fine-tune text based on 002 model. And if you go to the model garden, you will see this particular model. And if you want to use any other model, you can also give the model ID here. Got it? That's the thing. Now you have to pass the data, that is by DF. The DF actually I got. And you have to set the number of epoch, training epoch you want to, let's say, train. So here I mentioned 100 epoch. Okay, I want to train as of now. And you have to give the tuning job location. Okay, so I have given Europe West 4. You can keep the default size. If you go to the blog, you will see that they are also using this particular location. Now see, if I execute the program, it will give me one URL. And if I click on the URL, I can see the pipeline. That is completely, that means I can see the complete pipeline. My training process is running. And it will take, guys, like 1 to 2 hours to complete the training. But I can't wait 1 to 2 hours. What I will do, I'll stop the execution. So guys, I stopped the execution because it will take time. See, I'm telling you after actually executing this line of code, what you have to do. So you can see one URL. Just try to open up the URL. So this is the URL, guys, and try to make sure you have selected your account. Okay, that GCP account. Then you can see this pipeline. Okay, this pipeline would be running, and this is the jobs. So here you will see all the, let's say, logs. So in the pipeline section, you will see all the logs. That means whether your training is running or not. Okay, and how much time actually it will take to complete. So everything, all the log actually you can see here. Got it? So once this execution is completed, you will see it will automatically stop. After that, your model would be ready. Okay, and then you can use this model. And if you want to delete this pipeline, so what you have to do, guys? So there is a delete button. Just try to click on the delete and try to delete the pipeline. Okay, it will automatically delete the instance. Okay, and guys, one thing, after completing the training, if you open up your bucket, you will see 2 buckets would be automatically created. Okay, and inside this bucket actually it will save all the model checkpoints. Okay, let's say whatever training it is doing, all the artifacts would be saved inside this bucket itself. Okay, you can see. But once you complete the execution, see, it will already save the tuned model. Okay, inside that you can see the text based on model. Got it? So that's how actually it will save all the artifacts in the bucket. And from this bucket itself, we have to deploy our model as an endpoint. Okay, and this model would be available in your model garden. So if you click on the model garden, so there you will see one option. So here is the option, my view my endpoint and model. If you click here, you will see that model will be present here. Okay, I hope it is clear. Now let me show you the next step you have to perform. So previously I already did this actually fine tuning. So let me show you what you have to do after that. See, after that actually what you can do, you can use your trained model. That means the model actually you have trained, and you can do the inference operation. So here I'm giving this actually prompt actually summarize this text to generate a title. So this is the entire actually prompt I'm giving, and this is the output actually I'm getting. Got it? Now you have to deploy your model as an endpoint. For this, you have to execute this line of code. Okay, so this will deploy your model as an endpoint. Okay, to the GCP server. That means this model would be available in your model garden right now. So if I go to the model garden, so here you will see one option, view my endpoint and model. Just click here. In this section actually we'll see your model would be published. Okay, from here actually it will load the model. But what I did actually, I deleted the model because again, I'm using cloud platform. I don't want to keep anything. Okay, otherwise it will charge me. So that's why I already deleted. Okay, then after that, I was loading that model and I was again performing the prediction. You can see this is the result actually I'm getting from my model. Then I was also loading the base model. That means the actual model, and I given the same actually prompt. And I was just checking the actually output. Okay, whether this output and this output actually good or not. That means which model is giving the better output. And here you can see both model giving the good response. Okay, it's not a bad, although I only trained 100 epoch, but you can see this response is pretty good. Got it? So that's how actually you can perform the fine tuning operation. After that, you can deploy your model as an endpoint to the G Cloud. Okay, now I think it is clear. Now you can pick up any other model and you can perform the same fine tuning operation. All right, so these resources would be shared, guys, in your resources section. From there, you can download this notebook and you can perform the fine tuning operation. With that, guys, thank you so much for watching this video, and I will see you next time. Hello, everyone. So, guys, as of now, we have seen the Vertex AI demo, the complete, let's say, Vertex AI demo we have seen. We have implemented different kinds of application with the help of Vertex AI. So now it's time to explore another LLMOps platform called AWS Bedrock. So this service is available in the AWS cloud. So make sure you have the AWS account. So if you don't have the account, just try to create one account. Initially, it will give you $300 free credit, but you have to add your card there. Got it? So after login with your console, so you will get this kinds of window, okay, in the AWS. So this is my console. So now here, what you have to do, you have to search for Bedrock. So let me search. So see, Amazon Bedrock. And this is the service, actually the easiest way to build and scale generative AI application with the foundation model. So let me open up the Bedrock. Now I'll just click on get started. See, if you're opening for the first time this Bedrock, what you have to do, you have to request for the model access. So there is a button you will see, request model access. Just try to click here and see, for me, I already requested the model. Okay, for me, I already requested the model and I got the access. You can see some of the model actually they didn't given me the access. For this, what I have to do, I have to again, let's say resubmit the access request. Then I think I might get. But for you, what you will do, you will select all the model and try to send the request. Okay, send the request. You will see that in 5 to 10 minutes, actually, they will provide the access. Got it? And make sure you check your region, actually, in which region actually you are sending the request. Okay, because that in that region, actually, your model will be available. So I'm currently inside AP South 1, that means Asia Pacific, Mumbai. Okay. So now if I go to any other region, let me show you. So if I, let's say, go to North Virginia, so there you will be able to see I don't have any access of any model. Now see, it will show you this kinds of window, enable all model. Okay, now if I click here, now just select all the model and try to click on the next. Okay, now you have to submit the request. Okay, you have to submit the request. So let's submit the request. Sometimes actually they will ask for some information. So you also need to, let's say, submit some information. Let's say your name, email address. Okay, then you can send the request. After sending the request, in 5 to 10 minutes, you will see that they will give you the model access. So guys, you can see after sending the request, actually I got the access. You can see granted access. And some of the model you can see it is still in progress. So I think it will take some time to give me the access. Okay, so that's how actually you can apply for the access. So once you got the access, that means congratulations. Now you can start with the Bedrock services. That means now you got all the, let's say, access of the foundation model. Now let me get back to my that region, actually Mumbai region. Now see, this is your Bedrock interface. If I click on the overview, now you are having different foundation model here. And what is foundation model? I already told you these are large language model, and different companies also has collaborated with the AWS. Even they have also published their model. Like you can see Amazon is having their own model. Apart from that, Cloudy has like updated their model. Then Cohere, Llama, Mistral. Okay, so you can see all the provider. Okay, all the provider, they have collaborated with the AWS and they hosted their model on the AWS. That means AWS Bedrock. Okay, now what you can do, you can access this the model through API. Got it? So you don't need to download this at the model in your system. That is the main advantage here. Now you can also play with the playground. Let's say if I click on the chat, so here is the chat, guys. So you can select the model. Let's say I want to select this model. Let's say I'll select this Llama 3 8 billion instruct model. Now if I send any request, let's say hello. Let's say this is my prompt. Now see, it is giving me the answer. So that's how actually it is having different kinds of playground, text playground, chat playground, image playground, because it is also having multi-model as well. So you can see here different model. Let's say you want to use this Amazon model. So just try to click here. See all kinds of Amazon model you will be able to see. It is having Titan text G1 Lite, Titan text G1 Express, okay, Titan image generator, then Titan multi-model embeddings. Now if you want to use, let's say, this model, what you can do, you need to just copy the model ID. So this is the model ID, and with the help of model ID you can use it. Similar wise for the meta also, let's say you want to access Llama, okay, Llama model, you can see. So for this you have to use this model ID. Okay, even from here also you can directly open in the playground, and you can also play with these at the model. Even if you go to the example section, they have given different example. Even you can also copy these at the code and you can execute in your system. Now let's click on the base model. You can see different kinds of base model it is also having. Even if you want to train your custom model, it is also possible. Just go to the custom model. You can also perform the fine-tuning operation. So from the UI itself, you can do the fine-tuning operation. Even let's say after fine-tuning, you can also keep your model here, okay, in the custom model section, so that you can load this model as an API. Okay, every functionality actually this Bedrock will give you, so you can use them. So yes, this is the overview of our Amazon Bedrock. That means it's a platform. It's a LLMOps platform. Here we are having different kinds of foundation model. Even all the functionality it is also provides. With the help of these are the functionality you can create any kinds of GenAI based application. So in the next video, what we'll do, guys, we'll just try to do the hands-on on this AWS Bedrock. That means we'll be accessing, these are the foundation model through the Python. Okay, Python code. That is the agenda. With that, guys, thank you so much for watching this video, and I will see you next time. Hi everyone, welcome back. So guys, in this video, we'll be learning how we can, let's say, access this kinds of foundation model with our Python code. That means we'll be setting everything in our local machine. I will be writing everything from our VS Code. Okay, so what I will do, guys, I'll open up my local folder, and here I've already created one empty folder. Let me open up my VS Code. Okay, so I'm also going to open up my terminal here, and make sure you create one environment. So for me, I already created one environment, so let me activate. So conda activate LLM app. I think you remember this environment we created previously, so I'm using the same environment here, and you can see the Python version I'm using, it's 3.10. So you can use 3.9, 3.8, it's up to you. Okay, here the first thing you have to set up the requirements. So let me create a file called requirements.txt. Inside that, let me mention all the requirements actually I need. So I need the LangChain. Then I also need Streamlit, because I'm going to create a small, let's say, user interface here. And I need two more library, Boto3 and Python.env. Python.env, I think you know why we need it, because we're going to create one .env file. Okay, .env file. So inside that, you have to mention the your secret credential. That means we'll be generating access key, AWS access key, and AWS secret access key. With the help of that, we'll be authenticating with our AWS account. Got it? So we'll be keeping these are the key inside this .env file, and to load it, I need this Python.env. And what is Boto3? See, with the help of Boto3 Python package, we'll be making the connection with our AWS. Okay, so this library will give you the functionality you can connect with your AWS. Now let me set up everything in my environment. So I'll open it up and just write pip install requirement.txt. Okay, for me it is already installed. For you, it will take some time. Now the next thing what I have to do, guys, I have to create a IAM user. So let's go to my AWS. I'll go to the home page, and here you will see, or you can also search IAM. Okay, Identity Access Management, because I have to create a user, and there actually I will only give the permission related my Bedrock. Now click on the user. Now just create a user here. I'll give, let's say, Bedrock test attach policy. Now search for Bedrock. I want to give the Bedrock, Amazon Bedrock full access. Now click on the next and create the user. Then after that, I will click on Bedrock test and go to the security credential. And here you will get one option, create access key. Just try to click here. Select command line interface. I understand, and click on the next. Now create the access key. Now, so guys, this is your access key, and this is your secret access key. Now you can also download as a CSV file. Let me download. Now I have to configure it. So for this, you have to install one tool actually. So just search for AWS CLI. Okay, AWS CLI. This is the first website you can open. So for all the operating system, they have mentioned, okay, how we can install it. For Linux, Mac OS, okay, see, Linux, you have to execute some of the command. These are the command you have to execute. For Mac OS also, you have to execute some of the command. And for Windows, you are having one MSI file. So you can directly download this MSI file, and you can install, okay, as a software. That means the way you usually install any software. Now next, install, you have to do the same thing. After doing it, let me cancel it because I already have. After doing it, just try to open up your terminal, okay, and execute this command, AWS configure. AWS configure. Now see, if I execute, it should give you this kinds of window. If you're getting this kinds of window, that means your installation is fine. Now what I have to do, guys, I have to set these are the access key. Now let's try to copy the access key. Open the terminal, and it is asking for the access key. Just try to paste. Just right click, it will paste, and press enter. Then you have to give the secret access key. Just try to copy. This is my secret access key, and I will paste it here. And don't share, guys, this key with anyone. Otherwise, they will be also accessing your account. I will delete it after the recording. And now it is asking for the region. Now you can see which region you are in. I'm inside Mumbai. That means AP South 1. So I have to give the region. So you just check which region you are working on. Based on that, you can decide. So AP South 1. Now default output format, just keep it empty. Press enter. That's it. See, my credential has been set. So this was the first method. And the second method, what you can do, you can, I think you remember we created this .env file. So here, inside .env file also you can mention. So let me show you. So inside that you can mention AWS access key ID, secret key ID, and region name. So let me replace all of the secret key again. This is my access key ID. And this is my secret access key. And AP South one, it's fine. Now let me save. Now here I'm going to create a file. I'll name it as main.py. Inside that I'm going to do the coding. So here, first of all, let's import some libraries. So these are the library I need. Let me select my environment, LLM app I'm using. Now here you can see, guys, I'm importing Bedrock from LangChain. LangChain.llms Bedrock. I'm importing Bedrock. Then LLM chain, then prompt template, Boto3, and Streamlit. Okay. Then I need another package, this one actually, .env, because I want to load these at the credential. And how to load, guys, I think you remember. So you have to use this code snippet. So load env, and you also need operating system. With the help of operating system, we'll be loading these are the key, okay, from the environment variable. Now here it will store everything. Now, if I want to initialize Bedrock client, so I have to use Boto3. So this is the syntax. If you go to the documentation, you will see that they're using this syntax. Bedrock client, you have to make a Bedrock client. The Boto3 client, you have to mention the service name. I want to use Bedrock. Okay, Bedrock services. That's why I've given Bedrock runtime. You have to give the region, AWS access key ID, and secret key ID. So with the help of that, it will authenticate with your account. Okay, I hope it is clear. Now, the next thing, you have to give the model ID, like which model you want to access. I'll give the model ID is equal to, let's say I want to use one foundation model. Let's say I want to use this Mistral model. I'll click on Mistral. Now you can see Mistral having different variants, 7B, 8X, 7B, then Mistral large. Now let's say I want to use 7B instruct. So what I will do, I'll copy this model ID. So that's how, just try to open any kinds of model and copy the model ID. And here you just need to mention it. That's it. Okay, so it will automatically load this model. Now let's create our LLM wrapper. So inside Bedrock, you have to give the model ID. Okay, and here you have to give the Bedrock client. Okay, client is equal to Bedrock. Fine. And this is the temperature parameter. That means the creativity parameter. I think you already know. Now here I'm going to create a function. So this function will take the input from the user, like in which language they want to, let's say, get the output, and what is the input prompt. Okay, so this function will take this input, you can see language as well as the user text. Then it is create. Then inside that I'm creating a prompt template. I think you know what is prompt template, right? So this is the input variable, language and user text, and I'm creating a prompt template. You are a chatbot and you are in this language and this user text. Now based on that, you have to give me the response. Now here I'm creating a LLM chain and I'm passing my LLM as well as the prompt. And finally, I'm passing my language as well as the user input to my Bedrock chain. That means the chain I actually have created. Okay, because inside that I'm having my large language model as well as the prompt. And whatever response I'm getting, I'm just returning. That's it. Now let me create a Streamlit title. Streamlit, let's say user interface, Bedrock chatbot demo. Now user will also able to give the language. So let's say here I'll take a language input from the user. Whether he want to get English response, Spanish response, or Hindi response, you can. So here you can also pass any other language. It will also work, because I think you know these kinds of large language model can also support multi-language. Then this is my final logic. So if language is there, so they will give the input. That means what kinds of question they want to ask. Then once they have, let's say, given the prompt, this particular prompt I'm checking, first of all, this they have given the prompt or not. If they have given, I'm passing it to my chatbot. You can see this function. So it will take the language as well as the user input. Language and user input, and whatever response actually I'm getting, I'm writing in my Streamlit application. Now let me execute and let me show you. I'll save it. Now simply I'll just open up my terminal, and this is the command Streamlit run main.py. So this is the interface, guys. Now you can select the language. Let's say I want to select the English. Now here I can ask any query. Let's say, what is Python? Now you just need to press shift, you just need to press Ctrl and enter. So guys, as you can see, if you give any kinds of prompt, now here is the response. So here I've given what is Python, and here is the response I got. Now I can ask any kinds of query. Let's say I will ask, give me a Python code to add two numbers. See, here I got the Python code to add the two numbers. Okay, so that's how you can pass any kinds of prompt and you can get the response. It's amazing, guys. And here we're using Mistral model. Okay, Mistral model we are using. Okay, and it is present inside Bedrock platform. That's why this inference time is very low. You will see that I'm getting very fast response. But whenever I was using Mistral model, I think you remember in Hugging Face. Okay, Hugging Face Hub. So there I had to download this model in my system, and the execution time was like very slow there. Yes or no, right? So that's why we have to use this kinds of LLMOps platform if I'm implementing any kinds of project, efficient project, okay, in the industry. So yes, guys, now you can explore different kinds of model, different kinds of like foundation model. You can also explore query model, meta model, anything you can explore. Only just need to keep the model ID and everything you can access. Got it? So yes, guys, I hope it is clear now how we can use this Bedrock platform. And if you want to get this kinds of content more, so please try to support our channel. So please try to subscribe to the channel, try to share this kinds of content with your friends and family so that they can also get to know, okay, this kinds of session is going on. So please try to support the channel, guys. Try to like the video, try to subscribe to the channel. You can subscribe to the Code Commander channel. Even you can also subscribe to my channel, DS with Bappy. Okay, both channel actually I'm operating. You will see that in both channel I'm creating lots of content related data science, machine learning, generative AI, MLOps, okay, end-to-end project implementation, okay, everything I'm creating the content. So yes, guys, this is all about. I hope you liked it. So thank you so much, guys, for watching this video, and I will see you next time.
So here what will happen, let's say day by day, actually whatever activity you are doing, let's say you are doing any meetings, then you are scheduling any kinds of, let's say, plan. So whatever let's say you are doing, you can collect some data. Okay, you can get some data. Let's say you have some meeting data, you have your reminder, whatever daily task you usually do, you have some documents here. Okay, you have some custom documents. So what you can do, you can build a rag on top of that. Let's say you don't remember what is your, let's say, reminder today, or let's say what is your task for tomorrow. So what you can do, you can ask to your personal productivity assistant, and this assistant will try to suggest you, let's say, tomorrow what are the schedule you have, what are the plan you have, everything it will try to give you the answer. Or let's say you have done one meetings, in the meeting so many discussion what happened, okay, but you don't remember all of them. What you can do, you can collect the meeting transcript and you can get the data, okay, and you can also integrate the rag with that. So what is the architecture? So first of all, let's say we have the custom documents. So first of all, what we'll do, we'll try to create a chunks. Okay, we'll try to create a chunks, because you know that LLM has some input limitation. So that's why we have to create the chunks. We can't pass the entire data to the large language models. Chunks will give you different small kinds of chunks, and these chunks will try to convert it to the vector embedding. So here we'll be using one embedding model. Embedding model. So in case you can use any embedding model, you can use OpenAI embedding model. You can also use some Hugging Face embedding model. No issue with that. So here I'll be using OpenAI embedding model. So after getting the embedding model, what we'll do, guys, we'll try to generate the vector embedding. Vector embedding. And this vector embedding, we have to store somewhere to perform the retrieval operation. So we'll be using vector database here. Vector database. And in case we'll be using ChromaDB. You can also use Fires, then you can also use Web8, Pinecone. No issue with that. And this is going to be my knowledge base. Okay, knowledge base. Fine, that means first of all we have the documents, then we'll be creating the chunks, and this particular chunks, what we'll do, we'll try to generate, we'll be using the embedding model, then we'll be creating the vector embedding, we'll store in the knowledge base. Okay, that means in the vector database. Now if anyone is asking any kinds of query, let's say this is the user, let's say user is asking one query, and this retriever will give you some retrieve output. Okay, retrieve output, that means some rank results, ranked results. Okay,
So here you have one parameter called k. Let's say k is equal to 3. It will give you 3 relevant answer. But this answer is not readable. What we have to do? We have to use LLM, large language model. And we'll pass the response to the large language model. Also, this query will pass to the large language model. And large language model will give you the actual response. Actual response, okay? By referring your knowledge base. That means the retrieve output, okay? Whatever you are giving. That means what we are doing, let's say this is your LLM. So here you are passing the context, okay? Also you are passing the query. So LLM will try to refer the context, okay? Let's say the context is about Python, okay? And you have, let's say, asked one question. Let's say what is Python. First of all, it will refer the context, then it will give you the query, okay? So just you can consider, let's say if I'm giving you 10 different cat books, and if I tell you what is cat, so first of all you will be reading about the cat. You have enough amount of context right now regarding the cat, then you will be able to give me the response, okay? So this is what actually we are doing. So we are creating the knowledge base. This knowledge base we are passing as a context to the LLM, and whatever question user is asking, okay, it will try to return. Apart from the question, if you are also asking anything, let's say hi, how are you, and all, this will also give you the response with respect to that. So this is the entire system, guys, will try to develop. Now to implement the system, what are the technology we're going to use? First of all, let me write here. See, for the front end part, front end of our application, we'll be using Flask. So we'll be creating a web application with the help of Flask, okay? For the backend, we'll be using Python and LangChain. For database wise, that's a vector database, we'll be using PromaDB. Then LLM wise, we'll be using GPT. Okay, GPT-4 will be using. You can also use GPT 3.5 and all. And for this, we'll be using OpenAI. And for environment credential, we'll be using python.env. Python.env. Okay, with the help of that, we'll try to load the OpenAI secret, or let's say any other secret you're mentioning, we'll try to load it. And whenever we'll try to deploy the project, we also need to download the env file. For this, we'll be using gdown. Okay, so with the help of gdown, you can download anything from the Google Drive. That means we'll be keeping this .env file in the Google Drive, and from there we'll try to download, because you know that we can't directly, okay, upload any kinds of env file in the GitHub. Okay, GitHub will give you the issue. So for this, we'll be getting the env file from the Google Drive itself. Okay, this is the idea. I'll tell you, okay, whatever things I'm talking about, I'll tell you in practical. Definitely you will be able to understand. Okay, great. And to deploy this project, we'll be using CI/CD approach. Deployment, we'll be using CI/CD approach. So here we'll be using CI/CD. That is continuous integration, continuous delivery. So here what will happen, if you are uploading your code, to the GitHub, okay, GitHub will automatically trigger the CI/CD pipeline, okay, CI/CD pipeline, and this application will deploy over the AWS cloud. Okay, AWS cloud. This is the entire pipeline we'll be implementing. And for this, we'll be using some service, like we'll be using AWS, we'll be using ECR, Elastic Container Registry, we'll be using Docker. Okay, Docker for containerization. Okay, we'll be creating the Docker image. Then we'll be using IAM service for the this one, access management. And here we'll be using GitHub, okay, to perform the code management, and we'll be using GitHub Action for the CI/CD tool. So these are the service, guys, we'll be using, okay, one by one. And what will be the project folder structure? So folder structure wise, here we'll be creating a backend folder. Inside backend, we'll keep some backend file, like we'll be keeping the data ingest data. So this will create the this one. It will load the documents. It will create the vector embedding, and it will save as a this one database file. So this particular file we'll try to create ingest data.py. Then we'll be creating another file called model.py. So this will load the model as well as the this vector store object, and it will return you the retriever. Okay. Then apart from that, we'll be also creating a file called static. So inside static, we'll keep the Flask related code. So it will have the style.css. So here we'll create a basics UI user interface. So for this we need CSS code, and we also need a app.js file, okay, JavaScript file, because if you are using CSS and HTML, so you also need this JS file. And if you are not familiar with this kinds of HTML, CSS, no need to worry. Okay, you can get this kinds of code over the internet. There are so many template provider, you can already download from there. Okay, then we'll be creating another folder called template. So inside template, we'll try to keep a file called index.html. Okay, so this index.html will contain the user interface structure, like how you are going to create the front end part. So that HTML code we'll try to write here. Then I think I can write it here. We'll create a env file. Inside that we'll keep the credential. Then we'll try to create our endpoint called app.py. Then we'll create a Docker file here, because we'll try to create the Docker image, containerize our application. That's why we need it. Then we need a requirement.txt, requirements.txt. Okay, txt file. And apart from that, for the deployment, we need .github folder. Okay, I'll show you whenever we'll try to do the deployment. That time I'll show you what are the folders and files you need. As of now, this is the folder structure we'll try to create, guys. Okay, and before that, let me create a GitHub repository. Then we'll try to create all the files one by one. And open up your GitHub account. Make sure you have the GitHub account. And here click on new repository. You can give the name. So here I'll give the name as personal productivity assistant. I'll keep it as public repo. Okay, and add readme file. Git ignore wise, I'll be taking Python. License wise, let's take the MIT license. I think everything is fine. Let's create the repo right now. Okay, so once it is done, let's click on the code, copy the link address, open up your local folder. So this is my local folder. So here I'm going to open up my terminal. Now let's clone the repo. So git clone. Let's paste the link. So it will clone the repo. Now I need to go inside that. So cd personal productivity assistant. Okay, now I'm inside this folder. Now here I'm going to open up my Visual Code Studio. You can also use PyCharm, Sublime Text. It's up to you. So the first thing, guys, what we have to do the environment setup and requirement installation. For this, let's write the command in the readme file. So I already prepared the command. What are the command you have to execute? Yeah, so let me just mention it here. So you can see, first of all, you have to clone my repository. Then after that, you have to create the environment. This is the command conda create -m agent app python is equal to 3.12-y. So here we'll be using 3.12 Python version. Then after that, you have to activate the environment. Then you have to install the requirements. Okay. Now you can ask me what is the requirement file. I'll try to create the requirement file. No need to worry. Then once it is done, all the setup is done. Then you have to execute the endpoint, which is nothing but your app.py. But as of now, we haven't created the app.py. You can ignore this part. So these are the command, guys, you have to execute. So for me, I already created the environment, so I'm not going to execute this command. But for you, you have to execute the command. So let me activate my environment. So I'll open up my terminal, and if I just write conda activate agent app, you can see agent has been activated. Now let's create all the folder structure one by one. So first of all, so here I'll create a file called template.py. So with the help of this template.py, we'll try to create the folder structure in automated way. So for this, I have written a Python script. Let me show you. So this is my Python script. So here I only need to modify. These are the folders and file. I think those who have seen my implementation, I follow the same template.py. I follow the same logic to create my folder structure. Okay. All right. So now let's do some modification in the file. So I don't need the project name. This thing I don't need. So instead of that, what we'll do, we'll try to update the folders and file in the list of the files. That means inside this particular list. Okay. So first of all, I need a backend folder. So here, what I will do, here I'll just write a backend folder. Backend folder. Okay. And inside backend, I'll create two files. One is the ingestdata.py. So let me delete all the file. Params I don't need. Main I also don't need. And the if string is not required. I can also remove it. Yeah. Requirement I need. Setup.py I don't need. Resource I also don't need. Templates I need. Okay. Yeah. And .github I need because we'll be doing the CI/CD deployment. For this we need this particular file. Okay. Yeah. So first of all, I'll be creating a ingestdata.py file in the backend folder, and I'm also going to create another file called model.py. Okay. Then after that, we'll try to create a static folder here. So let me just write here. I'll name it as static. Okay. Inside static, I'll create a app.js file. Then we'll create another file called style.css. Style.css. Okay. Then what we'll do, a template I think I already created, index.html, because if you're using Flask, I think you know that you have to create the templates file. Inside that you have to create the index.html. Okay, that is what we are doing. Then we'll be creating a .env file here. .env. Then apart from that, I need a Docker file. Then requirement.txt and template. Okay, yeah. So yes, these are the files and folder I need. If you need anything later on, I'll try to create. Now try to save, and this is the logic. So first of all, I'm looping through the list. Then I'm actually converting to the path, because here we are using Windows machine, and Windows use backward slash. And if you want to convert it to the backward slash, you have to use the path library. Okay, it will automatically detect your operating system. Based on that, it will convert that part. Then I'm separating out my folder, file directory and file name. So you can see this is the file directory and this is the file name. And with the help of path.split, actually we are doing that. So folder directory will be stored in the file directory, and file name will be stored in the file name. Then after that, first of all, I'm creating the file directory. Okay, with the help of os.make directories. Okay, this is the code. Then after that, we are creating the files. You can see I'm opening the files and we are creating that empty file. And then if anything is exist, I'm logging the information. This file is already exist. Okay, and for this we are using login module. So now let's execute the file. So what I will do, I will execute my template.py. Now see, there is nothing right now. And if I execute this file, okay, this template.py, automatically the folder structure would be created. So template.py. Now guys, see, left hand side, automatically the folder structure has been created. Okay, so that's why I use this particular approach. Now let's say in future you want to create another file. Let's say you want to create test.py. Simply just try to add and execute it. See, automatically this would be created. Okay, you don't need to manually create it. Otherwise, what we have to do, we have to use this icon and we have to create it manually. First of all, this folder we have to create, then inside that we have to create, these are the files. Okay, so it's a like hard to create. Okay, it will take lots of time, so we are not going to follow that approach. Okay, so that's why we have followed the template.py approach. Now this is created. Now what I will do, I'll try to commit this code to my GitHub. So for this, let's clear my terminal. Now I'll just write git add, now git commit. So you have to write a commit message -m. So I'll just write folder structure added, then git push origin main. Okay, because this is the main branch. You can check here the repository we have created, it is under main branch. Now let's see, I'll try to commit the code, sorry, push the code. Now see, push is done. Now if I come here and if I refresh, now see, all the folders and file has been committed to my GitHub. Okay, and I also updated a readme file. So anyone can come here and they can copy paste the command and they can execute my application. Okay, now the next thing, we'll try to set up the requirements. Okay, now how to set up the requirements? Let's open up the requirement.txt, and inside that I'll mention all of the requirements you need for this particular project. So the first requirement, you need the Flask, then you need the Flask codes, then you need LangChain is equal to 0.1.20. Okay, this is the specific version we'll be using. Then we need OpenAI. Okay, OpenAI is equal to I need 0.28.0. Okay, this version we'll be using. Then I need ChromaDB. So ChromaDB is equal to, I'll be using 0.4.24. So now you can ask me why we are using this version, because I have implemented the project with this particular version, and I'm mentioning the specific version because after 1 month there is a possibility this package will get updated and we will face the dependency issue. That's why we are using the same version, the version I've used to implement the project. Okay, it's a good practice. Always try to mention the version, the package you are using, because GenAI is the frequent update industry. So every day they are doing new changes in the package. So the project you are running today, there is a possibility this project might not run tomorrow. So that's why it's super important. Then I need python.env. Then I need gdown for the Google Drive. Okay, if I want to download anything from the Google Drive, I need these are the package. Okay, now how to install? So this is the command I mentioned. Now let's open up your terminal. Let's clear it, and I'll install the requirement. So for me it is already satisfied because previously I already installed, but for you it will take some time. See, it's completed. Okay, now let's again commit. So if you want to commit, you can also commit from the VS Code. So you can give the message here. Let's say requirements added. Requirements added. Just a minute. Added. Then click on commit. And if you're doing for the first time, it will ask for the authentication with your GitHub. Just try to authenticate and try to commit. It's done. Okay, now if I get back to my GitHub, refresh. Now see, this is my second commit. Okay, requirements added. Alright guys, so everything is ready. Now we can start the development right now. Okay, fine. So the first file we'll be writing the ingestdata.py. Let me open this particular file and let me import some necessary libraries. So first of all, I'm going to import operating system. Then I'm going to import .env. Okay, import load.env. Then I'm going to import chroma from LangChain. So from LangChain, first of all, let me select my environment. Agent demo. LangChain dot vector store, import chroma. Then I need OpenAI embedding. So from LangChain dot embeddings dot OpenAI, import OpenAI embeddings. Okay, then I need text loader. So from LangChain dot, it is under available inside document loaders. Okay, import text loader. Yeah, this thing I need. Then I need character text splitter because I want to perform the chunking. It is also available in the LangChain. So LangChain dot documents. Sorry, it is under doc store, then documents. Okay, so there is a mistake. I think this is under text splitter. Import character text splitter. Okay, then I also need to import the document. So from LangChain dot doc store dot documents. Okay, import documents. And I also need gdown package. So import gdown. Yeah, everything is done. Now the first thing, we have to write a code. That code will try to download .env file from the Google Drive itself. Okay, see, although I have created the env file, but I want to download it from the Google Drive. So let me show you my Google Drive. See, in the Google Drive, I kept my .env file, and if I open this, let me show you my .env file. See, your .env file will look like that. So it will have the OpenAI API key. Make sure you collected your OpenAI API key and mention it here, and ChromaDB path. So here I've given DB. That means it will create a DB folder name here. Okay, whenever it will create the ChromaDB instance, and ChromaDB is the local vector DB. I think you know that. So this file you can upload where you can upload in the Google Drive. Okay, you have to upload this file in the Google Drive. Okay, and now we'll be writing the code. That code will try to download this file from the Google Drive itself. Okay, and make sure after uploading it to Google Drive, you just give the permission to anyone with the link. So just try to click on share, and this particular permission you have to give anyone with the link. Okay, by default it would be restricted. Okay, just try to make it and click on done. Then after that you have to get the ID. So click on share, copy the link, and this link you can paste here and get the ID. This is the entire link and this is the ID, guys. Okay, so after D, this is the ID. Just try to copy the ID and keep it somewhere, because this ID you need to download that file. Okay, now let me write the code. That code will try to download this file from the Google Drive itself. Okay, so for this I already written a script. Let me show you. This is the script, guys, I have written. Download env file from the G drive. So first of all you have to give the file ID. So that file ID I have given it here. Then this is the URL to download. So this is the URL, and this URL you have to add this file ID. Okay, this file will be downloaded from the Google Drive itself. And what is the output name? Output name I want to keep it .env. Okay, and with the help of gdown.download, I'm downloading this particular file from the URL and with this particular name, and quite is equal to false because it will not show anything in the console. Okay, that's why. Okay, now if you want to test, you can also test whether it's working or not. So what I can do, I can, let's say, remove this file and I can execute this particular file right now. So Python backend, it is inside backend ingest data.py. Now see, it will download the file from the Google Drive itself. See, it's done. Now see, this .env file is available, and again the same credential I have inside that. Okay, because I need it whenever you will be deploying this project over the cloud platform. That time you have to upload your code to the GitHub. Okay, now I can't upload this env file to the GitHub because in the .gitignore you can see this .env is mentioned. .env is mentioned. You can't upload this one. See, okay, so that's why we have to download it from the Google Drive itself during the production server. That is the idea. Now we have to load the env file. Okay, then after that we have to set as a environment variable. Both will try to set the OpenAI API key as well as the ChromaDB path. Okay, both will try to set as an environment. We'll try to load from the environment. Okay, that means from this particular file, and we're storing in the variable itself. Okay, then here I'm going to check a condition. The condition is if not OpenAI API key, it will raise a value error. OpenAI API key is not found. Okay, so these kinds of verification layer you can also add in your code. Okay, so we have added this condition. Now what we'll do, we'll try to load the documents. Now here document wise you can use any kinds of documents. As I already told you, let's say you have done one meeting and you can also get the transcript of the meeting, and you can also load that let's say transcript with the help of LangChain. So if you go to the LangChain data loader, so like LangChain can load all kinds of data. Okay, whether it's a PDF, whether it's a CSV, anything you can load. See, you can load from the web, even you can also load the transcript data. Okay, you can check it is like a huge amount of functionality it has. You can check here. So as of now, just to make this project simple, I'm going to create my custom documents here. So this is the documents I created just to show you, but in case you can use any kinds of documents. This part only you just need to change. Okay, here you can add that data loader part. Let's say you want to load the data from the Figma or let's say Slack. So this is the code. This is the code you can add. You can give the workspace ID. Okay, and you can load the data. You can create the data loader. Now let's say you want to load the data from the Twitter. You can follow that. Let's say you want to load the data from the PDF. You can follow here. Okay, so all the codes are already there. So only just need to replace it here. So here I'm creating my custom documents. I created 3 documents: meeting notes, discuss project X deliverables, okay, then reminder, then upcoming events. Okay, these are the, let's say, dummy things I've just added just to show you, okay, how things are working. But for you, you can load any kinds of file here, any kinds of personal productivity data you can load here. Got it? Then after that, what we have to do, guys, we have to initialize our embedding model, because we have to convert this data to the vector embedding. For this we need an embedding model, and I'm going to use OpenAI embedding model, and here I'm passing the OpenAI API key. Then the second thing, you have to create the chunks, because see, we are following the same architecture. First of all, we have loaded the data, we will be creating the chunks, embedding model. Okay, these are the thing we'll be doing. Now we have to create the chunks. Now how to create the chunks? We can use character text splitter. I think you know that. So this is the code for that. So here I'm using character text splitter. This is my chunk size 200 and chunks overlap 50. Okay. Now what will happen? Let's say you have one huge documents. Let me show you. Let's say you have a documents. Let's say this is your entire documents like that. And chunks size you have mentioned, let's say 200. So it will start from here, 200 token it will count. Let's say 200 what ends here. This is your first chunks. Okay. Then it will start the another chunks. But here you have mentioned the chunks overlap. You can see. Let me show you. We have mentioned the chunks overlap 50. That means what will happen? It will get back 50 words back. Okay. From here it will start the second chunks. It will again count 200 tokens and it will end here. That means this is the first chunks. This is the second chunks. Okay. That's how it will create multiple chunks. Got it? So now let me show you. And here you have to call split documents, and you have to pass the document you have here. So this will return you the chunk. Then after that, we have to store this data. Okay, we have to store this data. After creating the vector embedding, we have to store the data in the vector database. Okay, and we'll be using ChromaDB for that. Now let me show you the implementation. So this is the ChromaDB code. So here you can see I'm using Chroma from documents, and here I'm passing the docs. Okay, here I'm passing the docs. I'm giving the embedding model, and persist directory is equal to ChromaDB path. Okay, the path we have defined per DB database. And once it is created, I'm just launching a message, documents successfully indexed. Okay, now if you want to test whether it's working or not, you can execute the app. So I'll open up my terminal and let me clear. Now let's execute the same file again. So it will create a DB folder. You can see. The DB folder has created, and inside that it has saved all of the vector. See, successfully it is completed, and inside that you can see it is using ChromaDB, and it has stored all the vector. Okay, but you can't see that it is a binary object. You can't visualize that particular vector. Okay, but if you're using Pinecone, there is another vector database. Let me show you, called Pinecone. Pinecone is a paid one. If you want, you can also use it. They have the free plan. Maybe in future I will also show you with the help of Pinecone how to use this. So in the Pinecone you can visualize your vector. Okay, this is the beauty I usually like of the Pinecone. It will store the vector in the cloud platform, not in the local machine. Okay, but let's say you don't want to share your data. That time you can use ChromaDB because it will be available in the local machine. But if you want to share your data, you can store in the cloud. But these are safe website. Okay, it's not like that they will steal your data. It's not like that. Okay, now everything is working fine so far. Now we'll write the model.py file right now. Now what we'll do? Okay, so now let's write this model.py. So in the model.py, what we'll do? We'll try to initialize the model LLM. That means this particular LLM will try to initialize, and the knowledge base we have created, this vector DB object, will try to load as a retriever object. Okay, because whatever user will ask the question, it will go to the retriever. Retriever will try to return the response to the LLM as well as the questions, and LLM will try to give you the response. Okay, this particular functionality will try to write in the model.py. So for this, again, we have to import some necessary library. So let me import all of the library one by one. So these are the necessary library, guys, I need. You can see I'm importing Chroma, then OpenAI embedding, Chat OpenAI. So we're using the OpenAI model. That's why we are importing Chat OpenAI. Then retrieval QA, load QHN, and GDown. Again, we have to add this code, because what will happen if you are writing this code in the app.py, we'll be importing that functionality in the app.py, and sometimes there is a possibility this will execute. Okay, and if you don't have the .env file, it will throw you error. So in the both places we'll try to add this particular code, because whatever file you are executing, first of all it will try to download the env file, and it will use your API key, because here also I'm going to mention the same code, this particular code. Okay, this particular code, and to get this particular code you need the .env file. That's why we are first of all downloading it. Okay, now we'll try to load all the object one by one. First of all, we are loading the embedding model, then we are loading the vector DB. So chroma DB, and this particular directory we are giving, the DB directory we are giving, it will load that particular database object, because inside that I have all of my vector. Then embedding function is equal to embedding. Then this is my retriever, vector DB as retriever. Okay, this retriever we are creating. Now we'll try to initialize the LLM. So here we'll be using GPT-4 model. Okay, you can see. Now we'll try to create the QHN. Okay, QHN, it will take the LLM as well as the chain type is equal to star. Then I'm going to create a function called get response. So in the get response, I'll call the retriever, and this will give you the retrieve output, whatever question user is asking, and this particular output will pass to the QA object, that means to the LLM. LLM will try to return you the actual response. Okay, so this is the code. Now we'll try to add this both functionality to the endpoint. Okay, that means in my app.py. Now let's open the app.py. But before that, we have to complete the static as well as the template. Okay, because to launch the this one Flask app, you need this HTML code as well as the CSS. Okay, these are the things you have to mention. So first of all, let's write the HTML code, and this code I have written with the help of this ChatGPT. With the help of ChatGPT, I have generated this HTML code. It's just a basics, you can say a template. Okay, basics user template. You can also create any kinds of template with the help of ChatGPT. Even it is also available over the internet. You can also download. Then I need the style. So this is just a basics color and style I have added in the CSS file. And to operate this, I need a JS file. Again, you don't need to worry about the front end part. There would be separate team for the front end. This is the basics app I have just created. Okay, great. Now let me now if you have to change the header title, you can also change it here. Okay, now let's create the app.py. Now in the app.py, we'll first of all import some necessary library. So here I'm importing operating system.env, then I'm importing the Flask, then Flask cards, and okay, so here we have imported. Now see here from the backend, you can see I have a file called model.py, and here I created a function called get response. So this get response, I'm importing it here because user will give the query, and this query I have to pass where? I have to pass to the get response, and this query will go to the retriever. Retriever will return the retrieve output, and this thing will try to send to the QHN, and QHN will try to take care with the help of LLM. So yes, now we'll try to load the env as well. So let's load the env. Then one thing I want to do, because see, whenever user will initialize the app, this DB object would be created. And how this DB object will be created? Whenever user is executing this ingest.data.py. But here I'm not going to execute it manually. It should be automated. For this, we'll be executing this command. Wes.system python backend slash app. Sorry, it should not be app.py. It should be ingest.data.py. Ingest.data.py. Sorry. Okay. So this file should be executed. So once this file is executed, that means this DB object would be created, and you will have the knowledge base. Okay. Then we'll try to initialize the Flask. So this is my Flask. Then we'll create a default route. So whenever you'll execute the app, you will get a default route, and this default route will execute index.html page. Now here I'm going to create another route called query. So whenever you will send the query, so this query route will execute. Okay. And it will get the data from the user. That means whatever question user will write in the input box, it will get the data, and we'll try to send the data where to the get response function. Okay, you can see first of all I'm checking if not query, it will raise the exception. Otherwise, it will send the data to the get response function, and this will give you the response. This response I will show to the UI console. Okay, now let's initialize the app. So I'm running the app localhost port number 800, debug is equal to true. Now let me show you the app, how it will look like. First of all, let's delete the DB object. We'll try to create as a new. Now what we'll do, we'll try to open up the terminal. Now let's execute the app, python app.py. Now see, first of all, it will download that .env file, then it will create the DB object automatically. Now see, application is running. Now if I go back and search for localhost port number 800, so guys, you can see this is the user interface we are getting, but the issue is like, if I go to the code, it should be styles.css. Okay, not style, styles.css. Now let me save. Now if I refresh, now see, this is your app. Now here you can give any kinds of question. Let's say if I give hi and submit. Now see, it's thinking. And hello, how I can assist you today. Now you can ask the query. Let's say if I show you my data, so this is my data all about. So here I will ask, what is the reminder? Now see, it is telling the reminder is to submit the report by Friday. Now if I show you the data, now the same thing I have written in the data. Okay, now you can ask anything regarding your personal productivity, whatever data you are using. So this is going to be an amazing app, guys, because I know that there are so many people, they need this kinds of assistant. Now you can use any kinds of meeting transcript and you can implement the entire system. Okay, you can replace the data here. So this is the app, guys. Now it is running on my local host, and you can see it has created all the DB object and everything. It is working fine. Now I'll show you how we can deploy these kinds of app over the cloud platform. That means we'll be deploying over the AWS cloud with the help of CI/CD pipeline. So I already recorded one deployment video of my previous project. So there I created a medical chatbot with the same structure. Okay, same let's say technology. I was also using the Flask there. So the deployment strategy I showed you there, the same thing you have to also follow. Only the thing you have to do, you have to upload your project in your GitHub account. Okay, that's it. And you have to follow the same technique as it is. Okay, so instead of recording the deployment video again, I'll add that particular deployment video here. You can follow the same technique and you can deploy this particular project as a CI/CD. Now first of all, let's commit the code in my GitHub. So I'll click here. Now what I can do, I can ignore this DB object because DB object I don't need. So here I'll, in the git ignore, I'll mention I don't want to push the DB. So DB / start. That means just try to ignore everything inside DB. Now see, DB object is not there. Now let's try to commit. So I'll just write updated. Now commit and save the changes. Now see, pushing is done. Now if I get back and if I refresh my GitHub, now see, everything is up to date. Okay. Now, okay, one thing I forget to tell you, this Docker file. So in the Docker file, you can mention this particular code. Okay. So this let's say command will help you to create a Docker image. So first of all, it will create a it will take a Python 3.12 image. It will install some required tools in the Docker server. Then it will create a working directory called /app. Inside that, it will copy all of the source code. Then it will install requirements. Then it will launch the app.py. Okay, so this is the Docker command you have to use, guys. Now we'll also see like this .github folder. Inside that, you have to create a file called cicd.yaml, and inside that you have to mention some of the command. So in the deployment video, I have mentioned each and everything. I have clarified each and everything. Just try to follow and try to deploy this particular project.
Now we'll try to see the deployment part, like how we can deploy these kinds of projects on the cloud platform. If you want to learn any other cloud deployment, it is also fine. See, the process will remain same, only the cloud functionality would be different. So I'll try to create some more video on the deployment. Like I'll also show you how we can deploy these kinds of project on the GCP cloud, on the, let's say, the Azure cloud. But first of all, let's try to see how we can deploy this project on the AWS cloud. And see, this is not going to be a simple deployment. So here we'll be doing continuous integration and continuous delivery or deployment. That means CI/CD. So I think you have heard of this particular term called CI/CD, right? So we'll be learning how we can deploy this project as a CI/CD. I think you already know how to deploy any machine learning project, deep learning project as CI/CD, but we haven't seen how we can deploy any kinds of generative AI based project as a CI/CD, right? So that's why make sure you are watching this video till the end. So here I'm going to show you each and every step you have to follow. And trust me, if you follow this step, guys, you can use this step to deploy any kinds of, let's say, generative AI based project. Okay, and this is going to be production grade deployment. Okay, so here I'm going to use different kinds of service from the AWS. Even I'll be also using Docker. That means first of all, we'll be Dockerizing the entire source code. Then we'll be deploying this application on the cloud platform. Okay, so make sure you are watching this video till the end. So before starting the deployment, guys, first of all, let me show you what exactly we're gonna perform here. What is CI/CD exactly? Then I will also discuss, let's say, what are the tools and technology we'll be using here, what are the services we'll be using here. Then I will start with the deployment, and make sure you have the AWS account. If you don't have the AWS account, guys, so you won't be able to deploy this project. So first of all, try to create one account. If you're creating for the first time, you will get $300 free credit. Okay, and this is enough for you. So try to create an account, guys. Then you can start with the deployment with me. So let's open up our Blackboard and try to see the architecture overview. So guys, as I already told you, here we'll be doing something called CI/CD deployment, right? And I already told you what is CI/CD full form. It's continuous integration, continuous delivery, or deployment, right? So inside continuous integration, continuous delivery, what happens? Let's say you are the developer. Okay, let's say you are the developer. So what is your task? Your task is to develop a project in the development, let's say, environment. So development environment means like your local system. Let's say you are using your laptop or computer. Let's say local computer. Okay, local computer. Fine. Then what we are doing, I think you remember, we are committing this code to the GitHub, right? We are doing the code management. I think you remember. That means whenever I was adding some new feature, I was pushing this code to the GitHub. Yes or no? Okay, with the help of Git client, we are pushing the code in the GitHub server. Now what happens actually, let's say after deployment. So this is called actually development server, or I can write this is actually development environment. Okay, development environment. So after implementing this project, what we have to do, we have to deploy this project, yes or no? Let's say somehow you have deployed this project on the AWS cloud. Let's say this is your AWS cloud. Fine. So let's say you have deployed this project to the AWS cloud. Manually you just created a, let's say, instance there. You just took a machine there, a EC2 machine, and you manually deployed this project. Now it will give you some endpoint. Okay, endpoint. So with the help of this endpoint, any of the user can access your application. Now let's say after 4 months or let's say 6 months, you want to add some more features in this, let's say, application. Let's say you are deploying medical chatbot. The medical chatbot we implemented, I think you remember, right? Let's say you want to add some more data, you want to add some more knowledge base, and you want to add some more features in this application. Then what you have to do, you have to again develop this, let's say, features in your code. Then what you will be doing, again you will be deploying this application to the AWS cloud. Now just try to see, whenever you are deploying the project for the second time, let's say this is the first time you have deployed, then you are trying to deploy for the second time. Then what you have to do, first of all, you have to stop this application in the AWS. Okay, stop this application. Then you will be uploading your updated code. Then this code will reflect to the endpoint. Then user will able to access that. Now let's say in between, whenever you stop this AWS server, let's say your application, let's say it took 3 hours. It took 3 hours to change the entire source code. That means change the entire features, okay, of your application. So what will happen? 3 hours user won't be able to access your application. So they will come your website and they will see server error. Okay, server error actually they will get. So if user is getting this kinds of experience, so definitely it would be a negative, let's say, effect, okay, on your application. So next time actually they are not going to use your application, yes or no? Let's say if ChatGPT is down for the let's say 3 hours, definitely people will move to the Google Bard or any other, let's say, software, whatever actually we are having. Okay, so now see, ChatGPT is also updating their, let's say, application day by day. But did you ever observe this server is down? No, you are not seeing this server is down, but still they're able to make the changes in their application. How? Because they are following something called CI/CD approach, continuous integration, continuous delivery. That means this application is keep on running, but in the backend they're pushing their source code, they're pushing their, let's say, new features, and this feature is automatically getting updated. Okay, so this is called actually CI/CD. That means you are not going to deploy this application manually. Instead of that, what you have to do, you have to follow the CI/CD. That means what will happen? Let's say you have changed something in your code, you will push the code to the GitHub. Okay, GitHub will automatically let's say deploy your code to the AWS cloud. It will automatically push your code to the AWS cloud, and your endpoint would be automatically updated. Okay, automatically updated, so that if user is using your application, okay, they won't be feeling any kinds of, let's say, server down issue. Okay, server down issue actually they won't be feeling. Got it? So this is what actually we have to do. That means we'll be creating the entire pipeline, entire, let's say, CI/CD pipeline. So we'll be just pushing the code in our GitHub, and GitHub will automatically trigger this action, and my code will update it to the AWS cloud, and AWS will update the endpoint. Okay, now see, the automated process we'll be doing now. Whenever we'll let's say push our code to the GitHub, GitHub will automatically trigger. How it will trigger? For this, you have to use some CI/CD tool. Okay, CI/CD tool, CI/CD automation tool. So here there are different kinds of CI/CD tool. So the first tool you can use something called GitHub Action. Okay, GitHub Action you can use. Then you can use something called Jenkins. Okay, Jenkins. Then you can use something called Circle CI. Circle CI. So these actually three famous tool actually we are having in the market right now. So people are using more this GitHub Action because GitHub Action you don't need to set up anything. It is already set up everything in the GitHub. But if you're using Jenkins and Circle CI, you have to set up this server manually. Okay. So here we'll be using GitHub Action because it is already inbuilt with the GitHub. We don't need to set up anything. Going forward, I will also show you how we can, let's say, use Jenkins, Circle CI. These are the services as well. Fine. So yes, guys, this is the complete high-level architecture of our deployment. Now let's discuss what are the services actually we'll be using for the deployment. See, here the first services actually I'm going to use called Docker. So I think you already know Docker. So Docker is a containerization service. So with the help of that, you can containerize your code. That means, let's say you are having a source code, you can perform the containerization. That means it will create a Docker image for you. Okay. So this image you can, let's say, keep anywhere. Let's say you can keep in the Docker Hub. You can keep, let's say, in the ECR. That means Elastic Container Registry. From there, you can pull the image and you can execute this image. Okay. So if you are using Docker, so you won't be getting any kinds of setup issue. This is the main advantage here. Then we'll be using something called ECR here. ECR. ECR means Elastic Container Registry. So this is the service from the AWS. Okay, AWS giving the service. So here you can store any kinds of Docker image. It is the same like your Docker Hub. Okay, but it is the service from the AWS. You can store the private image there, but in Docker Hub actually all the image would be public. This is the difference only. Now we'll be using another service called EC2. Okay, EC2 is a virtual machine service from the AWS. Again, it is from the AWS. Okay, so this will give you virtual machine. There you can buy, let's say, CPU based machine, GPU based machine. Okay, so all kinds of configuration would be there. So here we are using our local computer. So there we'll be getting a cloud computer. Okay, this is the difference only. Then as a CI/CD tool, I'll be using something called GitHub Action, as I already told you. Okay, we'll be using GitHub Action for the CI/CD management. Fine. So yes, guys, these are the services as of now I'm going to use. So let me show you the deployment step we'll be following. For this, what I have done, guys, I think you remember we implemented one medical chatbot. This is the code, and this code would be also available in your resources section. Even you will also get this code in my GitHub. So guys, this is my GitHub profile. Just search ENT-BAPI in the Google, you will see my GitHub, and here I have created one repository called end-to-end medical chatbot. So I'm going to commit this code here, so you will get all the source code from this repository itself. Okay, and even I will also add the deployment step in the README file. So that is what actually I have written. You can see the entire deployment step I have written here. Now this is the CI/CD deployment we'll be following. So first of all, what I have to do, we have to let's say create a IAM user. Then we'll be creating the EC2 machine ECR. Okay, then we'll be, see, this is the deployment step as of now. Just try to follow the step I'm going to show you. First of all, we'll be building our so here, first of all, we'll be building the Docker image of our source code. That means Docker image we'll be implementing. Then we'll be pushing this Docker image to the ECR. That means Elastic Container Registry to store my Docker image. Then we'll be pulling this image from ECR in the EC2. That means we'll be pulling that image in the EC2 machine in our virtual computer. Then we'll be launching this Docker image in my EC2 machine. And from there, we'll be creating an endpoint. And that endpoint user will be able to access. Okay. And these are the policy I have to give whenever I will be creating the IAM user. Fine. So this is the entire step, guys, I have written. Even I have also given all the command you need to execute here. Now let's start the deployment, guys. But before that, you just need to prepare some of the files. The first file you have to prepare the Docker file. So this file will help you to containerize entire your application. That means it will perform the Dockerization. And these are the Docker command you have to write. So I think you remember we are using Python 3.10. Okay, this Python version. That's why I have taken Python 3.10 slim busted image. Then working directory, it will create a working directory called app. Inside that, it will copy all the source code. Then it will install the requirements. Okay, whatever requirements actually we are having here. Got it? Then it will execute this Python 3 app.py command. So that means my endpoint would be executed. Okay, my application would be running. And make sure before actually deployment, you just store your index. Okay, in the Pinecone. So this is the Pinecone, guys. It is running, and all the vector is already stored here. You can see 7020 actually record is already stored here. So I already executed this file. I think you remember store index. So it will create all the, let's say, vector embedding, and it will store in the Pinecone. Okay, Pinecone vector database. So in this project, I was using Pinecone. I think you remember. Okay, so this should be available here. Got it? So once it is available, now what I have to do, guys, then you can create another file called Docker ignore. Inside Docker ignore, you can mention like some of the file which is not required. Let's say here this file is not required. Let's say I think this file is not required. Generative AI project dot egg info. Okay. So whenever it will perform the, let's say, containerization, that means Dockerization. So I don't need this folder. That time what you can do, you can mention this folder name in the Docker ignore file. It is the same thing as your git ignore. So it is already mentioned inside my git ignore. That's why I haven't mentioned inside my Docker ignore. Docker ignore is completely empty. As of now, I need all the file. That's why I haven't keep anything here. Now let's say if you want to ignore any kinds of file which is not required, that time you can store these other file inside Docker ignore. Okay, that's the thing. Now the next things you have to create. You have to create one folder called .github. Okay, inside that you have to create one folder called workflows. Inside that you have to create one YAML file. You can give any name. Here I have given CICD.YAML. Okay, now see, this is the complete YAML file. So this YAML file will help me to do the CI/CD deployment. Okay, that means here it will be using something called GitHub action. Okay, and GitHub action need this YAML file. So here all the command is already written. So first of all, you will see that it will perform continuous integration. Inside continuous integration, it will authenticate with my AWS account. Okay, then it will log in with my ECR. Then whatever, let's say, Docker image actually will be building, you will push that image to the ECR. Okay, that means Elastic Container Registry. Then your continuous deployment will start. Again, it will authenticate with AWS account. Then it will pull that, let's say, image from your ECR to EC2 machine. Then it will execute it here. And here all the environment variable I have set. You can see -e means this is the environment variable. See, AWS access key, AWS secret key. I'll tell you how to generate these are the key. Then a Pinecone API key, OpenAI API key, everything I have set here. Okay, so these are the thing we'll be reading from the secret. Okay, GitHub secret. I'll tell you how to create the GitHub secret as well. So as of now, just try to remember this is the YAML file you have to use for the CI/CD, and this YAML file you can use as it is. No need to change anything in your other project as well. Okay, that's the thing. Now let's open up our AWS account. So guys, this is my AWS account. I already logged in with my AWS account. So here, so first of all, what you have to do, you have to create a IAM user. So let's create a IAM user. So IAM. So the first thing we'll be creating one user here. So let's create one user. I'll create a user. So let's say username is, I'll give medical bot. You can give any name, it's up to you. So let's click on next. Now you have to give policies. Okay, like what are the policy you want to give in this user? I don't want to give my entire policy. That means all the services I don't want to give the access. So I'll be giving some specific access. So access wise, I already written in the readme file. Let me show you. So these are the access I'll be providing. My EC2 container registry full access and EC2 full access. Okay, these are the thing we'll be giving. So here just search it. So this is the ECR. Okay, ECR Elastic Container Registry full service here I'm giving. So let's select. And after that, again, I can delete it. Then I'll try to copy the next service. This is the service. Okay, this is the EC2 machine service. So again, search here and select the EC2 machine and click on the next. Now see that I have given this two service. Okay. Next thing, just create the user. So right hand side, you can see one button is there, create user. Just click on create user. So guys, as you can see, my user has created. Now I'll click on the user. Then here you will get one option, security credential. Just click here. Then you have to create a access key. So click on create access key, select command line interface. And I understand this above recommendation and click on the next. So there is a next button. Just click on the next. Now create the access key here. Now see guys, this is your access key and secret access key. Try to download as a CSV file. So let's download. So and just keep it with you. Okay, this thing I need later on. Okay, and no need to share this key with anyone. Otherwise they will also access your AWS account. Okay, so here I'm showing because after the recording I'll delete everything. Got it? So my IAM creation is done. Now I'll go back to the home page. Now the next thing what I have to do guys, I have to create a ECR repository to store my Docker image. So let's search for ECR. So just search for ECR. That means Elastic Container Registry. Just open it up and make sure you check your region. In which region you are working. See, I'm working in Mumbai, AP South 1. If you're in other region, just try to note it down. Okay, you have to note it down this syntax actually. AP South 1, then CS Central 1. If you're, let's say, in North Virginia, you have to give US East 1. So just try to remember these are the tag. Okay, so I'm inside Mumbai. That means AP South 1. Now I'll be creating a Elastic Container Registry. So let's create. So let's click there. Now you have to give the name. Let's say I'll give medical chatbot. You can give any name. It's up to you. Everything keep it as default. Now click on next. Now see my repo is created. Now what you have to do, just copy the URI and just try to paste it as of now here because this thing I need later on. Just for reference, I'm saving it here. Okay. That's it. Now what I will do, I will go back again. Now the next thing I have to do, I have to create my EC2 machine. then I have to set up these are the requirements. Okay, that means I have to set up the Docker there. Then I will be also updating that machine. So let's create my EC2 machine right now. So search for EC2 here, EC2 instance. So this is the EC2 service. Now launch the instance. Now select the Ubuntu machine. And what you have to do, give the name of the machine. Let's say medical bot machine. You can give anything. Then see, instance type, you have to take at least 8 GB RAM. 8 GB RAM, just take 8 GB RAM. I'll be taking T2 large, okay, this machine. And then select the key value pair. If you don't have the key value pair, you can also create it. So let's say I'll give medical. So it will create one RSA file. So guys, you can see after creating and download, it will give you one PEM file. So this PEM file you can use. Let's say if you're using any third-party tool to connect with your EC2 machine, let's say Putty or Mobile Extreme, that time you can use this PEM file. But I'm going to launch my, let's say, machine in my second tab with the help of AWS only. I don't need this PEM file, okay? So now I'll select these two options, HTTPS and HTTP. Keep it everything as default. Configuration storage at least take, let's say, 30 GB. And launch the instance right now. So here you can see, click on view all instance. Then see, my machine is running. So if status is running, now click on the machine ID. Now here you have to connect this machine. So click on the connect button. Now I'll be selecting the EC2 connector and let's connect the machine. So it will create a new tab for me. So here I will get one terminal, black terminal. So we have to use this terminal to set up everything here. And this is the production server, guys. Okay, that's how your production server looks like. See, this is the production server. Let me zoom. Now let me clear. See, here you won't be getting any kinds of UI interface. Okay, that means the way we are using our computer, it is having UI. But in the production server, you won't be getting any kinds of UI. You have to work with the terminal always. And this is the Linux terminal I got. This is the Linux machine, guys. So that's why if you know any kinds of Linux command, it will help you a lot. Got it? So here, first of all, I have to update this machine. For this, you have to execute these at the command one by one. So let's copy all the command one by one. Okay, so this is done. Now I'll copy the next command and just try to paste here. Now give yes permission and press enter. Okay, so execution is completed. Now I have to set up the Docker in the EC2 machine. So this is the command you have to run. Copy the next one and execute. Then I will execute this one, then the last command. So we have to add the Docker in the sudo group, okay? Now, if it is running or not, so what you can do, you can execute one command, docker ---- version. So if it is showing the version, that means Docker is installed successfully. Now, we have to set up our self-hosted runner, EC2 as our self-hosted runner. That means we have to connect our GitHub. Okay, you can see this is the GitHub. Now, this is our project GitHub. So this GitHub I have to connect with my AWS. That means whenever user will, whenever let's say developer will push the code in the GitHub, it will automatically get updated to the AWS, okay, AWS cloud. So for this, what I have to do, I have to go to my project. Make sure you committed your repository in your GitHub and go to the settings, okay. Go to the settings. Now here, left hand side, you will see one option called action. Just click on the action, click on the runners. Now create a new self-hosted runner. Now select the Linux machine and you have to execute. These are the commands. So let's copy this command one by one and let me execute here. So it will automatically make the connection with your GitHub. Let me show you. Then the third command. Then fourth command. Now you have to go to the configuration section and copy this command and execute it here. Now see GitHub action, it will automatically connect. Now it will see it has connected to the GitHub. Now it is asking for enter the name of the runner group. I don't want to give anything, press enter. Now it is asking enter the name of the runner. So here you have to give self-hosted. Okay, self-hosted. This is the thing you have to give. If you're giving another thing, it won't be working. Okay, make sure you're giving self-hosted. Now let's press enter. Now keep it everything in default, just press enter again. then again press enter. Now see, it is done. Now the last command we have to execute this one, and you can ignore this one, it is not required. Now see, it would be connected with my GitHub. See, connected to the GitHub, listening for the jobs. Okay, now if I show you, if I come back, and now if I go to the runners, let's say I'll go to the runners. Now see, status should be idle. You can see it is connected. Okay, now the next thing what I have to do, I have to set up all the GitHub secrets. Okay, now let's go back to the secret. So secret variable, click on the action. Now new repository secret. Now give the secret ID. Okay, so for the first ID I have to give AWS access key ID. Just copy and give the key name here. And why we will get the value, I think remember we downloaded one CSV file. So let me open this CSV file. I will open in a Notepad++, and this is my AWS access key ID. I'll copy, and here let me paste it. Then the next one I have to give secret access key ID, copy, and create another new repository secret and give it here. And in the CSV file you will get the next one. See, it is comma separated. So before the comma, this is the AWS key ID, access key ID, and after the comma this is the secret access key ID. So let me copy the secret access key ID and I will paste it here. Okay, now the next thing you have to give AWS default region. So region, I already told you I'm inside Mumbai, that means AP South 1. So I think remember I'm inside AP South 1. See, AP South 1, you have to write it. So let's write AP -South. Okay, -1, AP South 1. Let's try to check AP South 1. AP South 1. Okay, fine. Now let me add it. Now the next thing I have to add my ECR repo. So ECR repo wise, I think you remember we copied one URL. So just try to get this name only. Okay, after .com, just try to get the name and try to mention here. Then the next thing I have to set my Pinecone API key. So let's copy and add it here. And I think I remember in my .env file I had my Pinecone API key. Let's copy. And this is not available inside my GitHub. That's why I'm reading from the GitHub secret. Okay, this is the idea. Now I also need to add my OpenAI secret. Okay, that means OpenAI API key. The last one you can see OpenAI API key. Let's add it. So let's copy the OpenAI API. Here I'm going to paste it. Now let's add the secret. Okay, now see, everything is added. Now let me see anything is left. No, everything I have added. Now what I have to do, I have to push the changes. Okay, but before that, let me get back to my project. Now I'll push the changes. So just try to commit. To commit, just open up your git bash and try to write this command, git add space dot, then git commit -m, let's say CI CD edit, then git push origin main. Now if I go back to my GitHub, now see, if I refresh here, so it will start running my action. Now just go to the action. Now see, my action is running. See, first of all, it is running the continuous integration. So inside continuous integration, first of all, it will authenticate with my AWS ECR, build the Docker image, push it to the ECR. Okay, everything will happen. See, automatically. It's just a one-time setup, guys. Next time, you don't need to set up it. You just need to write the code and push it to the GitHub. Automatically, it will push to the, let's say, AWS server. Okay, now see. So let's wait. Once this execution is completed, I will come back. So guys, as you can see, my continuous integration is completed. Now it is running the continuous deployment. Now what it will do, it will again authenticate with my AWS cloud, and it will pull that image from the ECR to EC2 machine. And if you go to the Elastic Container Registry right now, and if you refresh here, you will see the image. Okay, see, Docker image is been uploaded here. Now see, it is running the deployment. Now see, it is pulling the image. So once it is pulled, then we'll doing the port mapping. We'll create the endpoint, and we can access our application. Let me show you. So guys, as you can see, my execution is completed. That means both integration and deployment is executed. If you're not getting added, that means congratulations, it's done. Now I will go back to my EC2 machine. Okay, Now here in the EC2 machine, you will get one public IP address. Just let me show you. So this is the public IP address. Just try to copy and just try to open it. Okay, now see if I open it up. So it won't be opening because see, my application is running on port number 8080, I think you remember. Okay, so by default port number 8080 is not set. So I have to do the port mapping. So what I have to do, I'll go back, go to the instance. This is my instance. Then I'll go to the security. Okay. Now here you will see one option called security group. Just click here. Now on top you will see edit inbound rules. Okay, just try to click here. Now I'll just add the rules. Custom TCP port number, just give 8080. Just select 000. Okay, and here you will see save rules. Okay, just click on the save rules. That's it. Okay, so rules has been added. Now I'll go to the instance again. I'll open it up. Now I'll copy the public IP address again, and here let me paste. Now you have to give clone port number 8080. Now see if I hit enter, my application should be running. See guys, this is my chatbot is running. Now if I give any message, let's say what is acne? See guys, it is giving me the response. Now see, my application is live right now. So it is already deployed. Now user can use my applications. Now what you can do, you can buy a domain, okay, your custom domain, and you can publish this application to the audience. Okay, now for the second time, let's say you changed anything in the code. Let's say you added some more function. What you have to do, only just need to commit the changes. It will automatically get updated here. Fine. So no need to set up anything from scratch. It's just a one-time setup. Once setup is completed, just try to commit the changes. It will automatically running. Okay. Now you can ask me, if I close this terminal, will it work? Yes, definitely we can close it. Let's say I will close this terminal. Now if I again go to the chatbot, if I refresh, see, still my bot is running. Okay. So that's how guys we can do the CI/CD deployment. Now let me show you how we can terminate all the instance, like whatever instance we created, if you don't want to keep it running, otherwise it will charge you, right? So what I can do, first of all, I will stop the EC2 machine I've created. So select the machine, click on the instance state and terminate. So terminate will delete it. Okay. So it will terminate and delete the instance. Then after that, I also need to delete my ECR. So let's go to the ECR. So first of all, delete the image inside that. Just write the delete command. Now try to select and delete. Okay, then what I have to do, I have to delete the then I will also delete my IAM user. Okay, the IAM user I created. User. Let's select and try to delete it. Medical chatbot I have to write here. So let me copy. And let me delete it. See, everything is deleted. Now nothing will charge you. Okay. So guys, that's how we can perform the deployment. And this is the code. You can use this code as it is. Okay. The code actually have shared. So yes, guys, this is all about, and I hope you liked it. So thanks for watching, guys.